Babae. Babae. Ha?
Hello YouTube, Boss Rino. Welcome to my channel. Dito kami sa 5th floor. Kung natatandaan nyo kung saan nakapwesto kung saan pinosas namin si Balbaliw. Ito si Balbaliw. Balbaliw. Tapos saka si Third Eye. Wala si Third Eye kasi busy siya si Adventure Ducks. So nandito kami. Tapos kakain kami ng street food, isaw, Betamax, etc. So kain na.
Okay, ayan. Simulan na natin. May kanin na ako. Rice. Wow, sarap. Uy, gutom na ako.
Uy, ba't ang dami kong ano? Eh, sabi mo, okay na yan.
Jesus pa.
Paborito ko. Kasi may aking paboritong isaw. Yan.
Sayang si ano. Pero kami ghost ball, baka bigla umilaw dito takbuhan to.
Takbuhan blues.
Mga
tropa, isaw. Wala si Third Eye. Kasi
Famous na siya.
Famous na, iba na.
Iba na kasama eh.
Busy na siya, busy. Sarap po, tingnan niyo naman.
Isaw, ito, isaw, sarap po.
Bel, sarap. Sarap doon no, boy. Sarap ba yan?
Dandahan lang kumain.
Dahan-dahan siya kumain. Takot na nga ako.
Dahil hindi naman na. Baka naman takot dito.
Ay, grabe. Kita ko yung reflection natin dito, tinamang yung salamin ko. Ayun, no?
Takot po. Takot mo, nakakatakot. Sarap.
Ikaw, bibilis ako.
Napagmang kayo.
Betamax.
VHS.
Maybe, ba?
Ay, Betamax yan, si VHS. Diba?
Pare, dito takot siya. Ano eh?
Si Third Eye.
Diba tinanggal niya yung posta sa sobrang takot niya.
Sobrang takot ng hayop na yun.
Nagpapawisan ako.
Hindi, ngayon, grabe. Famous na. Famous.
Kulog dito, yung init eh.
Saka dito yung ano, bakit? Dito yung accurate ko.
Yung? Ay, oo. Accurate, di ba? Accurate yung labas ng gusto.
Doon, tapos isaw. Para talaga isaw doon, para.
Tsaka hindi na itong ano. Maraming pupuso doon.
Ano mo, bakit ito?
Hindi madumi ang ano. Katulad yung ginawa natin, nag-live tayo sa mga tansyan ko.
Ba't malataan mo ba yun pag may pupo?
Diba? Ay, ang hina naman ito ba yun?
Di Yung pinapakaramdam mo yung paligid.
Ayoko na pakalamig na, natakot ako.
Ito pa pa naman. Hindi pa kain na kita.
Init. Tulog ko si dito.
Nagpapawisan nga ako, iwan ng ano?
Manghang.
Ang hang.
Sarap po.
Pwede ito ka, baka hindi kita sa amin ako. Wala na. Ngayon.
Kain po sa mga nakatira dito.
Paano yung barbecue ka, masarap din. Grabe, no? Haunted house, tapos ang pinaka... Uy!
Uy, init.
Uy! Uy!
Tatakutin ko na kayo ng
Grabe!
Grabe mo tama.
Grabe dito ka, hindi yata kita sa camera ko. Gago, naghubad. Ba't naghubad ka?
Mucho, oh. Namamagaw ka, bro.
Sabi ko, magalaw mo yun. Ako na katawan, di ba?
Parang naman Maria.
Pare, sa mga viewers natin yan. Takin na.
Paano?
Ano nga boy?
Kaya yun, hindi ko mabuga yung inakain ko kanina.
Pero dito ka, parang medyo kita ka sa camera namin.
Siyempre, pare gusto ko sumikat ako eh. Hindi sa camera yun, sa camera ko. Dapat.
Sabi ka,
Ay, napakalaki ng katawan nito.
nagulat ako, an.
Pero, yan talaga, may pawis na pawis na po yun. Bigla ako sa'yo, boy. Naghubad ka.
Tak na, pare.
Nabuga ko kaya ito yung kinakain ko kanina dito.
Do or die na to. Kamo. Kumagat ko lang.
Iba talaga pag monetize na.
We're famous.
Parang nakakailang kumain na may nakahubad sa tabi mo.
Bakit?
Naghubad ka.
Pare, gusto ko eh.
Mainit na yan. Really, mainit talaga kaya naghubad siguro.
Ang mga viewers ha. Kailangan, pare, huwag kayong mga mabibigla. Parental guidance. Only for ano.
Parang may nasa ilip mo kanina. Yun ko lang.
Teka.
Kasi dyan yung may nakita sa third eye.
Bumay. Ano?
Dandan lang kayo kumain.
Taka na, bilis ang boy. Nabubuhin ako. Hindi mo kaya na. Naninigat pa yung dibdib ko. Boy, oh.
Ba't gumagano'n?
Pare, something's moving.
Tayo na, makagit ako ba yan, pare?
Ang lupit na ba?
Naghubad ka.
Pare, kailangan.
Pag monetize na, bubuhubad talaga yun.
Wait mo, nakabip na nga naman. Gusto mo, nakabip na nga ako. Gusto mo?
Bawal.
Bawal sa YouTube.
Punta mo ng pasabi, naghubad pa ako.
Nainitan na.
Naginita na ako.
Mainit talaga yun.
Iba talaga pag nag-iinit na.
Oh, ibang init yun.
Ibang init.
Lupit mo ba?
Uy, gumagalaw pa rin eh.
Ang laki tayo naman, ay, nakakabad din.
Kakain mo na ako ang mga ano.
Masalamat daw, wala si resource investigator dyan.
Kundi nasa ako yun.
Kain po.
Ano ba?
Parang ikaw na nakita ko nagbukbang na sa hatin sa house na nakahubad.
Pare, parang matakot ang ngayon ito. Saan ko nakakita na gano'n?
Nabog ako yung kinakain ko kanina. Pagubad ko.
Nagbukbang na kinakain mo.
Kasi ito na kanin, hayop ko.
Ang dami mo papaling dito na grabe, boy.
I'm a lover. Not a blubber.
Ang lupit mo ba?
Kaya tubig, niluhan na.
Tenga, kumakain ba kayong tenga? Tenga.
Tenga nga?
Tenga. Teka.
Boy, sabot ta.
Teka, tinignan ko. Oh, yun.
Nagulat ako kay Bal. Akala ko iangat lang yung ano. Nabugo ko yung kinakain ko.
Pare, yan ang kalupit ko tayo. Ano ba? Kailangan natin kapit sa patalim na. Taka na pare. Saan makakita ng ganyan?
Eh, buwelo sa basurina, parang gusto rin magubad.
Oo, ubad ka rin.
Naiingit ako ah. Di pa pala ako pare.
Kaya parang tawag
Ay, ito, in-order ni Val, oh.
Atay.
Atay.
Pare, wanted daw to, tapos atay.
Hindi, puro laman loob ang kinakain natin.
Laman loob, atay, tenga, isaw.
Ang pare, delikado to. Vampira na ata kasama natin.
Tapos kakain tayo. Maganda kinain natin to sa morgue.
Uy, mahirap yung morgue. Tanga nakakata. Di nakaubad na ako, nakabrief na lang ako niya. Yung morgue na yun.
Iba na Pero ko na siya nakitry topless ba? Na ganyan katagal. Oo, di ko alam kaya niya yun eh. Pakita mo sa amin ako.
Normal ba yun? Namamaga?
Oo, ginagalo.
Namamaga, no?
Ang dami mababasa. Mababasa ang ano.
Subscribe niyo si Bala.
Subscribe nyo, ano nyo na ako. Comment na kayo kung ano gusto nyo kayo.
Hindi ko makagit over, pare. Bigla ka nagubad.
Baka ano, wala na tayong ano, kailangan nyo.
Machete.
Hindi, manot. Manot.
Ang dapat mo ba?
Ano, pare? Okay ba?
Ha?
Oo, good ba? Good ba?
O ba yun? Tawa ko eh. Tawa ko.
Dapat mo.
Kasi malupit talaga. Siyempre, kailangan natin. Pare, ang sarap. Iba yung ano.
Pero sarap, di ba?
Mahirap ngayon kasi hindi natin nakikita kung nasaan yung kasi kung si third day kasi di ba kita natin, alam natin kung
Alam
saan
natin.
patay.
Kasi wala kami nakikita masyado.
Kaya nga nagubad ako, pare, baka may magpakita eh.
Pagbabae.
Ng babae. Ha?
Pwede.
No?
Ang gagawin mo.
Di, papakita ko ng sabihin ko, hindi ka ba natatakot dito?
Ang lupit mo ba?
Pare, makakaana.
Pare, ito lang gumawa niyan.
Pare, mukbang sa haunted house, ang nakubad.
Mamasay makakatawa pa rin.
Wala na. Tawag dito, wala.
Doon or night.
Mamakay na kung mamakay. Di ba?
Parang bumagsak na yun niya.
Ha?
Parang bumagsak. Dahil
Sabi na pa.
Hindi ko kaya, boy. Grabe. Ibang level ka na kaya, boy.
Siyempre.
namonetize lang, oh.
Kung naman kayo lang.
Gago. We're famous.
Taong-taong.
Wala takot ko sa'yo. Takot pa naman ako dito, boy.
Uy, hindi nag-aanap ako multo nga.
Ang gagawin mo sa multo?
Papakitaan ko nga na akong...
Pero biyo tayo. Sabi na tayo.
Sabi na tayo. Diba? Lalo na sa usap mo dito. Parang diba?
Wala ko sa charong balak na pala. Nandaan lang ako, man.
Hindi ko kaya sa bal.
Bakit?
Tama na, hubad pa eh.
Paano? Kailangan daw sabi ng dito eh.
Unexpected din eh, gagawa.
Sabi ng direktor, bumulong sa akin kanina. Makubot ka. Makubot ka.
Sabi sa'yo?
Parang natakot ang ganun.
Ganun ba yun?
Okay, may hindi.
Dami pag nag-explore ka, nakahubad ka na.
Ay, oo, susunod. Gusto mo nakabrief nga lang ako. Texto. Pero pag yung butas ang brief ko, parang mga butas ang brief ko, nakakaya eh. Tama na yung ganito. Tapos na muna tayo.
Parang bigla akong nabusog.
Bakit?
Nakakita ko ng muscle. Nawalan ako ng gana. Ayaw kumain ng may nakakubad sa tabi.
Pare, hindi ko na ba isot eh. Masakit na aking balikat.
Hindi ko alam ka, nagdidiri ako o na mahanga ako.
Mandiri ka na lang.
Boy, kain pa.
Parang sapat tayo.
Boy, hindi inubod mo yung isaw?
Sabi ko sa'yo, masarap ko sa isa.
Parang ano? Wala naman.
Tao kasi pito.
Hindi, dapat. Ano? Tao dito, tao na to. Ako tumawa.
Kaya na pa kung may nararamdaman, natatawa lang ako.
Ako nararamdaman ko, sumasakta naman ang tiyan ko.
Oo, hindi nga.
Hindi, joke lang.
Hirap yun. Sarap to.
Wala yung momentum.
Hindi na ako makahinga. Hindi na ako. Ba't kayo pawis na?
Tama ko ng tawag na pinapagalan yung dede niya.
Hindi ba kaya?
Hindi ko kaya, wala naman dede ganyan.
Talagang ang hirap. Kaya pawis ako tamo yung deep press.
Kaya siya gubay, pawis sa first tayo, tamo, preso siya.
Fresh na ako, hindi ako nagkakawis. Hindi na mo.
Parang pinagubad din tayo na ba, no?
Magubad mo ka mo. Hindi kaya ka.
Parang ano ah,
Parang na... Okay na yun.
parang iba talaga pag famous. No?
Parang siyempre we're famous.
Parang inubos mo yung isaw eh.
Ang gagawa mo, masarap eh.
Hindi mo natin. Parang...
Parang minasigaw. Kaya ko narinig, parang minasigaw.
Yun yung pinapakaramdam mo kanina eh. Natawa lang talaga tayo pero may nagpaparamdam.
Saan?
Paano?
Saan ba? Saan ba? Ganyan ba?
Ito, ghost fighter, mahal.
Parang tagulog eh.
Papakitaan ko ng mga sinata.
Parang tarugo ba?
Ano, gusto mo ka ganun? Ano nga natin?
Hindi kita kaya. Hindi kita kaya.
May nagpaparamdam na sa atin.
Pawis na, gano'n mo. Tapos hindi pawis.
Siyempre pare, fresh ko ako ngayon. Ano pare mo yun?
Wala na ko ng gana sa'yo.
Nag-posing pa ako kung minakita ko, gagawin ko.
Ano pa naman?
Kaya,
Wala, non-stop na naman si Van.
ayop ka.
May nasigaw na kanina, di ba?
Nawala na. Ari, papakitaan ko lang kayo.
Nagpaparamdam lang. Paano may magpaparamdam sa atin kung ganyan lang?
Pare, kaya ako.
Nakabuka ko talaga. Tapos talaga ito. Tuwa ko. Ang kaganito pumukas.
Teka, titignan ko. Papakitaan ko ng biceps ko. Oh,
Ikaw lang, sa radyo ka niya tayo.
Hindi nga.
ewan ko. Mali ko. Kaya.
Bayo kayo, matapos na tayo. Tapos na ako eh.
Ang sarap na ano. Atay.
Atay, puta na.
Half na.
Nabuka ko yung kinakain ko kanina. Nagulat ako. Gubad din pa.
Ay, hindi ko inaasahan yung ginawa mo.
Siyempre, paano yung mag-ganyan mga ano?
Hindi ko lang matutuwa yung mga subscriber ko o ikakahiya kita.
Pare, sabi kasi naman yun, may bumulong sa akin na. Ay, makubad ka.
Sabi mo, ba't ka?
Sabi
Pero,
nila.
ba't?
Sabi nila.
Direktor ko ata yun eh.
Direktor?
Di ba ang dating eh?
Huwag kainin yung ano, Betamax. Oh.
Kasi yun ako nakain ng Betamax. VHS ako eh. At saka CD. DVD. Hindi ka nakain ng Betamax.
Wala yung joke mo, pero yung hubad mo, bakit panalo?
At siyempre.
Ang tapang lang. Tumapang bigla, nagubad mo.
Bigla akong tumapang na gumagod ka.
Tumapang ako.
Oo nga, naghahanap ko ng multo. Dati tumatakbo sa multo to, ngayon naghahanap ko ng multo.
Ang lupit mo ba? Ang dami mag-PM niyan sa'yo.
Nasabi niya na hayop ka ba? Bastos.
Ang daming prepare sa'yo. Anong Gcash mo ba?
Bibilang ka na lang nila.
Yung mga mamasang dyan ba? Yung mga single mom, yung mga mamasang, yung mga OFW. Anong Gcash mo ba? Anong Gcash mo ba? Ang hirap, takot ka, gutom ka,
Natawa ka pa.
natawa ka, tapos busog ka, natawa ka.
Pare, iba eh.
Pawis na pawis kami talaga. Tama, pawis na pawis si Dax.
Ba't iba yung pawis ako hindi ko? Sabi siya, magbad ako eh.
May ano, susunod.
Ano?
Ba't tayo magbubad? Wala naman kaming ganyang katawan.
Ang laki nga ng tiyan ko.
Pag may ganyan na kami,
Nakakayaman, laki ng tiyan ko. Ganyan ang pare niya.
bukas, kumain ka nung kumain. Nakadalawang rice ka na. Oh.
Nag-ano yung comedy, yung takot ko kasi may nakikita ko dyan.
Ay, ngayon nga lang. Boy, nagubad ka lang nung mas kumain ka ba?
Alam mo kasi yung ulam na eh. Nag-ano na.
Tapos na, ubus na yung dalawang kanin niya. Ubus na yung dalawang kanin niya. Kami, dati tayo yung ulam. Dati tayong dalawa na natatapos eh. Siya yung matagal. Nagubad ka. Nagutom.
Ayun ka na sa'yo. Ayun ka na.
Pwede na kung ano doon. Tulungan mo pa.
Oh, pare. Saan ka punta?
Gagalan tapos ako.
Gawala.
Namamagala ako. Busog na ako, boy.
Namamagala talaga yung braso mo.
Siyempre, pare. Saan makakita? Ikaw ano? Ano yung masasabi mo? Iyo. Tama na pare, ang lakas mo ah. Ako hindi ko na kaya, busog na ako. Busog ako, boy.
Yung malakas yung Jax nga, to rice eh.
Ang lupit na mo.
Oo.
Ang lupit mo, pre. Kaya mo to, ayos, ang bilis. Naday mo pa kami.
Diba? Tapos bago kumain niya. Sabi mo niya kanina, boy, nung hindi ka pa nagubad, sabi niya, bagalan niya kumain.
Ano ba? Huwag ganun.
Bagalan niya kumain. Biglang hindi ka pa nagubad ka. Nung nagubad ka, boy,
Napakain na marami.
tulis ka.
Ay, yung ka talaga, Dax.
Binusog mo kami ba? Binusog mo kami?
Uy, paus na paus ako.
Pare, nagubad na ako mainit kasi. Tsaka, baka may mga biktima tayo dito dito. Diba?
Magdamit ka na ba?
Ay, pare, mamaya na. Oh. May t-shirt na. Oo, sinubuso ko na. Tayo ko na po, gusto na ako. Nabugsog ako. Grabe.
Grabe ka ba?
Ayun, iba. Iba ka talaga, boy. Pare. Iba, iba.
Bakit kasama ka kami sa kwarto, boy? Kasama sa kwarto para makita na tetestingin natin yung ano. Para tetestingin natin yung
Yung ano?
nakahubad tapos nag-explore.
Yung?
Nakahubad tapos nag-explore. Pare, prasata mo nga siya. Oh, iba pare. Grabe sa katawan ko. Oh. Grabe pare. Puta ka na, parang Ninja Turtle lang puta.
Teka, bigyan mo naman akong flashlight. Pambihira naman. Wala akong maano. Wala akong flashlight. Paano tayo makapag-ano?
Pare, dyan sa CR oh.
Kung dire-direct din tayo ni Iban magpaganyan ng katawan.
Oo, boy. Tapatan mo nga siya ng flashlight. Oh, bagay, boy. Bagay, boy. Boy, bagay.
Tanggalin mo yung ano.
Bagay.
Yung tanggalin mo yan. Yan. Yun.
Oh, bagay nga, boy. Oh, walang hiya mo. Oh, parang si ano, parang...
Machete.
Si ano?
Manchupo.
Eddie Garcia. Oh, di ba kayo si Eddie Garcia?
Oh, shit.
Yun.
Ba't Eddie Garcia?
Patay na yun. Awa ka na.
Boy, flashlight, wala flashlight.
Wala flashlight.
Wala na to eh.
Oo, palubat na ako. Ano ba may... Ba't nakatutok lang sa akin?
Ay, syempre, titesting natin kung maganda sa camera na nakahubad ka pag nag-i-explore tayo.
Tangin na nga pare, ba kayo?
Lakad ka doon, lakad ka doon. Para makita natin. Di ba? Ako director eh, titignan ko kung maganda. Parang Ninja Turtle yung likod, no? Oh, yun, ang laki. Ba't saan ka takot ako doon, ah? Tara.
Tara, ayoko na. Nakakatakot to. Ako kinikilabutan na dito. Mga tropa, kinikilabutan na ako. Paano lang kami? Ay, matira pa. Sayang yun. Papaano na kami.
Hindi, wag muna. Magtuloy-tuloy mo yung camera mo, boy.
Sige. Teka, babalik ko dito. Babalik ko dito yung camera.
Hindi ba tayo, ano yan?
Oh, shit.
Nag-repairing mo sa akin.
Well, dito ka, bukas mo, boy. Balik ka sa pwesto natin, boy. Boy, balik ka sa pwesto mo. Asan yung tutok mo kagad natin? Kasi,
Nag-repairing?
may gagawin tayo eh.
Ano?
Iba yung mo gagawin. Ako director, di ba? Boy, dito ka. Ano? Pagubad ka lang, ganyan ka lang. Ganyan ka lang. Tapos, boy, dito ka, boy.
Nag-repairing.
Dito ka.
Ano gagawin?
Basta.
Nag-repairing yung file ko. Teka.
Oo nga, sige, yan mo. Tayo ka lang.
Tatak pa naman thank you aking camera.
Baka na kunyari gato. Meron kang gagawin. Kunyari.
Ano? Ano?
Kaya tayo natin siya.
Sige. Ano?
Sa mga, mga flashlight.
Ayan. Ano nga sa?
Ano gagawin?
Ano?
Teka na yan.
Ano nga?
Pwesto ka dito, boy. Tapos pagsaling ka muna ng... Saling ka muna ng...
Soft drinks.
Soft drinks, di ba?
Tapos?
Ikita ka lang. Kita ka ba sa camera mo?
Oo, kita. Bakit?
Kasi mayroon kaya ang box. GoPro! GoPro!
Naka-GoPro na ako.
GoPro! Open. Dahil nagubad ka.
Oh, unboxing.
Uy!
Dahil nagubad ka.
Naka-GoPro ako.
Meron ka ng GoPro na.
May GoPro 9 ako.
Ayun!
Galing sa mga...
Mag-thank you ka naman.
Thank you. Thank you.
Ganun lang?
Papakita ko.
Yun! Oh, thank you.
Thank you. Tapos na, tama.
Yun lang, thank
Thank you
you.
very much sa ating mga subscriber, sumuporta, at maraming salamat at nagka-GoPro na ako.
Yun. Yun, thank you. Thank you. Thank you. Ang mabait ninyo. Thank you.
Tapos na, tama.
Yun lang, thank you.
Thank you very much sa ating mga subscriber, sumuporta, at maraming salamat at nagka-GoPro na ako.
Yun, thank you. Thank you.
Ito, di ba?
Agogo.
Shit. Grabe. Nakakapakit yun.
Okay. Sino mo mo? Bilisan nyo, boy. Bilisan nyo. Boy, bal. Teka. Oh, gago. Creepy ito, boy. Ito may mga salamin, oh. Ganda pala dito, eh. May design pa, oh.
Have you been before?
Uy, bal. Oh, nagloloko na din yung camera niya. Dito daw talaga. Sugat?
Oo, sugat.
Uy,
Shit.
tata.
You're right.
You're right. Kagong. Wala, ang layo nito, boy.
You're right.
Kagong. Wala, ang layo nito, boy. Nire-upload ko lang.
Pwede pala yung re-upload.
Binura ko doon sa isang channel ko, doon ko nilagay. Nakakapagod talaga, no? No?
Nakapagod yun.
Nakakapagod din talaga, bro.
Ang alin?
Explore.
Pag-explore,
Biyahe.
syempre. Wala ba tayong biyahe? Ikaw ang pagod.
Siya pagod.
Explore.
May viewer na tayo isa.
Kasi yung ano mo, tangin na naman eh. Hinuna mo pa yan eh.
Siyempre, titimpla muna ako.
Ayun na, hindi ka na makaka-shoutout, tangin na.
Wash out!
Tanga-tanga ka lang naman din. Ano gagawin ko?
Teka, isi ka lang, Brownie. Brownie!
Ina.
Brownie!
Dami na.
Nakita ka eh, 85 na agad. Oh.
Hello po, Boss Rino! Hello po, shout out!
Aljun Buotan, hello! Meron kaming bisitang walang kwenta!
Andito na tayo.
tayo.
Wash out, Fuji.
Pumunta tayo dito sa
Hi po from
Batangas.
Ito, nakasama namin si Boss Dax.
Dami yan.
Diyan ka magbasa sa phone mo.
How are you, ba? I'm okay,
Para
Glenn.
mabasa mo.
Glenn, I'm okay. How are you? Nagkakano akong kape. Hi po from
Abangan nyo ang aming vlog at may pasabog kami!
May nagpakita ng ano.
Nagpasabog si Bal!
Tumae ako, mga hayop kayo.
Kape.
Steerer pare kailangan mo? Tina.
Ano na lang yung mga creamer.
Ito tata. Kuha ka. Nilagay ko na yung basura eh. Teka, hindi pa ako tapos eh.
Shoutout.
Shout out! Shout out! Shout out! Hi sa inyo, musta?
Sabi ni Janelle.
Saan lakad? Hindi kami naglakad, sumakay kami, mga hayop!
Sabi ni Janelle, shoutout mo naman siya. Sino ba yung Janelle?
Sino yung Janelle yan?
Hindi ko alam eh.
Sabi dito boy, oh. Basahin mo boy, basahin mo.
Ano sabi?
Bal, saan basahin mo?
Shout out! Shout out! Ano? Ano yan?
Sino ba yan?
Ano?
Ito, basahin mo
Yung
yung...
ano na
Basahin.
Ano? Naka-hide? Ano yan? Ano yan?
Ito, basahin po, tangin na naman
Hindi
eh.
ko
Oh.
mabasa boy, ang labo.
Oh, layo.
Taya! Mabisit! When puli kayo mag-explore. Nakapag-explore na po kami.
Shoutout mo si Ponggoy, Bolbas.
Ponggoy!
Pakis daw.
Pakisayo! Hayop!
Sama natin si Ponggoy.
Ay,
Ayaw ba?
delikado si Ponggoy.
Sama
Delikado.
nyo, iwan ako.
Oh! Nagpadala pare oh.
Ay no? Si
Doon ang kapinpin.
Donna.
Kanupi!
Kanupi!
Tanga! Donna Kanupi!
Kanupin.
Hayo!
Shout out!
Wash out! Wash out!
May bisita kami, Dax!
Ayan oh pare, may 5 pounds ka na, puta.
5 pounds.
Pare, ano yan, 68 pesos.
Lalo kong bibigat niya.
Pounds eh.
5 pounds eh.
Pare. Oh, you have earned 5 pounds.
Ano lang iba?
Si Donna.
Donna Kanupin!
Kapinpin na kanupin.
Kanupin. Ako pinasigaw yung hype niya 10 beses. Kapinpin.
Oh, Joanne Bustillos.
Si Joanne.
Oh, yung may type na type kanyan, boy.
Oo.
Hindi ko alam kung bakit ano nakita sa inyo.
Oo. May loves daw, boy. Tawag sa iyo.
My loves ba?
Oo, may loves. Yan pa.
I-shoutout mo lang pala si Donna Kanupin para magpapadala ulit dyan. Tinan mo.
Oo. Ilang pounds ulit yan.
Shoutout mo.
Shout out!
Donna Kanupin.
Donna Kanupin!
Hindi ko alam kung bakit ano nakita.
Oh, may loves daw, boy. Tawag sa iyo.
So sa mga nagtatanong, galing kami, nag-explore kami ngayon.
Malapit na. Makikita nyo yung mga aming pasabog.
Nagbukbang kami.
Ayan. Oh.
Pagod kami. Dapat pupunta pa kami ng Cavyang. Kaya lang hindi natuloy dahil
Sobrang layo.
malayo.
Kulang sa oras.
Wala sa oras.
Next time. Donna Kanupin! Pare ganyan kami mag
Dapat pupunta pa kami ng Cavyang. Sabi ni Green, Boss Rino, umalma si Bungo sa sagot mo about sa tanong kung talaga bang may third eye si Jeff. Hahaha. Kaya mo na umalma siya, ganun talaga.
Ano sabi ba ni Bungo?
Hindi ko din alam.
Eh, hindi ko rin alam eh. Dapat share mo kung ano. Kwento mo sa amin.
Okay lang yun, kahit sino umalma, okay lang sa amin yun, di ba Bal?
Oo.
Tayo na Bal, itapon mo yung kape ko sa kotse, yung kape mo sa kotse ko, tatapon kita sa labas. Punong-puno yung kape eh.
Ewan ko nga ba, ang dami boy. Oo. Ano sabi ba ni Bungo?
Straightin mo yan!
Ang dami yan.
Share mo kung ano. Kwento mo sa amin.
Ginagawa mo.
Nabusog ako sa kinain natin. At tayo nyo, nagbukbang kami ng ano, ng mga isaw.
Oo.
Busog na busog ako. Asan daw si Mike Enriquez, Bal? Sagutin mo nga.
Famous na.
Wala na si
Iniwan na kami.
Oo.
Nagsulo na, may kanyang grupo na.
Nabusog ako sa kinain.
Hayop yan, animal.
Iniwan na tayo.
O, iniwan na kami.
Ba't mo sumaloob nito?
Hindi, tuwan-tuwa nga ako eh.
Sumaloob mo.
Hindi, tuwan-tuwa nga ako eh.
Hindi mo mababasa yan pagka diyan ka tumingin.
Nakikita ko naman.
Pare, ganito uminom ng kape ha.
Huwag mo na raw hanapin yung wala. Sabi ni ano.
Okay, yung Gcash namin sa mga magbibigay para sa explore natin.
Mag-explore kami, pupunta kami Dinagatan, Albay.
Nalaspag na naman.
Wow!
$500!
500!
$500 oh.
Patigulis!
Sabi mo.
Shout out!
Ano, ang pangalan?
Patigulis! Okay, tayo pare, ganyan kalakas. Pare,
Mahina pa nga eh.
pare, grabe nang hina ako doon sa ano, yung inik-ano natin. Ang inaboy ng lambo talaga
Oo
ako.
ba, namulto tayo.
Oo, namulto ako doon. Inaboy, grabe.
Kahapon nag-live ako, naka 900 pesos ako pang explore. Lugi pa.
Boss Bal, bakit?
Oo, kasi-
Si Boss Bal.
Lugi pa. Binigay ko pa yung, binigay ko 1,000 dun sa ano, sa ano ba yun, sa venue.
Oo.
Tapos nagbukbang pa tayo. At least konti na lang.
Oo, tama. Nagdagdag.
Oh, ayun si Donna Kapinpin.
Donna Kanupin! Dahil lang dyan si Dax daw. Panggas!
Panggas ka
Boy,
na,
bigyan mo
boy.
daw panggas.
Dala ka na win!
Bibigyan natin panggas si ano.
Bigyan mo 300. Pasok na yan.
Si
Gilin.
Dak,
May
kasi ang layo.
nagsumbong nga daw bakit daw sagot ni Boss Pino daming problema sa Pilipinas. Even ang problema
Parang tawag ba sa
May nagsumbong nga bakit daw sinagot ni Boss Rino sa dami ng problema sa Pilipinas. Yan pa problema mo. Yung kay Bungo?
Tama!
Inaano kasi, inaano na...
Ano kasi ni Bungo yun? Na content ni Bungo talaga yun.
Hindi, may nag-comment sa akin na ano, na gano'n. Tinanong ko, ang dami ng problema ng Pilipinas, huwag mo nang dagdagan. Okay lang
Nag-comment
yun,
sa'yo?
talaga okay lang yun.
Okay lang yun.
Wala yun.
Pati wag kayo magalit kay Bungo kasi ano yun, content ni Bungo yun.
Oo.
Huwag kayo magalit kay Bungo TV.
Okay lang yun, ayun yun ba noon, may naninita ng mga peke.
Tama. Yun ang ano nyo, makikita nyo mga legit tulad namin. Ha! Kami hindi. Kami talaga impromptu.
Kung sa tingin ni Bungo, walang third eye si Jeff, wala kaming pakialam. Tropa pa rin yun.
Actually talaga walang third eye yung hayop na yun. Fourth eye.
Nakakalaga yung part ay nun.
Nasa tumbong. Nandito yung mata nyo. Kaya.
Kaya pa,
Diba? Tama si Dax. Kaya ka. Kaya nga sinabi ko, parang lakas ang signal mo. Buong buo. Tainang yan.
John Elliot Manalang, shoutout sa'yo.
Nagpadala ka ng magkano?
Nagpadala ng 3,000!
Puta yes! Puta na tayo parang bipol.
3 pesos.
My God!
Sinabi, pinagmalaki pa niya dun eh. Boss, nag-Gcash ako.
hindi, malaking bagay na rin yun.
Malaking
Kung wala
bagay
yun.
yan.
Pare!
Oo.
Oo, malaking bagay yun.
Lakihan mo pa para mas malaking bagay. Puta. Alam mo, maganda yon. Makinig kayo kay Bungo. Maganda dinidebunk niya lahat yung mga peking ghost
Oo,
pal.
alam nyo ba,
Ghost hunter.
parang 7 video ko na rin yun na kay Bungo eh. Bungo TV.
Inano niya?
Pero pinapanood ko tapos, dinidebunk din naman niya talaga.
Oo, okay yun.
Mas maganda yun.
Huwag kayong magalit.
Pitong video mo ang
Itong video
dinibak
ko,
niya.
oo.
Okay lang.
Okay lang
Sinishare ko.
yun.
Sinishare ko, di ba?
Wala naman masama.
Wala
doon.
yun.
Mas maro kasi.
Huwag kayong magalit.
Aware na rin ako na may lalabas sa Bungo TV kasi sa ibang bansa may mga nagde-debunk din talaga. Oo.
Okay lang yun. Wala namang problema.
Wala
dun.
akong problema eh. Kaya
Oo.
kahit anong sabihin ni Bungo TV sa atin,
Oo.
Okay
kasi
lang.
kasi content niya naman yun.
Tama.
Oo.
Kaya maano lang kayo.
Okay lang yun sa amin. Walang problema sa amin yun. Kahit idibang kami na idibang.
Mm.
Ito nga, natataga namin eh.
Kaya nga
Bumuo pa
eh.
kaya.
Siyempre.
Ito, pag bumukha nito, di ba? Tang inabal. Hanggang ngayon, hindi ka pa tapos maglagay ng asukal. Puta kanina pa yan, pati creamer.
Teka, shout out!
O, ano pa
Ang dami
issue?
lang yun ah.
Ang dami na.
Ano nilagay niya? Ang dami maglagay talaga ng natanga yan eh. Yan yata ang sikreto ng ano eh, katawan eh.
Hindi, yan ang sikreto ng pare, tawag doon, hindi ko na alam. Teka!
O, hintayin nyo ang aming mukbang, may pasabog si Bal.
Oh!
Surprise yun.
Surprise!
Napasuray ako dun.
Ay, sorry boy.
Gago!
Sorry boy.
Tapos ngayon, sasabihan mo ako.
Buti may tissue.
Ultimate issue, gago ka.
Kasi lagyan mo ng takip.
Alam mo, sumisip-sip ako, wag mo ako itulak.
Hindi ko maalam mo si Misip. Buti may tissue.
Oo, kung wala.
Kundi na pa-leather ko bukas doon.
Bobo!
Buti may tissue. tissue.
Buti sinalo na tissue,
Kaya
tanga.
nga, lagyan mo kasi ng
Ayan ba,
takip.
nabasa, oh. Ayan, oh. Ayan, oh, ayan, oh. Ayan, nabasa. Wala. Ayan.
Takip boy, takip.
Easy ka!
Yung takip po.
Hayop ka.
Nag-i-steer ako, umiinom ako, ginayon ako. Oo.
Mali ko ba? Nag-send daw siya ng Gcash, wala naman.
Boy, wala na, naghang na.
Yung sa'yo.
Oo.
Hindi.
Uy, may mukbang sabi. May mukbang, abangan nyo.
Signal yan, boy.
Hindi, sa'yo yan.
Signal yan.
Ulitin mo.
Paano gagawin ko ulit?
I-close mo yung app, tapos balik mo ulit. Yan. Ano mo ulit. Kasi yung live chat.
Jojo.
Yan. Dapat dinidebunk nila mga peking ghost hunter.
Oo, tama. Hindi, lahat yan, para walang ano.
Diyan, di ba?
Lahat naman, kahit
Lahat, dapat
naman,
pantay-pantay.
Oh, kahit sila Red Cell 18,
Oo.
sila Manila Ghost Explorer,
Yo.
debunk naman ni Bungo.
Oo, lahat yan.
pinipili,
Kasi
wala
alam nyo,
pinipili.
wala naman kami problema kung i-debunk kami kasi wala naman kami ginagawang
Oo.
katarataruan.
At saka hindi kami nagawang peke. Kami mga natural! Diba tama boy, tama ba?
Iniisip ko sinong gumagawa ng ganyan eh.
Mali ko, hindi
Si
ko.
Palito gumagawa nga talaga.
ganyan.
Yung ganyan?
Yung mga holy shit.
Holy shit!
Doon muna kuya kay Palito no.
Tanga, wala naman si Palitong ganun.
Walang holy shit, walang holy shit si Palito, pero yung mukha, yung facial expression pare katulad mo.
Yes.
Mukha mo talaga si Palito.
Kala ko si Bentis Soy ba yun?
Invented soy. First time sa live to, boy.
Oh. Boss, andito si investigador sa Boss, Happy New Year, good health and more power. Pa-vlog mo.
Oh, may pawns.
Tanga pare, mga ano yan.
Pare, meron tayong bisita, interviewin mo.
Boss! Boss!
Usapang Dax na ang tayo.
Usapan Dax tayo ngayon.
Oh, interviewin mo to.
Dax, anong masasabi mo ngayon nag-live tayo? Kasama ka ngayon sa aming live.
Ito masaya. Masaya.
Dati nanonood ka lang pero ngayon nandito ka na.
Ngayon, sinundo pa namin yan sa airport. Nag-aeroplano pa yan, galing Farview.
Oh, far view.
Layo
Farview.
nun, pare.
Kaya nga far Farview.
Layo nga no,
Oo,
pare.
pare, Farview. Oo. Ganon kami kalupit. Pinasundo namin sa driver namin. Gumasos pa kami ng
Kano?
full tank. Magkano full tank? Tsaka gasolina.
2.5.
Basta.
2.5! Oh, ha?
Ba't ikaw ka nasigaw?
Hindi.
Bingi ka na eh.
Happy New Year.
Di ba dapat ganyan sumigaw na sumigaw?
Tama.
Active.
Taas ng taas ng ano.
Parang dami asukal eh. Shout out!
Hindi na kape yan, asukan na iniinom.
Hoy! Usapang Dax to!
Kaya nga.
Pare, sabi mo si Dax.
Ba't ako pinag-ginawa mong tagapag-interview? Hayop ka, ba't ayaw mo ikaw?
Ikaw muna.
Ano ba mga tanong
Papahiya
pag
ko
ano?
yung drive ako eh.
Dax, anong masasabi mo sa ating...
Hoy, sinolo niya yung barracks.
Oo, yung barracks.
Tapang talaga.
Hoy, mga kakatropa. Sinolo niya yung barracks, puta.
Punta kami ng barracks kanina sinolo ni Dax. Hindi namin sinolo. Hindi namin pinuntahan. Siya lang. Tapang ni Dax eh.
Hmm. May nagtanong, may asawa na po ba si Adventure Ducks?
Mga ganyang tanong di siya sagot.
Hindi yan sinasagot, yan ay personal.
May nagtanong dito boy, sabi, huwag niyo na pansinin si Third Eye kasi humiwalay na sa inyo.
Tama.
Okay lang, no problem.
Ay, alam mo ngayon nagla-live siya, pare. Pinanood namin nagla-live. Nagla-live, boy.
Naka-live.
Oo, kanina naka-live.
Ngayon, kanina,
Oo.
nandun kami sa loob.
Talaga?
Oo, boy. Ang lupit.
Binanonood.
62.
60.
64.
Solid yun, 60.
Tingnan mo, mababa na ngayon yan. Sa atin na.
Boss Val, I love you daw.
I love you too!
Sabi ni Alvin.
Kung
Anjon!
alam mo,
Anjon Grande.
Si Mr. Ganda J.
Sabi ni Mr. J.
Ayun na pala.
Katatapos lang,
Alam
boss.
mo, happy kami. Happy ako ha, na lagi may vlog si
Oo.
Jet. Na meron siya
Happy yun.
nakakasama.
Successful
Ako
na siya.
happy ako. Ewan ko si Val, medyo masama ang loob ba.
Oo.
Hindi, ako happy ako sa kanya. At least,
Ulol!
Sinasabi mo lang
Huwag ka sinungaling!
tapat ako!
Di ka.
Tapat ako!
Hindi ka happy.
Hindi, at least okay siya.
Masama ang loob mo.
Bakit? Ano ba itong
Malay
masama?
ko sa'yo.
Oh, wala! Happy yun. Successful.
At saka si Mangot ka.
Teka, yung kape ko ang lamig na eh. Parang cold coffee na eh.
Sabi takpan mo yan ba? Sabi takpan mo yan, itatapon niya sa ano ko eh.
Huwag mo ang tapikin!
Tatapon niya sa kotse boy, hindi tayo naka-leather. Dali na, hindi kita mahataw eh.
Kita mo, bahala ka sa buhay mo.
Lag-
Basta ako, I'm drinking coffee.
Lagyan mo na yan ba?
Pare ka na ito, uminom ng kape.
Ba't may kasamang dila? May kasamang dila naman.
Oy! Puta, doon na kanupin! Puta pare, pare pa Christmas sa ating tatlo! 23 pounds! Magkano yan?
Oh, ano ka? I-shoutout mo naman ako.
Shout out!
Sino?
Gusto mo? Doon na kanupin! Kailan mo boy, ha? Oh, ha? Pare, ang laki na
Pare,
nga.
makakaipon na tayo pang La Union.
Yun.
Hindi, late Christmas gift pare sa tatlo.
Ayun nga, pang La Union natin yan.
Hindi, ba't mo pa man lalaon yun natin? Ipang laon-laon natin ngayon. Laon-laan, dyan kainan.
Tama, o hatiin natin, 23 yan.
Oh.
10 sa kayo, 10 sa akin. So, 3.99 sa'yo.
Hayop! Hindi. Si Donna Canupin, walang yan. Taga ano pala yan, London?
Oh, love na love ka niyan, boy.
Puta, Donna
Love na
Canupin.
love ka. Oy! Labas mo yung ano, GoPro, boy.
Teka.
Pakita mo sa kanila.
Oy, nakabili na akong
wag,
GoPro.
Asan ba?
Napakita na pala natin.
Napakita
Hindi,
natin.
okay lang. Konti lang naman nasa live eh.
Oo. Eto na! Ang aking GoPro!
Pakita mo naman yung item, baka sabihin kahon lang yan.
Hindi, ayan, nandyan ang GoPro ko, GoPro.
Pinaghirapan natin yan.
Ayan ang GoPro ko, GoPro.
Ilang gabi yan na.
Mag-thank you ka naman,
Oh,
boy.
nagpokpok ako ng 5 araw, walang tulugan. Ginanyan ako. Eto na. Kinantahan ako. Kinantahan ako, sabi niya, Boss Bal, Boss Bal, Boss Bal, Boss Bal, Boss Bal, Boss Bal. Tawa ka ng tawang hayop ka. Oh, nagpadala na naman.
Ganyan kanina.
Ay, yung ba yan? Kanina ba? Tangin. Kala ko nagpadala na naman. Tangin. Kala ko nagpadala eh. Tangin, si Donna Canupin eh. Sasabog na ang mundo ko pare pag nagpadala ulit ang ganan. Tangin, tawa ka ng tawa. Ayop ka.
Naghangan yung ano mo.
Talagang na naman. Oh, tangin na. Donna Canupin! Nanloloko ka.
Ay, mag-thank you ka din sa ano.
Saan? Op, akyat tayo, akyat. Op.
Hindi, okay na. Mag-thank you ka sa GoPro.
Thank you po sa nagpadala ng GoPro. Wala lang ako tripod.
May order na kita tayo.
Na-order na ba ako? At saka wala.
Dumating na yung takip dito sa dito, pare.
At saka wala ako yung ano.
Dito.
Ano ba? Para saan to?
Bilis nga eh, dumating.
Para saan to?
Ah, dito yan.
Sa third
Pag ano ba tenga? Kaya pag hinuli. Hindi kayo pare kayo salpak yan. Tangin mo gago ka. Niloloko mo ko hayop ka.
Kaya pala masaya to, may GoPro nga pa.
Oo! Kaya ako masaya may GoPro!
Oh, ganun ka namin kalab, pare.
Congratulations! Sabi ni Ma'am Donna Canupin.
Si Dax pa ang kumuha nito.
Oo,
pare.
kinuha. Alam mo, kinuha pa niya sa Benguet. Benguet Abra. Kasi nandun yung reseller.
Layo, pare.
Nagkinaplano pa ako dun.
Oo. Congrats daw sabi ni Regina. Siyempre, dahil sa inyo, natupad na. Pwede na ako mag-vlog sa CR. Pare.
Wala
clear.
nang angal niya.
Oo, wala kayong angal na yan. Hindi na kayo sasabihin, Boss Bal, ba't malikot? Kahit ako naduduling
Bakit
yun eh.
sahig, no? Ba't
Oo.
nasa sahig nakatutok? Ganun.
Oo. Ngayon, hindi na.
Galing yan, bro.
Pare, ngayon nakatingala lagi sa langit dyan. Tangina.
Puro kisa mo.
Okay, sabi na ngayon. Oh, thank you, thank you. Wash out sa inyo.
Tuwa kaya pala masaya ka, boy.
Oh, ayan, ha. Meron na akong GoPro. Ano ito, pare? Ano ito?
Battery.
Ano ba to? Ano?
Battery.
Ito ba yung ano, lalagyan ng asin? Ha? Hindi tinataktak. Ha? Uy,
Ajinomoto.
Ajinomoto, ano, lagyan ng asin. Tinataktak na yun.
Ajinomoto.
Iniisip ko nga, ito para saan to?
Ah?
Dito, lalagay sa dugo.
Ganun.
Yung
Oh,
GoPro.
yeah, si Jonar Galera, boy.
Joner Gale! Ano yung gagawin
Oh,
natin?
malaki din ang bag niya.
Oo, si Joner Galera.
1,000 ang bag niya sa GoPro mo.
Oo. Si Koke wala na. Nagsariling mundo na. Ito para saan to?
Ganda.
Dito, lalagay sa dugo. Ayan, ang GoPro ha.
Yan. So, wala, si investigador dyan, humihiwalay na sa atin, boy.
Ayan, paano daw gamitin na? Marunong ako. I can't you see?
Bibigyan din sana natin ng ano eh.
Si investigador,
ng
Jay?
go.
Go lang, go.
Walang go.
Pakitakbo kayo, di go ka lang.
Go ka lang, go. Go, go! Oh, good evening, boss. Jonar ha? Ito sino yun?
Pagod ako.
Pagod na si Boss Rino.
Oh, napagod na mahina. Oh,
Kaya, papahinga na ako, boy.
Teka, at
Ba't gano'n nalambot ako?
gabi si Boy eh.
Hindi naman ako ng ano.
Iba dun sa ano.
Iba boy, doon sa ano.
Bumalik kasi kami sa Twin Mansion, nagdumo kami dalawa.
Oo.
Dumo nga, hindi dalawa.
Nagduo kami.
Napagod ako, boy.
Hindi,
Ang
boy.
haba pa ng tulog ko.
Hindi, ako boy, lalo ako nang hinay pagkatapos. Hindi pa kayo nag-usap na lang ni ano, ni Cholo ah.
Kaya nga eh.
Ako nakagayon, nakamukha ko, inintay ka namin, nakagayon ako eh.
Hindi kasi ano, kaya nangihina kapag pumasok ko ng abandon kasi kumukuha sa'yo ng energy yung mga
Pare,
nakatira.
ibang nakuha ang energy sa akin eh. Lumiri ka mata ko.
Ay, ibang energy yun.
Aga!
Nagre-relax ako kasi dito naman si Dax. Merong ano.
Ibang energy yun.
Oo, ibang energy pare, grabe.
Okay, panoorin yung mukbang natin. Yun ang una natin i-upload.
I-upload daw.
Kasi ano eh.
Yun yung sa ano, continuation ng...
Sariwa pa yung Twin Mansion. eh.
Oo.
Hindi Twin Mansion. Yung ano, yung fifth floor. Yung ano.
Hindi nga, sariwa pa yung Twin Mansion na upload natin.
Oo.
Kaya magmukbang muna tayo.
Oo.
Yung upload namin.
Yes.
Nagpasabog si Bal.
Nagpasabog ako! Puta!
Ibang pasabog. Napaturay ako.
Oo, tangina no. Grabe si to, grabe to.
Hindi
Nagulat ako doon, boy.
nabugaw ko pa yung pagkain ko doon sa lamesa.
Puta na pare, sabi daw, ang lakas daw ng energy ko ngayon. Puta.
Eh, syempre, may bagong GoPro.
Siyempre may bagong GoPro kami. Pero pag ano, pupunta ako sa YouTube, titignan ko pa paano pag ano.
Alam mo kung ba't ako nilalambot? Ang dami ko nakain. Ang dami ko din nakain, boy.
Nangya kayo. Yan ha!
Okay, sarap ng kape. Hindi, dito lang.
Sabog pati multo. Siyempre, sabog lahat kami. Op. Ay, anyway.
O, di ba? Oh. Oy! Oy, si Dax! Si Dax! Usapan Dax to!
Kaya nga, Dax, ano masasabi mo sa ginawa mong exploration ngayon?
Yung sa ano? Saan?
Oo.
Yung sa barracks?
Oo.
Nakakatakot.
Experience mo lang.
Sabi ni Dax, ano, pupuntahan ko ng solo yung barak. Sabi niya, sige, punta mo na. Saglit lang ako ha.
Oy, sabi ni Anywhere TV oh. Oh, pare si Anywhere TV. Si Anywhere
May sinasabi ko nga! May
Anywhere
sinasabi!
Oh, yeah.
Lagyan mo ng takip yan!
Hindi pwede. Nagtumapon, malas.
Anywhere
no?
TV, hello!
Sabi ni ano, thank you daw. Congratulations pa, may GoPro na ako.
Congrats daw.
Thank you. Ano, Anywhere TV.
Tangina, ako bago ako nagka-GoPro, ito hayop to, pag ganyan-ganyan ka lang, nagkaka-GoPro ka.
Parang nagtanong, bakit si Dax kahit takot, guwapo pa din?
Na-edit kasi yung ano, yung mukha sa video. Sa actually ba yun?
Gopong-gopo kayo dito. Sabi niya kanina, sandali lang ako sa barracks. Tangina, 30 minutes
Oo,
yata sa
tagalin.
barracks.
Putang ina nga sabi.
Tangina, init na kami.
Oo, pare, inintay lang namin dumating ka para lalayasan na namin yung isa.
Hindi ko kasi, baka nanonood. Kasi natatakot na ako, ang daming kwento ni Cholo boy.
Oo.
Daming kwento, nakatakot eh. Ayan, pagod
Yung barracks kasi doon, 2 months ago lang may nawala ng buhay doon eh. Sa barracks.
Oo. Ay, sa barracks pala, dalawa na yung namatay.
Dalawa na pala, dalawa na namatay talaga.
Dalawa.
Grabe no.
Binangungot.
Binangungot daw?
Boy, may nagsabi, gwapo din naman si Boss Rino eh.
Syempre.
Oo, syempre.
Oo naman.
Kay Bal wala ba sabi?
Wala, syempre, alam mo naman
Sa
tayo.
susunod na upload na yun.
O susunod yun, oo.
Ay, pag napanood niyo yung mukbang namin, ay lilipat kayo.
Lilipat kayo ng ibang channel.
Lahat na may gusto kay Bal,
Mawawala
ay
na.
kay Bal, kay Dax, lilipat lahat kay Bal. Pag atayin niyo yung mukbang namin, mai-in love kayo kay Bal.
Atay.
Tanga na, mag-aalisan na sa channel ko.
Di, puta pare, ibang klase.
Kakaiba yun ah. Kakaiba yun yung nangyari sa mukbang.
Oo, gabi yung mukbang na yun pare.
Hayop na yan.
Ikaw lang gumawa ng boy.
Ikaw lang gumawa nun.
Tanginang yan.
Pero paninindigan mo na rin yun kung ano man yung ginawa mo dun sa mukbang.
Oo, panindigan mo na.
Hahanap-hanapin ka ng
Ihanda mo na ang Gcash mo, sasabog na.
Gagawin ako lagi.
Spoiler ka na rin eh.
Sabi, gwapo kayong tatlo, napilitan ka pa, wag ka na.
Oo.
Sabi ni Albea Grace Aquino, gwapo naman kayong tatlo. Okay lang yun.
Ay sorry, solid ako kay Labs ko. Bari, solid talaga si Joan Bustillo sa'yo.
Si Lalabs ba? Sabi niya.
Wala, ayun, sorry, solid daw ako kay Labs ko.
Labs, kala ko lalabs.
Nagtataka ako, may nagme-message sa akin, nasaan si, sa
Ayun
chat?
naman, no, I love you, Dax. Tangin ninyo to. I
Patay na natin ito, pare. Wala nang kwenta to. Lokohan na to.
Dahil lang kay Dax,
Oo, po.
Sabi sapawan daw. Walang sapawan dito.
Single ba si Dax? Oo, single yan. Single and very much single.
Unavailable, ganun.
Oo. Oo, ha? Kayo talaga, ba't kayo? Usapan Dax tayo, ba't tama?
Ilang taon na raw si Boss Rino? 28.
walang
29
tanong
ba?
nga ng ganyan.
Oo, nang insulto
Alam nyo,
kayo.
huwag nyo kaming tanongin ng ganyan kasi hindi kayo makakuha ng tamang sagot.
Oo. Dito pare, ang viewer natin, 261.
Siyempre, andyan si Dax eh.
Oo, pag nandyan talaga si Dax, ang lakas, no?
O yan, sabi ni Azir. Dax!
Puta, Adventure Ducks, puta, Adventure Ducks, Putang na pare, lipat na nga tayo sa channel mo. Na mag-chat.
Sabi ni Glenn, papabal, ano daw po ang FB mo at mag-chat tayo. Ay!
Ay! Message mo ako sa aking page.
Balbaliw.
Balbaliw. Doon tayo mag-usap.
Facebook page na
Ay, may nag-message sa akin. Oy, puta!
HK yan ah.
HK, Hong Kong dollar, Si Mary Mary. Mary Mary! Shout out! Dapat ikaw pare, channel mo yun sa'yo lahat nagpapadala
Kaya, takina, binigyan ka na namin ng GoPro.
Sige na nga, ay walang tripod
Parating pa lang yun.
Para di
Order ko na nga yung tripod mo!
Ay, walang flashlight.
Binigyan na kita ng flashlight kanina.
Hindi yung flashlight yun. Ha? Yung flashlight yun. Yung ilaw niya sa side, di ba katulong ko, di ba?
Meron ka sa'yo
Ah, meron ba ako sa akin?
Mahal yun, yung katulad sa akin.
O, magkano yung gano'n? 5,000 ba yun? Ah!
Takina lahat na lang, Bal. May GoPro ka na, Bal. Ayun, ba't nag-freeze?
Walang din. Ay, ito lang. Pero okay lang yun. Dito lang.
Pinost mo to? Oo, alam ko yan. Uy,
Ano?
yung sa'yo na lang, pwede na yun.
Na?
Yung malit na ilo mo.
Ah, yun ba?
Oo, yun na lang.
O, ilalagay ko na lang sa noo ko.
Mahal yung gano'n yung sa ilo.
Ay, ganyan mahal na yun.
5,000 yun yung katulad sa akin.
Takinang yan. Pare, pag-iipunan ko yun.
5,000
O
yun.
magla-live ako ng ano.
Yung maliit na ilo.
Pare, magla-live ako 10
Hindi ko lang, 5,000 o 2,500 ba, gano'n.
Pare, magla-live ako 10
Mahal
live.
yun. Magandang bato nun eh, ng ilo.
Pare, magla-live ako para mas maganda yung bato.
Mag-live ka? Oo nga, pwede ka naman
Pare,
mag-live.
solid na bato. Granite ang babatalakit.
Pwede ka mag-live, boy.
Diba?
Pambili
Diba, pare?
pambili ng accessories.
O, pambili ko na accessories.
Pero kasi, gandahan mo ang vlog mo.
Oh, pare, hindi. Ganito, pare.
Hindi kung saan nakatuto.
Hindi, ganito pare, pag maglalagay ako, lalagay ko para sa accessories ko, t-shirt, sapatos, jeans, naka-itemize lahat, di ba? Oh,
Para makaporma ka.
baka porma pare, ang hirap mag-vlog ng nakahubad.
Oo nga, huwag kang magubad.
Huwag magubad.
Masama yan.
Masama yun.
Huwag mong pakita yung
Bawal kay YouTube yun.
yung sobrang gandang katawan mo, huwag kang magubad.
sige, sige,
Tago
sige.
mo na lang yan.
Tatago ko na nga lang, hindi ko napapakita.
Anywhere TV nandito ko.
Oo nga si Anywhere, Anywhere nga eh, ayan oh.
Tapang din yan. Naglalakad yan ng walang
Oy.
flashlight sa abandon eh.
Masarap din kasama yan.
Parang lupit niyan.
Tapag niya.
Akala mo no, walang flashlight, naglalakad sa dilim, di ba? Hindi ko lang parang pusa. Yung mata niya pare, kita niya, may tawag doon, may night vision. Biglang mawawala, tatago sa poste. Yung gagawin ko,
Bari, lagyan mo ng yung takip.
para hindi mo ako matapik.
Oy, usapan Dax!
Pare, puro ducks nga ang bata. Banat eh, ang pogi mo ducks, I love you ba ducks?
Bax, ano ba ito?
Adventure
Boss Dax,
ducks.
ikaw nga sumigaw para si Balha.
Oo ha?
Taga Sandigan ba si Dax?
Taga Sandigan. Taga Fairview.
Taga
Fairview.
Fairview.
Parview!
Ay, baka nakita ko niyan sa Sandigan ah.
Ano meron sa Sandigan?
Wala naman.
Yung kwento.
Maraming motel dun eh.
Saan ako? Sandigan?
Baka nakita tayo dun ah.
Si Bal Pogi, nagwapo pa.
Oh,
Pero
ayun pare
sinungaling.
oh.
Pero ako sinungaling.
From Hong Kong,
Ano?
si Melka Balabat. Wow,
Boss
from
Bal,
Hong Kong.
nag-gym ka ba?
Hindi.
Bato-bato ka daw kasi.
Hindi, bato lang ang mukha ko. Ganun talaga, pag bato.
Yung mukha lang niya.
Oo, mukha lang bato. Pero hindi. Asan daw si Third Eye? Wala nga si Third Eye. Ano na yung famous na. Oy! Shit! Si Donna Canupin! Nagpadala ng 6 pounds!
Donna Canupin!
Pang live. Pag nag-live si Bal, mas maganda sa Diyos ko. Flash night na yan. Ah!
Ay, binigyan ko na siya ng flashlight kanina.
Ibang flashlight yun. Flashlight ang GoPro.
Binigyan ko siya ng flashlight. Yung blue ba ako? Binigyan ko na niya.
Wala pa. Hindi ko pa nakukuha eh.
Ay, andyan.
Nasa bag mo eh.
Napakaswerte na tumatanggal sa ano.
Siyempre, pare. Kailangan dapat spoon feeding. Spoon feeding.
Napakaswerte mo, boy.
May...
Oh, shoutout po si Donna Canupe.
Donna Canupe! Shout out! Oh, pare, may takap na.
Sagawa mo, boy.
Shout!
Yung pang $5, $5 pounds.
Ang pang 5 pounds, ganito ang sigaw ko kay Ma'am Donna Canupin. Hindi. Donna Canupin, shout out! Kanina pare, yung ano magkano padala ni Donna Canupin?
23.
Ayan, buta si Glenn!
Singapore
dollar! I love you!
Oh, ba't gano'n? May I love you?
Dapat si Donna Canupin.
Donna Canupin, I love you! Baka may magalit, gago.
Bakit ano na naman yun?
Shout out lang namin kayo.
I love you na naman, di ba mga agawin eh.
Oo nga, tama.
Tama.
Dax, single ka ba? O may jowa ka ba? Maraming jowa yan si Dax! Mga multo!
Lagi ako nasa ano,
Puta.
abandoned hotel.
Nasa abandon motel lagi yan. Sogo, Mariposa,
Nag-investigate.
nag-investigate yan kung sino yung mabobosuhan doon. Taga-Kalamba, yes! Taga-Kalamba kami, Justin.
Bakit daw di kasama si
Third eye?
Investigador Jay?
Oo.
Si
Paliwanag mo nga, Bal.
papaliwanag ko na sa inyo si Investigador J, kaya hindi na sumama. Sikat na, so famous. Ang sabi niya, dahilan niya, ako ay guest daw sa isang party. Naghahanap kasi ng mascot, kaya siya kinuha.
Ghost party.
Ghost party. Ayun, kaya ayun, kita mo pa rin nakaga.
Tawagin doon natin si Ed Kalawag.
Hindi, mahirapan niyo si Ed Kalawag.
Pero dati nag-guess na ako sa kanya eh. Kay Ed
Talaga?
Kalawag. Oh, mga 2020.
Nag-guess ka?
Oo.
Talaga? Nag-guess ka?
Kinontak ako ni Ed Kalawag tapos may ano yung live streaming.
Ba't di tayo i-imbita doon, Bal?
Pero nung piniem ko siya sa page, sabi niya, sabi ko collab tayong ano eh, tatlo.
Sabi niya.
Sabi niya, ang manager niya tayo nakausap ko. Sabi, kukunin niya daw yung contact number ko, di binigay yung contact number ko.
Wala.
Hindi pa siya nag-chat. Siguro ang dami pang
Sikat na rin kasi.
Paano pang ano? May hirapan na yun, boy. Ganyan.
Hmm.
Kaya ako sa inyo, ganito pa rin gagawin namin. Natural na natural. Walang kapeke-peke.
Meron kaming bagong pinuntahan.
Ano?
Tanong kung meron daw tayong pinuntahan.
Meron, marami! Unang-una pinuntahan ko namin Astrotel. Sumunod, My Inn.
Ang dami mo alam.
Tapos, Sogo. Tapos, Red Horse. Red House, dyan.
Red Horse.
Red House, pare, Red House. Tapos, Angel's Nest. Puta, pare, creepy! May gagano na. Puta, pare, bakit niya marinig mo ba? Sabi ni Trixie, tawa si Trixie.
Ayaw si Trixie.
Ayun naman si Trixie.
Si Trixie natatawa sa...
Ayun si Trixie, yan ang sabi ni Trixie. Sabi ni Trixie.
Tama si Trixie, alam na alam niya, boy.
Biglang appear nawala eh.
Ibang Trixie yata yun.
Baka ibang Trixie yun. Ibang Trixie.
Naku, na-miss mo si Trixie, boy.
Pegasus daw
Oh,
sabi.
ibang Trixie nga yan, boy. Gago, hindi yan si Trixie.
Hindi.
Sabi ni Anywhere TV, Pegasus. Sabi ni...
Iba yun, hindi baryon. Ito motel. Creepy motel.
Ano ba yung nakagano na logo?
Victoria Court. Wala dito Victoria, pare, dito lang Laguna. Dito kami tumaba na.
Ay, yung mga sinabi mo dito?
Dito lang yung
Ang
pare.
dami alam nito,
Ang
boy.
dami. Kasi tinesting ko lahat ng mga kwarto eh. Per rate.
Dito lang lahat yun, yung
Dito
sinabi
lang
mo.
yun. Oo. My Inn. Astrotel.
Investigate.
Riverview. Yung
Ikaw, boss,
sa
sino?
ano?
Saan yung mga alam mong mga abandoned na hotel?
Sa Manila.
Ako, Santa Mesa lang alam ko eh.
Dami doon sa Tamesa.
Parang dikit-dikit doon. Pababa ng presyo doon.
Sa Tamesa.
Ang pinakamura doon, 150, nakatayo na kayo.
Paano yung nakatayo?
Pagpasok, pare, cubicle, nakatayo na lang kayo. Tangina ganyan na kayo.
150 eh. 150 lang eh.
150, ayan na lang, tayo kayo.
Baka kung ano iniisip nila, sayaw po.
Kaya po. Ganyan mo kami. Kami naging investigador. Ngayon tinitira namin lahat ang ganun. Sa katunayan nga bukas may may mga client ako 5, titirahin ko yung kanilang
Sayaw.
yung kanilang mga
Alin ba?
yung kanilang mga suggestion na motel. Citrus Lodge. Tangina. Mariposa.
Kaya mo yun, 5?
El Rancho.
Ikaw dito.
Hindi, okay lang. Pwede natin gawin yun, boy.
Oo.
Punta tayo sa mga Sobo.
Abandoned hotel daw.
Hindi, kahit active. Mag-check in tayo, tapos doon tayo mag-vlog.
Oo. So, pare pupuntahan ko nga ngayon bukas yun eh. Montreal. Oh, Joy
Hindi
Motel.
naman nila alam yung Montreal eh. Yung mga sikat na lang.
Ayan, pupuntahan namin.
Victoria Court.
Victoria Court.
Oo.
Anito Inn.
Meron wala na yun.
Wala na palang Anito Inn. My Inn. Any Inn. Out Inn.
Winston.
Win Inn. Winston Inn.
Winston.
Winston Inn. Oh, puta.
Sa ano marami? Sa
Saan?
San Mesa.
Taka naman pinag-usapan natin mo talaga. Pinag-usapan natin yung Boss Dax. Oh, ba't?
Ikaw nagpasimula eh.
Ay, puta. Siya kasi sabi daw kung ano yung mga ating ano explore rin eh.
Oo, exploring.
Oo. Anyway, dito kami ngayon kaya inimbitahan namin si Boss Dax. Ganyan kami kalupit. Sinundo namin, sabi ang dami kasi nagre-request para sa kanya. Oh, ha?
Ibang usapan na yun. Sabi.
Hindi, ano lang 'yan, napag-usapan lang namin. Anyway,
Ano sabi?
Tuwa sa yung mga tao.
Tibal.
Kasi sabi si Anywhere.
mahal kitang motel.
Alam mo yan, mahal kita motel.
Hindi ko ba.
Katabi, sa ano yan? Sa Pasay.
Sa Pasay ba?
Yung naka-review. Sinong basahin mo?
Asan?
Saan ba masahe mo?
Bal.
Ito.
Halatang ganda.
Halatang ano ka daw.
Halatang fuckboy ka. Hindi naman.
Mas okay pa nga yung Tagalog kesa doon sa ano eh, sa sinabi
Fuckboy?
mo. Oo, mas bawal yun.
Mas bawal ka.
Basahin mo buti.
Halatang kantote. Pero alam mo, hindi ako ganun. Alam mo ginagawa ko, share your love.
Love
Ako yung
pala yun.
ano lang na may migay ng pagmamahal. Oo.
Pagmamahal.
Oo, pagmamahal yun. Diba? Pero sa shoutout ko si Ma'am Cindy, nagpapa-shoutout pala. From ano yun, Davao. At saka si Ma'am Joanne, si Ma'am Lee, ano? Yung taga San Diego. Nalimutan ko.
Si Ma'am Ma'am ano?
Ma'am Grespe?
Oh, guest pa.
Ma'am Grespe! Shout out si Ma'am Madeline Maongat, shout out.
Si Penny.
Ma'am Penny Epipanya ano ba yun? Biray.
Biray. Oh,
Epipanya Biray. Pinasya-shout out niya yung pamangkin niya. Sino ba yung pamangkin niya? Samantha Kati. Sarah Kati. Ayun, pucha, ha? O yan, sinautout na namin. Ano na, pa-shoutout naman. Justin Jake, puta kanina ka pa, sinashoutout na namin. Lintik ka naman eh.
Kailan uwi ni Anywhere TV?
Nasa mo si Anywhere TV? Nasa Iraq?
Nasa Anywhere.
Asan ba yun? Parang
ibang
lupit
bansa.
talaga yun.
Oo, lapit mo.
Grabe. Kita mo yun nasa ano tayo? Nasa Clark. Puta biglang nawawalan. Gumagano. Ang lupit. Akala ko The Matrix. Diba?
Oo, kaya lumilipat eh, no?
Oo.
Sabi, sana sumikat kayong tatlo tulad ng iba. Di na, okay lang.
Okay lang kami dito. At least masaya kami. Napapasaya namin kayo. Yan. Ang mga puso namin ay puso sa inyo. Sinishare namin ang puso sa inyo. Pajikas! Ay, nako. May abandon pwede po explorein dito sa Nueva Ecija. Kontakin mo yan. Tapos kontakin mo kami. Okay?
Ito, shoutout mo. May nag-gigas siya, shoutout.
Sino?
Yan, basahin mo.
Hindi ko nga mabasa yan. Nalapit eh. Ba't parang hirap pa? Hindi mo maano up?
Ayaw din ma-zoom.
Kasi, sa Aquarius, Boss Bal, marami daw. Tiyanak doon.
Yes! Halatang jakulero ka. Tiyanak eh.
Dito
Jakulero.
kasi may Aquarius.
meron ba dito?
Yung massage na may Aquarius.
Para pagpasok mo sa Aquarius kasi makakita ka ng iba't ibang hayop. May hippopotamus, may elepante, kumpleto pre. Parang zoo.
Ganon?
Pare. Oo.
Hindi ka pa nakapunta ron, boss Rino.
Hindi pa napasok doon. Diyan lang, nagdaan natin.
Yan lang pare pa. Tuturo namin sa iyo. Matutuwa ka. Sasabihin, putya. Kakaiba. Ha? Kita mo yan, ilan ang puta pare, dumami na ang chat. 295.
Ayan, dito si Dax Boy eh.
Puta, iba talaga pag nandito si
Kaya
Dax.
usapan Dax Boy.
Oo,
Kaya
iba.
napupunta sa hotel eh.
Oo.
Abandoned hotel eh. Hindi haunted pala, mga haunted
Oo,
hotel.
mahal dyan sa classmate. Pero nag-explore kami ni Boss Dax. Kasama namin siya kanina. Nag-explore siya dun sa barracks. Puta, sinolo niya. Kakaiba. May nakita siya. Parang
Parang, ba't kaya ako magsalita vlog? Parang may period kada word mo.
may nagpadala na naman si Donna Canupin! Shout out! Ano, magkano pinadala mo? 6 pounds! Shout out daw si Leon Guerrero! Tama ba? Leon! Pare, laksan mo naman boses mo. Tangin na ba? Parang
Malakas yun ah.
malakas ba yun?
Malakas yun.
Shout out daw si Leon ko! Leon ko! Leon, ano yan? Chinese?
Doon nakanupin.
Leon, anak niya yun.
Leon ko? Hindi, Chinese yun. Leon ko. Leon ko?
Shoutout mo na!
Shout out! Parang lambot kang hayop ka.
Lalambot ako boy.
Doon yun sa ano, sa Twin Mansion.
Sorry, hindi ako antok.
Lambot ka boy, naubusan ka ng energy.
Nanghihigop ng energy.
Oo, hindi ko
yung
pa.
ano doon.
Ganun ka.
Totoo ba yun ang higro?
Oo, kaya sabi ko sa'yo eh. Ayaw maniwala kanina pa eh.
Parang lambot na lambot ako. Kakakain lang natin.
Yung mga multo kumukuha ng energy
Oo, boy.
sa nag-explore.
Kaya nga sabi ko sa'yo,
Kaya
naramdam.
ayoko sabi sa'yo, ayoko sa barracks eh.
Puta, nagpadala na naman si Donna Canupin! Ay, putangin na yan, yun na naman pala.
Ay, hindi nakaano eh.
Hindi na naman. Ayun, tarantado ka, hindi umakyat eh. Hayop ka. Kuya Bal, ano?
Kuya Bal, pumapogi daw kayo kasi kasama niyo si
Dax. Oo nga, syempre na ano kami, nahahawa kami. Alam mo naman may pagka chameleon.
Boy, parang ka shoutout eh. Wala ba tayong topic dyan?
Eh,
usapang
pare mahina,
daw.
lambot na pag pasensya nyo na to at lambot na lambot si Boss Rino.
Mm.
Kasi parang may humigop siya kaya ginan daw siya. Oo, kita mo. Lambot na lambot ang puta. Ako kanina lambot na lambot, ngayon ako naka-recover eh. Talagang iba buhay.
Haba kasi nung tinakbo namin eh.
Hindi buhay iba.
Kasi bago
Sa Twin Mansion.
nag-Twin Mansion, kailangan mo takbuhin mo muna papunta doon.
Hindi buhay iba.
Magod ako boy.
Yabi ko siya, mararamdaman mo yung naramdaman ko eh.
May tao sa likod mo. May ramdam sa likod
Oo, ramdam ko parang may iwas sa
Doon
likod.
nakanupin, Leon. Boss, may send ako video
Ano?
sa'yo. Greetings from Leon.
mo. Sa'yo.
Puta.
Wow.
Wow, Leon Guerrero! Greetings. Putang na sino yung Leon? Guerrero.
Dapat may dala kayo panlaban sa negative energies. Sabi ni Rica.
Sabi ni Joan Bustillos, mga boss, may tanong si JB Balza. JB Balza? Anong tanong niya? Ashri Paranyal. Oh, shout out sa iyo. Teka. Boy, nasaan yung Hinigop siya ni Bal. Pucha. Abrin Francisco. Shout out.
Ito sabi ni JB
Peña
Plaza.
Floor from Taytay Rizal. Gamer? Ano sabi?
Minsan ba naisip mo na lang lumabas sa haunted house dahil natakot ka talaga? Sabi.
Nagpadala si Minukawa $10.
$10.
Pangkape ni Bossing. Ba't kami wala? Ba't lambot ka? Nasaan?
Labot na labot ako boy.
Hindi, ikaw Boss Rino, yung gusto mo nang lumabas daw sa abandon.
Kasi may sinasabi si attention ka dito kasi.
Kaya nga.
Ang sabi ni siyempre JB Plaza, minsan ba naisip mo na lang lumabas sa haunted house dahil natakot ka talaga?
Oh.
Ako para sa akin kasi mas natatakot ako pag halimbawa hindi ko nakikita yung halimbawa may nakita akong kwarto. Dapat gusto ko makita kung ano yung nandoon eh. Lalo na pag may nagparamdam. 'Di ba? Kasi pag umalis na lang ako, lumabas ako sa haunted house nang hindi ko nakikita yung lugar. Kasi may nagparamdam, natakot ako. Parang mas lalo kang hindi makakatulog eh kasi hindi mo alam kung ano yung nasa loob eh. 'Di ba?
Baliktad siya no.
Ako
Wala akong pakialam, basta hindi ko makita. So hindi ka nalabas.
Hindi ako lalabas.
So kanina ko pa nababasa yung boy, hindi ko pinapansin.
Ina mo, hayop ka.
Pinansin mo naman.
Hayop ka
So
talaga.
si Dax hindi daw siya lumalabas. pagka may nakikita.
Oo. Pag may nagparamdam ganun.
Tapang nga to, ikaw.
Hindi boy, sa akin kanina talaga ramdam.
Pag may nakita ka!
Wala akong nakikita na ramdaman lang. Kaya tumatakbo na agad ako.
Yun, kaya kapag ka pauwi na tumatakbo ka.
Oo.
Ako hindi, lalabas na ako boy.
Hindi mo titignan.
Gago
Hindi
ka
na
ba?
ako, hindi na. Tatakbuhan ko na.
Titingnan ko pa, tapos hindi naman ako.
Hindi naman.
Siyempre, mapapaisip ka lalo nun kung
Kaya,
ano yung nandun.
mas okay na naman nasa isip ko lang siya. Kasi pwede ko pa sabihin na, wala yan.
Oo.
Pero pag nakita mo na boy, ayaw na.
Oo. Ako boy, kanina talaga naramdaman ko pagbaba
Sa
natin.
likod nga.
Puta boy, tumakbo na ako eh. Kaya napatakbo ako eh. Ramdam ko. Kaya kita mo pagdating dun sa ano, pahinga. Lambot na lambot ako.
Parang dun sa may spiral, no?
Oo.
Andun talaga eh.
Oo.
Ang lambot
Sa
talaga.
Twin Mansion, yung may spiral na hagdan dun. Dun mo naramdaman yun, yung may sa likod mo.
Oo. Hindi. Pag-akit na lang namin.
Mm.
Di ba nasa baba na kami? Di ba unang tatamaan yung kwarto ni ni Romualdez?
Mm.
Lumabas na kami. In-explore pa namin dalawang kwarto doon sa dulo.
Oh, gilid.
Pagdating niyo sa pangalawa, yung sabi niya, boy, pare pag nakita namin hagdan, para may naramdaman ako sa likod
Sa
ko.
likod mo.
Kaya tumakbo na ako. Kaya sabi ko, puta ka na, parang unahan na kita. Eh, biglang ang bilis.
Okay, kwento na natin yung vlog natin. Kwento
Hindi,
na natin,
hindi,
huwag natin
yun
i-upload.
lang, yun lang.
Hindi,
Oh.
wag na natin i-upload. Kwento na natin.
Yun lang.
Hindi.
Hanggang katakot
Tap,
talaga.
pare,
Boy, akala ko nagbibiro ka lang. Hindi pala totoo. Gago ka, Bal. Akala ko nagbibiro ka lang kanina. Totoo
boy,
pala.
totoo yun.
Gago ka, natakot ako.
Di ba sa isip mo lang na may ano?
Hindi.
Hindi, na may naramdaman.
Pero ito muna. Ang pogi naman ni Leon.
Yes! Wow!
Wow, si Leon.
Hello, si Leon! Wow!
Ang cute ni Leon, no?
Ayan, si Leon! Ha? Yaw, pucha.
Oo.
Ang galing!
Shout out kay Leon.
Oh.
Shoutout kay Leon!
Pucha. Leon Guerrero!
Kasi yung pinag-usapan natin, tapos si Dax marunong sa live.
Oo.
May topic siya, oh. Ito walang kwenta kakausap to boy, eh.
Nilipat.
Pare, wala. Alam mo pag may topic, tapos wala pang 1 minute, tapos yung usapan.
Oo, parang ganyan ako eh.
Wala si, tamo.
Lipat. Parang dito ka lipat ka ako sa likod.
Dapat ganun, pag may topic, diretso, podcast ka eh.
Podcast.
Ano,
oh.
walang kwenta, kaya hindi ako makabuo ng podcast eh, kasi ito magiging partner ko. Puta na, walang mangyari.
Anyway,
Tamo, iba na naman.
Anywhere TV. Anywhere TV.
Iba na naman. Iba na naman. Wala kang ano boy, hindi ka man of focus.
Hindi, mali.
Oh,
Consistency.
Man of focus.
Hindi, boy.
Parang yan,
Mali.
John Wick yun.
Pare, yan ay hindi ka consistency sa topic. Galing ko ano?
In English mo lang, hindi naman yan.
Ano yun? Sige.
Hindi ka ano boy, wala ka kasing pakialam.
Boy, kita mo itsura mo, mukha kang lobat.
Lubot nga.
Halatang halata ka.
May grupan kayo ng energy dun sa ano, Twin Mansion.
Teka, bukas pare magpapagpag ako. Hahanap ako ng kausap na. Are you free tonight?
Pagpag yan.
Pagpag yun.
Sama mo naman kami dyan.
Are you free tonight?
Wala naman ang pagpag mo boy
Siyempre, pare, kailangan ko ipagpag si Junjun. Si Junjun.
Papagpag mo.
Pagpagpag si Junjun. Ha?
Boss Bal, gusto daw po mamit ni Lola, crush ka daw niya.
Oh, sure! Para si kay Lola.
Gusto magpagpag.
Hindi, wag. Pupuntahan lang natin siya. At ating kakamustahin si Lola. Puta pare, grabe ka naman.
Boy, sabi mo pagpag eh.
Pag ibang ibang ano yun pare.
Juicy ka pa.
Ayaw mo pa nun.
Siyempre nakakahiya yung boy. Hindi ako ganun. Ano sabi? May nag-message? Wala. May nag-Gcash?
Wala nang Gcash.
Pare, pumasok na dyan lahat eh. Ha? Teka, nanlambot ako eh.
Sabi siya, nakakalambot ng boy eh.
Nakalambot.
Pare, nung nagbagyo tayo, 6 hours ako nag-drive, nag-diploma tayo ng 3 hours straight. Umuwi tayo, nag-drive ulit ako, hindi ako nalambot ng ganito.
Oo. kita mo sabi ko sa'yo, ramdam ko kanina, ayaw maniwala.
Baka bading yung multo doon, boy.
Tangina boy, delikado yun.
Tingin mo sa barracks yan o sa ano?
Higop ng lakas.
Ako hindi.
Sa twin, no?
Oo.
Sa twin.
Sa twin, di
Sa
ba?
twin yun.
2 beses namatay ang GoPro ko doon, pare.
Tamo.
Sa twin.
Kaya nga, sabi ko sa'yo. Pare, ako nga hindi nag-record eh. Kita mo sabi, diba?
Jonar Galera, tawa ng tawa, misis ko kay Bal. Shout out Jane Galera.
Jane Galera! Shout out sa'yo! Ah, bucha. Ha?
Dami natutuwa sa'yo pagkabastusan doon. At ayun yung mukbang namin.
Puta!
Patay ka.
Doon kayo kikilabutan! Sabihin nyo, ano ba naman to napasok namin?
Yari ka ba?
Yari na. Ay, nako! Sos! My God! Ay, nako!
I-upload namin yan, ano na, January 2 na ano ba?
January 2 na.
Para tapos na yung season.
O kasi mahirap kasi baka hindi nyo mapansin yung aming video at
Busy
kasi maghahanda kayo, magpe-prepare kayo, busy
Papaputo kayo.
magpapaputo kayo. Kami rin.
Papaputo ka ba?
Siyempre pare, ang gagamitin ko na yung plapla.
Papaputo.
Oo pa.
Plapla ba o
Plapla, oh.
watusi?
Hindi, what you see. What you see is what you get.
Kaya baka mo, baka watusi lang yan.
Ang gago, pikulo naman. Para maganda ang putok. Puk! Ang wato si pik 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 pik. Ay! Putay na! Monikawa! Pucha! Shout out! Minukawa pala, Monikawa. Name ng Gcash, Boss Rino. Lang Gcash, nag-send ako kay Baya.
Ang Gcash,
Baya Remedy.
ang name ng Gcash ay Mark Onerino.
O ha? Mark Onirino!
Basta yung Gcash na yan, oo.
Oo nga.
Mark Onerino.
Kachat ko yan si Madam. Minukawa?
Kachat mo yan?
Oo.
Biglang kachat ah.
Hindi, minikaniko ni Monica ang
Mechanic ko ni
Monica ang Miki, makina ni Miniko. Diba? Tama yun?
Oo, tama.
Oo, tama. Yun.
Yun na yun.
No, yun. Ayan.
Ano yan?
Ito ang pangalan sa Gcash. Basa ba, boy? Tingnan mo.
Boy, mali ko. Hindi eh. Uy, hindi ko maano eh. Layo eh. Baliktad eh. Paano mababasa baliktad?
Siguro sa kanila tama.
O, basa.
Basa.
dito.
Oh, yan. Yan ang pangalan ng Gcash, Mark Onerino.
Yan, bucha! Sir, trip niyo naman sa... Hindi nga pwede sa mga film center. Bawal.
Kaya nakakaahon na ako, boy.
Ah.
Nanlambot talaga ako doon, boy.
Mm.
Lalo ako natatakot Si Bal, simula na monetize, tumapang.
Di boy,
Mukha
kanina...
ka talagang pera, boy.
Hindi, boy, kanina kasi... May ano tayo, di ba? Oh.
Then, isang araw ka pa nagayakag sa barracks, bari. Tapos, alam mo bang gusto niya puntahan yung Yulo Mansion? Parang nakakatakot doon.
Pare, yun ang malupit.
Yung lugar na yun,
Ng gubat yata.
parang yung lugar na yun, ay, naka-isolate talaga yun pare dito sa Kalamba.
Oo.
Yun ang pinakaliblib na lugar sa Kalamba, pare.
Nandun daw lang.
Walang nakatira doon.
Meron daw dong ano, kapre, may ano.
Pare, puta, nakatakot talaga doon. Gusto niyong puntahan. Ah,
Pare, doon daw maraming nilalang na ano, espiritu. Oo. Yun ang pinakamalupit.
Oy, Donna Canupin, basa!
Donna Canupin, basa daw. Anong basa? Bakit? May ano pa ba?
Basa daw yung ano pinakita ko kanina.
Basa. Anong basa?
O, Gcash, si Noe Sobrepena.
Noe, sobre pena. Magkano pinadala?
10,000 pesos!
Puta, 10,000. I love you, we love you, and we love you.
10 pesos.
Pulang bahay.
Bahay na pula.
Bahay na pula. Hindi na bahay na pula ngayon. Dilaw na.
De, ito yung mga pinapadala nyo, Gcash, yung ano, yung
Stickers. Ganyan.
super chat. Yan ay, ang susunod natin La Union, no?
Lawin yun.
Paano yung message mo si, si Jeff,
Oo.
napuntahan yung ano, yung
Ay, oo nga pala. Nandun siya, no?
ano siya, di ba? Yung, ano tawag doon?
Yung Cresta del Mar.
Oo. Para sure tayo, tapos, mga 3 araw tayo doon.
Sige.
Magbabayad kami ng tao para may magbabantay sa gym ni
Nibal.
Nibal.
Bal.
Sabi ni Gilin.
Tingnan mo to, may pinag-uusapan dito. Ito pinapansin mo. Anong klase ka?
Pinatay ko si Bagdona Canupin!
Tingnan mo, kung hindi kita kasama, wala kami napapag-usapan ba rin.
Kaya mag-usap muna kayo. Ako tumitingin dito eh.
Tingnan mo, anong klase ka usap tong hayop na to? Ka-stress to kausap eh. Walang ano.
Ang tanong, ilang araw ba tayo doon?
3 nga.
3 days. Pare, tirahin natin ng Biyernes. Biyernes, Sabado, Linggo.
Oo nga. Basta
Para ang
yung
bantay
titirahin
lang.
natin yung Cresta, ano.
Basta
Pero
ano,
gusto ko puntahan nyo, maganda eh.
Hindi, ano,
Actually,
nakatakot talaga doon.
yung mga ganon, boy, yung mga ganon, mas gusto ko siyang suluhin.
Oo.
Kasi worth it. Katulad ng diplomat. Di ba? Ando ka na eh. Worth it na eh. Pero susuluhin mo yung horror house, tangin na yan. Parang hindi worth it eh. Tapos, di ba? Eh, doon sa diplomat, kung may makita kang multo doon eh, diplomat
Oo,
naman yun.
diplomat.
Diba? Yung Cresta del Mar, parang maganda eh, no?
Maganda yan.
at saka boy, yung ano yung horror house boy, delikado kasi.
Isa lang lalabasan mo sa horror house eh.
Puta, lulong ka sa bintana.
Oo,
Puta, masugatan ka pa doon sa mga bakal.
Problema daw pare, yun nga, at tatalas ng mga stainless, yung
Oo.
mga yero-yero.
Oo.
Pero yun boy, mahirap.
Yung twin mansion naman, ang laki kasi, ang hirap suluhin. Tagal mo dun ah.
Sa Twin Man.
Ilang minutes yung video mo?
25.
25, solo pa siya. No?
Ako,
Parang
ikaw
diplo-
ilang minutes yung video natin? Ano ko, less than 20 lang eh.
Kanina.
Sa'yo.
Oh, less than
20
20.
plus yata sa akin.
Less than 20.
20 plus pala sa akin. 20 plus.
Less than 20 sa akin.
Ang laki.
Kasi naputol.
Hindi pare,
Kasi naputol eh.
Ang problema kasi sa ano, sa twin mansion,
Mm.
yung isang ganun mo, ganun pa pabalik.
Oo.
Hindi ka tulad sa diplomat, iikot ka lang,
Ikot ka
tapos
lang,
bababa, labas ka na doon kasi gaganon ka, tapos babalik ka
Doon ka pa rin
sa
lalabas eh.
start.
Kasi tinignan ko walang lalabasan.
Wala, nakalak lahat.
Bintana eh.
Nakalak lahat, nakalak lahat.
Kaya
Nakapako.
nakakatakot suluhin.
Nakapako, nakapadlock.
Oo.
Hindi pwede.
Yung pangalawa, yung pangalawang ano, sa Twin
Oo.
Max.
Tapos dadaan ka pa doon sa ano, yung duktungan.
Oo, yung haba, yung-
Takot kayo.
Annex.
Annex yun, tama,
Nakita
annex,
ko sa
oo.
ano, sa camera, ang ganda yun. Pang
Oo,
horror.
pang-horror.
Ang galing eh.
Oo.
Hayop na yung twin na yun. Hindi ko masolo.
Kita mo na parang yung record ko naputol eh. Ang tahaba.
Oo.
Buti sinabi lang nito eh.
Oh, hindi napuputol ang record niya.
Oo, puta naputol.
Oy, doon sa Twin Mansion, dalawang beses nag-error,
GoPro.
namatay yung GoPro. Yung sa kanya naputol first time.
Oh, first time.
Tapos yung ghost
Hindi ko
tube ko nag-hang lahat. Tang ina, grabe
Tapos
na
pagkatapos
sa
natin, parang lambot na lambot ako. Yun.
Haunted pag... Haunted. Nanghina ka.
Parang nanghina ako talaga,
Hina
grabe.
ako, tamo ang hina.
Kita mo ngayon na siya naramdaman ako. Kanina, pinakagayan ako eh. Nakalugmok na ako, nag-uusap sila ni ano ni Cholo. Tama, mag-usap kayo. Nakagayan ako eh. Hindi ko kaya. Sabi ko, tayo na, nangihilo na ako. Ganyan pala yung boy.
Ganun yun. Pag yung mga ano,
Oo.
nanguha sa'yo ng energy,
Oo.
yung mga
Grabe no.
Ay, putang ina mo.
yung mga entity, ano yun?
Bakit ano yun?
Uy, 30,000 yun ah.
30,000 boy.
Talaga?
3,000 boy.
Oh, wow!
Si ano to, si Minokawa.
Minikawa?
Paano na
Oh,
boy?
pucha si Minakawa!
Shoutout mo pag 3,000.
Shout out!
Ano ba naman nga? Ayusin mo naman.
Shout out sa'yo, Minakawa! Wow!
I love you.
We love you! Hindi I love you. We love you! Ah.
Minakawa!
Kanina yung isa, I love you. Tapos ito, we love you.
We love you kasi lahat tayo.
Thank you!
Thank you, madam!
Set mo na yung ano po, may budget na tayo.
Oh, may 3,000 na tayo pang gasolina.
Sa ano? January.
Kailan niya?
First
loan
week.
niyo.
Okay, second week. First week.
Kailan? Ikaw ang lagi kami nag-a-adjust sa'yo.
Magkano ba kung tao?
Famous ka? Famous ka?
Siyempre, I'm famous.
We're famous daw. sabi.
We're famous. Siyempre.
Ano pa?
Binigay si Minokawa.
Meron pa.
Meron pa?
Shoutout kay Kenneth Encinares
Anong ginawa ni Kenneth Encinares?
ng Dubai Sugarol siya.
Sugarol siya.
Garol?
Shoutout.
Shout out.
12 pesos.
My God, we love you.
Ito wala eh, 100 eh. MG.
MG.
Ang apelid- ang
Morris Garage.
Minokawa, thank you!
Mang Minakawa, thank you.
Para sa ano yan, para sa explore natin. Lalo ako kinakabahan ito eh. Lalo ako napipilitan mag-explore eh.
May na-review ka na bang video rin sa ano, sa Cresta del Mar? Wala pa, no?
Pangit kasi yun sa inyo eh.
Hindi, may solo ko dun ah.
Meron ka ba?
Yung solo.
May solo. May solo ko
Wala
lahat
kita,
yun.
check ko nga.
Pero wag mong panoorin kasi magkakaroon ng ano.
Idea.
Okay lang sa'yo? Magkakaroon idea pagpunta mo
Meron ka
dun.
ba nun? Tago, wala.
Meron!
Baka, ay hindi, nakuha na.
Nag-send ka pa ng ano nun, ng sticker nun. Nung naalala mo, nag-send ka ng sticker ng 250 yata.
Oo, hindi ko lang siguro maalala.
Oo, di mo na
Pero
maalala.
napanood ko na yun. Yun pala yun.
Parang nagreklamo dati to sa iyo.
Bakit?
Hindi mo daw siya binati. Nagpadala ka sa kanya, di ba?
Hindi, pinati ko siya.
Binati ako.
Binati ka ba niya? Akala ko sabi mo hindi binati eh.
Nandun yun. Ano, doon ako.
Saan?
Yung ba yung pare yung resort na madilim
Oo, yun.
na sabi daw may nagpaparamdam? Yun ba yun?
Oo.
Parang napanood ko na yung vlog mo yun eh.
Lagi naman may nagpaparamdam.
Oo.
Pangit yung sa kanila, yung marami sila.
Gano'ng kalawak ba yun?
Ang laki nun.
Gano'ng kalawak nga? Hindi.
Siguro mga...
Isang hektarya, kalahating hektarya, ano? 10,000
Mas malaki pa sa ano. Sa,
Hoy, Jeff! Nandiyan ka ba, Jeff? Kunin mo yung contact sa ano, pupunta natin 3 araw. Dami, meron na tayong panggas, oh.
mas malaki pa sa ano, sa Twin Mansion.
Talaga?
Oo.
Hindi, malaki yun. 2 side yata yun.
Dalawang
Eh.
side, oo.
Talaga?
Tapos may rooftop pa. Basta ano.
Suluhin mo, Bal. Suluhin mo,
Ah,
Bal.
putang ina.
Alam mo, Bal, ako, pwede na ako di mag-solo. Kasi ang dami-dami ko ng video.
Pare,
Ikaw, mag-ipon ka ng video.
pare hindi ko magagawa yung solo.
Bakit?
Hindi na palundag ako. Ano ako si parang Leong Guerrero?
Kailangan mo ng video eh. Dapat pag tayo lumakad, ba, naka-4 akong video, dapat ikaw 6. Ganon. Gamitin mo yung utak mo. Huwag puro bunganga.
Lahat di pare, pag nakakita sa CR, mag-video na ako.
Oo.
My God.
Hindi, upo, mag-ipon ka ng video
Ba't parang
sa'yo.
lambot ka pa rin?
Wala mo. Pipilit ko nga lang eh.
Puta.
Ay, hindi ka
Hindi,
nagpagpag eh.
alam mo,
Hindi ka pa nagpag... Hindi ka pa nagpagpag. Lobas ka na ba doon? Dito. Diyan?
Saan? Kami, nandun.
Sa taas na taga.
Kaya tayo nagpagpag.
Hindi, galing na tayo sa
Pumasok
taas
pa kami.
eh.
Oo, ay sa bagay.
Ito na yung pagpag ko.
Oh?
Ang tawag dito? Hindi, ano, nabusog ako. Dami ko nakain.
Hindi, boy, iba ang ano mo eh.
Oo nga, baka
Iba, boy. Sigurado pare, lalaki yan.
Alin?
mamamagaya.
O mamamagayan.
Ang alin? Yung itlog ko?
Hindi. Isipin mo na lang kung ano yun. Ah, may nagpadala na naman! Si Donna Canupin!
O, dagdag nyo sa budget.
Oh, 23 pounds and 99 cents. Dagdag nyo sa budget!
Shout out doon na Kanupin!
Donna Canupin!
Thank you!
Ah, pare,
Dagdag sa budget. Oh, dagdag sa budget. Meron tayong budget, boy.
Sabi niya, may tao daw sa likod natin.
Hindi, mga bata, ayun, nagkukot,
Maniwala
ano.
Ano yan, boy? Set na yan, January, boy.
Oo.
Marami pang magtutulong sa atin dyan. Kasi malaki babudgetin natin doon 3 araw, boy.
3 araw.
Tsaka La Union
Mag-hotel
yun.
tayo nun.
Mag-hotel tayo nun. 5-star hotel.
Ah, shit. Hindi nga. Shit.
Kami, ikaw sa ano ka, transient ka lang.
Hindi, doon ako sa
Doon
kotse.
ka sa 150. Yung katayo lang.
Paano ka nakatayo? Nasayaw.
Wag, wag. Hindi na kaya.
Nakatayo. May aircon naman yun.
Oh, pare, at least nakabelt ka naman eh. Nakadikit ka para sa wall.
Pinipicturean si Boss Rino sa katabi naming kotse. Ayun.
Oo nga, no? Sino?
Hindi, tingnan, tanga.
Oo, oh, tignan. Huwag ka tignan.
Hello. Oh, shout out! Shout out!
Oh, kaya! Ba't ako magsha-shoutout? Hindi ka!
Sticker.
Meron kami dito, Sogo sticker. Pwede, gusto mo Sogo sticker?
Ha? Thank you. Ano pangalan? Lance. Shout out Lance Espinas. Shout out
Espina,
Lance
bravo.
Espina. Shout out mo. Shout out mo.
Shout out!
Ilan pa rin ilan? Taga saan kayo?
O, dyan na pala eh. O, dyan lang kayo. Dito lang kami. Dyan lang kayo. Dito lang kami ha.
Nagla-live kami.
Nagla-live.
Tiya.
Oh, shout out ulit. Ano sa aso ng bintana? Aso ng bintana? Teka, tayo na.
Kasi yung bintana doon.
Dyan na pala eh. Oh, shout out kay Donna Canupin! Tangina mo, tayo na ba nakatutok? Sel mo nakatain. Tangina.
Hindi ako naliwan yung mali ko ba?
Okay, nagulat nga ako eh. Takirang yan. Takirang yan. Ako nagulat din eh. Nakatutok pare, kita mo.
Ganun talaga.
Tinatako tayo ng mga viewers.
Oo, buta pare, ang dami mo stalker.
Sir Dax, may katabi ka po ba sa likod?
Hindi, lagi yan. Sanay na kami yan. Si Dax pa tinakot nyo.
Ligo po kayo. Di, pero ano, may mga, di ba nakamotor ako lagi? May pag gabi na may nadaanan akong mga nakatakot ng mga kalsada.
Saan?
Talagang sinisilip ko sa side mirror eh. Ginagano ko talaga side mirror kung may sasakay sa akin sa likod eh. Oo.
Mga nalalaman mo.
Ginaganon ko yung side mirror talaga para makita ko kung may
Talaga?
puti, o kung ba may puti na ano sa likod.
Gusto niya talaga may makita, boy.
Oo.
Pare, gusto mo? papaluin kita ng
Pati
kaldero.
ba yung sabi?
Tangina, makakakita ka ng bituin. Tapos,
Iba na
ano,
yun eh. May hilo ka
oo.
mo.
Anghel. Anghel.
Tangina, angel yan. Gano'n gusto mo, paluin kita. Pero isang palo lang.
Gusto mo pala may
Oo,
makita.
may makita. Parang sabihin mo kay Joe, kung gusto niya may makakita, papaluin ko isang palo lang. Full swing. Pongga.
Ay, yung sa ano, sa transient nun, dami nakikita ni Joe.
Buti,
Alam mo kasama natin si Joe, tsaka si Jay doon, si Jeff.
Ako sa tayo na boy.
Kagulo yung pare.
Hindi, paangasan nyo ng mga nakikita. Yung isa, black lady, white lady. Yung
Isa,
isa,
bata.
bata po, tangin na.
Masarap din pagsamahin yun eh.
Puta.
Masarap din
Tangin na boy,
pagsamahin yun
ang
eh.
lupit yun. Kita mo kagulo yung dalawa, magpapasikatan, pataasan ng ere yung dalawang yun. Tangin na yan boy.
Pangit rin yung shoutout ko doon, napag-ayos sa'yo. Shoutout na boss nila, ayoko nang ganun boy. Nahihiya ako.
Oo.
Hindi ko kasi alam yung shoutout eh. Yung shoutout, shoutout kita dito. Pero parang i-shoutout kita na ikaw yung kumukuha.
Oo.
Ay, pa-shoutout naman, hirap na hirap ako sa ganun boy. Kung ba, pag-shoutout ka sa akin, sa shoutout kita, kaya ko yun.
Oo.
Pero ikaw, halimbawa, ikaw, boss, pa-shoutout naman, tapos nakatutok mo sa yung camera. Kasi shoutout kita,
Oo.
andito ka, ang hirap, di ba?
May ano sa ganun.
Shoutout sa'yo, Bal, Baliw, ganun. Eh, dyan ka lang eh.
Tarantado!
Ginagawa ko daw, shoutout sa'yo, tapos pinapakita ko sila sa camera. Binibiro ko na lang na, oh, dito naman itong mga to eh, ganun. Pero shoutout, ang hirap pa yan.
Teka pare, mabalik tayo dun kay kay Third Eye at saka kay kay Joe.
Hindi ba na naman niya?
Pare kanina nandun tayo kay Third Eye at
Kaya
saka
ako
kay
nang
Joe.
lalambot sa'yo, hindi ba mo na naman
Nandun tayo
usapan?
kay Third Eye at kay Joe.
Hayop ka!
Pare nandun tayo kay Third Eye at kay Joe. Bigla ka naman sumingit doon sa nagpapa-shoutout.
Eh kasi umalis sila eh.
Kaya mo na sila, mga lintek.
Hindi nila kilala si Joe. Si Joe yung yung kasama namin sa
Saan? Sino? Sino Joe?
Sa diplomat,
sa diplomat.
yung POV ko.
Oh, yung
Yung upload ko yung
POV.
POV eh.
Oh. Yung sa Team Kilabot,
Oh, yun.
Si Joe Piles.
Joe Files.
Joe Piles yun, Joe Piles.
Joe Piles.
Yun yung dancer ng Itbulaga, si Joe Pai.
Joe Piles!
Joe Pai, di ba? Tama ba yun? Yung, si Joe Pai, no?
Oh, yun nga yun.
Yung sa Itbulaga dancer, kasama ni ni Pangilinan. Tama ba?
Oo na, sige na, putang ina.
Kwento na, dali yung
Oh, ano na balita?
O yun, tapos anong nangyari? Saan?
Ikaw nagkukwento ah. Tanga nito, dapat yung usapan namin kasi gawa ni Joe Piles sa kanya, no? Tapos sasabihin mo sa amin, ano? Ang tanga mo na kwento, uy. Ang hirap mo kasama.
kwento. Ewan ko, ano ba yun?
Mamalay ko. Ano ba yun? Ano ba yun?
Nagulo na.
Iniisip ko parang akong tanga doon siya.
Tapos ako kakalad ka din mo, gagahigitin mo yung ulo ko, tarantado ka, pakialam ko dyan.
Hindi, akala ko kasi napapanood niya tayo sa live. Eh, doon tayo mag-shout.
Yung pala, binibidyo ka, tanga. Oh, ha?
We're famous.
We're famous! Yuri Bernardo!
Wala, nakita mo na boy, wala kami na mapag-usapan dati.
Pare, ganyan kami, magulo. Puro na out of the world. Oh, Yuri Bernardo, shout out from Japan. Oh,
Ito boy, shout
Makaya
out.
naman.
Shout out Bal.
Oh, Bal.
Nakamukha ni Palito by Lester.
Ah, shout out Lester, hayop ka.
Pare, sabi niya kamukha mo si Palito
Oh.
kasi nagbigay siya ng 4 pesos.
Oh my God! 4 pesos, I'll give you 5 pesos!
Gulo mo ba?
Kaya tagulit ako ba nakaganyan yung
Hindi ko na nakikita.
Nakita ko nga eh.
Tingin ko, pwede yan. Ayaw mo tumingin, nakaganon ka eh.
Eh dito ko nakatingin, mali ka ba?
Ayaw mo tumingin. Hindi, wag niyong pansin, wag niyo.
Hindi ko alam.
Kaya nga eh.
Sinabi lang niya.
Ano, gulat
Ay,
na.
hindi, sinabi mo na
Oo.
nakatutok.
Oo,
Yung camera.
Pero hindi ko tinitingnan. Pero hindi ko talaga, nung sinabi lang niya.
oo, takin na yan.
Sabi mo, huwag natin.
Sabi mo kasi
Hindi, akala ko naman, malayo. Yung pala yung kotse.
yung kotse yan sa tapat, puta nagulat ako.
Shoutout sa inyo, yung nakawigo dito sa tabi namin.
Hindi namin alam pangalan. Ano ba pangalan nun?
Hindi na nakalimutan na. Nakalimutan na.
Nakalimutan ko agad, Jessie.
Oh, Jessie.
Jessie?
Jessie
what?
Mendoza.
Ha? Talaga nalambot ako.
Nalabot ka na rin? Ako medyo na-recover na ako eh.
Dun sa ano yun. Twin Mansion.
Ang dami tuloy gustong sa atin, boy.
Ano?
Dami tuloy gustong sumama sa atin. Kasi biruin mo, nakapagpasikat tayo ng chonggo.
Oo, pare. Tapos biglang nawala, kumalas agad. Pare.
Isang buwan lang yun, monetize agad yun.
Wala
Kumalas
nga isang
agad.
buwan eh. Ha?
Kumalas agad.
Oo.
May grupo agad.
Ganyan natataga mga unggoy eh.
Oo, pare. Naghanap na kanyang tribo.
Di ba?
Naghanap siya ng kapwa true
Sabi
unggoy.
ko sila, nakapagpasikat ng unggoy, tao pa kaya?
Oo, pare. No? Hindi, pumunta siya sa kanyang katribo.
Kaya, huwag naman gabi.
Hindi, tribo niya na ano, pare. Ang lupit nga eh.
Hindi, okay nga yung ginagawa ni Jeff eh.
Oo, tama yun. Sige.
Bilhin mo ako kay Jeff.
Alam mo,
Nag-resign na yata.
sabi ko din, may mag-resign
hindi pa
ako.
hindi pa sumusweldo sa YouTube, nag-resign na yata ang puta.
Kita mo, sabi, pinagmalaki pa, monetize po ako.
Paano daw yung setup?
Na-monetize na daw siya pero wala pa siyang ads. Kasi sa paano daw i-on yung ads eh.
Kailangan yung setup pa yun.
Kaya pa yun eh, ba naman yun?
Magbasa ka na lang sa
O
YouTube.
sa YouTube,
Tanga!
may tutorial.
Kala mo naman, alam niya, tanga.
Tanga rin ako eh! Pareho lang kami. Ay nako, sakit daw
Sabi
na.
niya, sakit ang tiyan niya. Wala naman tayong ginagawa.
Bakit? Masakit ang tiyan niya. Ah, baka
Sakit
nabalis.
ng tiyan ko.
Baka tayo mo lang yan, tayo mo lang.
Si Pauline Mendoza, sakit ang tiyan.
Oo, ay.
Boss Rin ng malakas.
Ah.
Asan?
Ay no. Boss Rin lang, saka lang.
Biringan Summer, ang layo ng Biringan Summer.
Ang kulit ito mga to, yung Laperal Mansion daw.
Wala na ngayon laperal. Tangina, naging
Mahal
ano.
dun. Masantad yung ano, yung presyo.
Oo,
dun.
Yung
restaurant
presyo.
na yun eh.
Oo.
My God.
Matatakot kami doon sa presyo ng ano, restaurant.
Grabe no, presyo.
Oo.
Tangina.
Pinakamurang nabasa ko, 7,000 eh.
Hindi ko na pinansin eh.
Hindi, may 400,000 ako. 400,000. 475 yata yun pare.
Baka
Parang
tubig.
appetizer lang.
Appetizer.
Grabe no. Ginawang fine dining. Yung tawag doon fine
Mahal.
dining.
Sa Laperal House, mahal.
Mahal?
No? Baguio.
Ba't pinipilit lagi nila Campo Bello?
Ganda kasi din eh. Ako din gusto ko
Wala
yung
na
Campo
eh.
Bello. Wala na talaga.
Wala eh.
Eh, paulit-ulit sila Campo Bello.
Wala na yung Capo Bello eh. Ano
Ano?
na eh? Oo.
Maganda yung Campo Bello.
Maganda sana yun, oo.
Luma no?
Sayang.
Iba ambience doon, Campo Bello.
Talaga? Ano kalawak yun?
Mga isang ano,
Isang
twin,
hektarya?
Isang twin.
Isang twin mansion?
Oh. Pero
Bali
ano lang siya.
bali,
Oh, tama, may second floor, tama, isang twin
Bali
mansion.
1,000 square, ano?
Oo.
1,500 square meter ng ganun.
Mm.
Malaki yun boy.
Isang
Ah hindi,
twin
malaki
mansion.
yung twin mansion eh. Mga ano yun boy?
Tapos
Mga 5,000 square meters.
Tapos nasa gitna siya ng gubat.
Oh, alam ko yun, napuntahan ko na.
Tas-
Alam ko nakapag-taping na ako.
Nakapag-taping na kayo doon?
Probinsyano.
Iba yung tunog
Kaya
ng
lang,
paligid,
hindi alam ko luma, pero ang dami naman namin dun eh. So
Oo.
hindi ko...
Ay hindi mo na ano?
Oh, daming crew doon, daming crew, daming artista.
Kasi wala na yan boy pag marami, wala.
Oo.
Wala ka na maano doon.
Pero alam kong old school talaga yung bahay.
Iba yung tunog ng paligid dun eh.
Iba?
Oo.
Paano
Di ba
tunog?
nasa paligid dyan, puro puno?
Oo.
Hindi pa
Yung
paano
kuliglig,
tunog?
ganun, kuliglig.
Ah, yung kuliglig. Yung huni ng kuliglig.
Para Rizal yun, layo, isa may tanay.
Tanay.
Ah, tanay na.
Tanay yung bahay.
Lampas pa sa Teresa?
Oo, lagpas pa.
Lampas pa naman Teresa? Ang Teresa bungad lang. Pagbaba yun, pare nag-try na ako pumunta ng Teresa eh. Pababa yun. Iba akit ang mundo,
Wala bang
bababa.
shortcut? Alam ko may shortcut ng Laguna eh.
Oo, nagpadala ulit si
Mino Kawat!
Mino Kawat!
Shout out, thank you ulit.
Oh, thank you.
Try nyo yung Bolinao, Pangasinan.
Ang layo, Bulinaw.
Bulinaw, Pangasinan.
Lighthouse?
Lighthouse.
Ang Teresa bungad lang. Alam mo yun?
Yung puting lighthouse.
Eh syempre, hindi naman pwede maging pink yun.
Oo.
Pangasinan, La Union, malapit lang yung Pangasinan eh.
Hindi, yun yung
Pero
ano.
La Union tayo eh.
La Union.
Pare, yun yung pinunta
Pag
natin.
diniretso mo,
Sabi natin,
Barbara.
dapat matarget natin yung
Crestamar.
Cresta. Tapos, saka natin tirahin yung iba. Pero
Oo.
hindi dapat nang matira natin.
Yung Cresta del Norte.
Meron naman iba mapupuntahan si Jeff eh. Kasi napuntahan niya na eh.
Oo.
Oo.
So kasama natin si Jeff doon. Sa La Union. Okay na sa'yo?
Okay lang naman. Pare, pero mataas ang ano yun, cannot be reached na.
Oo nga eh.
Oo.
Hindi na ma-reach yung mga ganun, pare.
May TF na
Kita
yata
mo,
si
ang
Jeff.
sabi niya eh, I'm guest daw siya.
Guess niya eh.
Pare,
May TF yun.
May taas ang TF na
May
yun.
taas sa TF nun.
Oo, tapos kita mo, may dahilan na naman yun, boy. Pag niyakag natin, Boss Bal, Boss Rino, hindi ako pa pwede. May guest na naman ako eh. Paano ba yan? Oh,
Hindi, nag-live siya. Pinaliwanag niya na
ano?
wala daw siyang grupo. Kasama pa rin daw siya sa team sa Team Ghost Fighter.
Wala ba? Sabi niya meron.
Sabi
May
niya.
grupo na siya pero kasama pa rin siya sa atin.
Wala naman tayong grupo eh.
Wala naman kaming grupo eh. Kasi ang grupo namin, grupo kami.
Wala po kaming grupo ha.
So, hindi kami nagguguhan ng
Kanya-kanya
grupo.
kami.
Sa investigador J meron.
Kami ay kanya-kanya pero magkakasama kami.
Magka-collab.
Mahirap yung may grupo.
May yung team.
Yung kami, ang grupo namin ay mutual.
Yes. Kami ano lang, basta nagtatandem lahat kami. At saka nagkiklik ang vibes, okay na. Masaya na kami doon.
Kahit sino pwede namin i-grupo.
Oo. Oh, ganyan kami.
Sino pwede sumama?
Kahit
kahit
sino
sino.
pwede sumama.
Di ba may kasama tayo si Ai Ai?
Si Trixie.
Si Trixie. Yun si Ai Ai.
Ipoposas natin
Poposas namin yun.
sa'yo.
Tapos pare, pagka tumakbo, buhati mo.
Bubuhati ko pare, ang litli. Saka makakita ng 4'9".
4-9 ba yun?
4'9". Oo.
Tawa to sabi ito, maitin daw kiligay ni Trixie.
May
Bakit
tao.
tinignan mo?
Sa live,
Nakita
sa
mo?
live. Sabi ko, paano mo nakita?
Nakita mo ba yun?
Hindi inangat eh.
Madilim yun.
Eh madilim, di maitim.
Ah.
Di ba? Pag
May
inangat
baka
mo,
nanonood
madilim.
dyan, nakakaya.
Trixie.
Kausap nga namin sa
Kausap
live,
nga
sinabi
kagabi,
niya.
yung gabi, oh,
Sabi ko,
nakakaya.
yan di ba yan si Trixie yung maitim?
Kagabi ba yun?
Hindi, nakarang ano yan. Di ba sabi ko, di ba yan si Trixie yung maitim ang kilikili? Hindi, parang mo nalaman. Kasi tinaas eh, madilim, di na maitim.
Grabe.
Ay,
Trixie,
nako.
gusto ko makita yun. Yung tandem yun ni Trixie boy.
Hindi mo pwedeng hatakin yun kasi babae yun. Tapos ano?
Oo.
Alagaan mo yun.
Pare, bibit-biting ko yun, nakaganyan.
Ilan taon na ba si Trixie boy? Bata pa yun.
23, 24.
Ang ina, doble ng edad mo.
Oh my God. Pero maliit lang yun boy, madali yun.
Sama daw si Joanne boy.
Sino Joanne?
Para daw makasama kanya. Ba't di lang kayo mag-ano?
Kaya mag-vlog na lang kayong dalawa. Diba, no? Tama.
Ba't di kayo pumunta sa ganun?
Oo. Joanne! Punta kayo sa ganyan.
Layo eh. Layo niya eh.
Oo, okay, sa 150, sagot ko na.
Oo, sa 150. Nakatayo na lang kayo.
Tayong sayaw.
Tayong sayaw, kaya.
Sabi, pogi talaga si Doc.
Oo, pumunta pare. Pogi ka lagi. Nakakaano. Usapan dak. Teka, usapan dax tayo. Patapunta tayo ko ano kung saan saan.
Yun eh.
Ikaw eh, bago ka nang ano eh.
Ayan, oh.
Usapan Doc
Yun
na
yung
tayo
usapan
eh.
eh.
Oh, sabi ni ano,
Oh, pwede ka ba doon?
pwede, boss, pwede ba ko bang ligawan si Trixie? Hindi nga po pwede. Bakla yun. Kami lawit yun. Teka, usapan dax tayo.
Ang galing buyo, tara mga boy. Si Third Eye, inimbita ng subs niya sa La Union, all expenses paid. May haunted beach resort daw doon, puntahan nila.
Wow.
Tsaka yung ano, Cresta.
Putang ina boy, ang lupit, no?
Hindi, beach daw eh.
May ganun.
Pare,
Pare, daig pa talaga tayo. Pero mo, all expenses.
All expense paid.
Sagot
Paid.
ng subscriber.
Tayo.
Kaya pala nagpapaderma ng butang ina. Hindi mo nakita itsura, kumikinis. Ginagamitan na pare ng ano, masilya.
Masilya.
Oo, pare.
Puta, akala ko kandila.
Hindi, masilya.
Pataka.
Hindi, masilya pare.
Hindi, puta.
Roller yun,
Pare,
di ba?
daig pa tayo.
Hindi,
Derma
oh,
roller.
hindi.
Derma
Kutsara
roller
yun
ba
pare, kutsara.
Boy,
Ginaganyan.
daig pa tayo.
At saka ano, palitada,
Pare, daig
pinapalitada.
pa tayo. Bili mo, nilibre siya ng subscriber niya.
All expenses
All
paid daw.
expense paid. Hindi tayo ang sinama.
Oo,
Iba ang sinama.
ayop,
Dapat
boy.
tayo.
Ibang sinama,
Sabi ko
boy.
sa'yo, boy, masama.
Sinabi ko sa iyo eh.
Masama ugali.
Alam mo yung mga Planet of the Apes, hindi talaga pagkakatiwalaan yung boy eh.
O, iba na natin, boy.
Sinasabi ko sa iyo, boy eh. Ang hirap turuan ng mga Planet of the Apes talaga eh.
Unggoy talaga ang pagkaugali, no? Unggoy.
Ang hirap talaga, boy. Hindi mo kaya i-disiplina.
Oo.
Dapat tayo sinama. All expenses paid.
All expense paid. Tapos pagkasama natin,
Oo,
hindi
tayo
na lalabas kahit piso.
Oo, tangina, bakit nautakan tayo? Hayop na yun, ah. Ay, nagago yun, ah. Pag nakakita ko, papaluin ko yun ng triple extra rice.
Triple X.
Oo, tangina. Pasasampalin ko na yun.
Ayan yun.
Sabi mo, pare, wag na natin sama yung hayop na yun, ah.
Hayop talaga, boy.
Ito mo, all
All
expense.
expense paid. Tapos hindi tayo, nawala yung ano ko, nawala yung paglalambot ko, boy ah.
Tangina, nagulat ako.
Para akong ano, para akong nagagalit na ano ah.
Tangina,
Ang lupit
All
daw.
expense paid, hindi tayo sinama.
oo, tangina.
Ang lupit daw sabi ni Ma'am Donna.
Nakita ko naka-check-in pa sila, boy. Yung live niya kagabi.
Di ba
Naka-check
kanina?
in sila.
Yung kanina naka-live, di ba?
All
Oo,
expense
yung
paid,
ngayon,
naka-check
oo,
in tayo tayo sinama, boy.
Kaya pala kita mo itsura,
Sabi siguro nung subscriber niya, sige libre ko kayo last gastos ko, magsama ka kahit sino.
Oo.
Tapos,
Kung hindi tayo sinama.
Ang hayop na, unfair talaga, no?
Unfair,
Namili pa rin ng tropa.
Kasi kasi taga-planet Earth tayo eh.
Oo, pare, ang hirap talaga may ano. Oo, Planet of the Apes, puta inang
Tabla,
yan.
tinabla tayo.
Oo, puta inang yan, no. Shit, ano kayang balak natin, teka pare. Nag-iisip ako, pare, mag-hire ako
Sino ba
ng
yung
ano,
nagsumbong? Sino ba yung nagsumbong na yun?
mag-hire ako ng hitman, puta, papapaluin ko yung mukha nun ng saging. Saba.
Saging, gago, lalakas yun. Pag sama, huwag saging.
Ano?
Huwag saging.
Para ano, pare, ang lupit no, tangino all expense
All
paid.
expense paid, tapos hindi tayo sinama.
Ayun ang yan.
Pagka nasa McDo tayo, grabe pa maka-order.
Tapos pare, ang sabi po, talo kayo ni Third Eye. Tangina pare, sabi ko sa'yo, wag natin isama na yun eh.
Ginatungan
Oo, ginatungan pa tayo pare.
Ginatungan pa
Tapos
tayo.
sabi ko sa'yo pare, nakita ko yun, mukhang hold upper yung hayop na yun eh. Kita mo?
Hayop na yan. Sabi niya, mahirap
Oo.
pag-unggoy eh.
Oo pare, iba talaga.
Tuso talaga boy.
Tuso?
Tuso talaga ang matching pare.
Oo, napaglilin lang din.
Tuso man ang matching, papaglinlangan din.
Pare, totoo pala yung kasabihin na
Oo,
ganun.
totoo pala yun pare.
Matching pati sila.
Pare, iba na natin ha.
Grabe yun pare.
Isama mo muli.
Bakong sa third eye.
Matutas pare.
Tapos mo sa
Sabi niya, iba isasama ko para hindi ako sapaw.
Oo, tangina para siyang
Para siyang bida.
Gago ah.
Bida. Pare. Para siyang bida.
Share naman bida sa atin eh. Di ba?
Di ba, kamukha nga niya yun, yung sa Planet of the Apes,
Oo nga,
yung bida doon.
pare, kaya ito, gusto
Di ba bumuo ng sariling grupo yun?
Kaya parang may nagsabi na mautak talaga.
Si Albe yun nagsabi yata eh. Albe.
Oh, sabi ni Noe TV, boss, 10k daw bayad kay Third Eye!
Oh, putang inang yan.
10k!
Ano boy, ang lupit
Legit
no?
ba yan? Legit.
Circus siya. Circus ba yun?
Hindi, siyempre pare, sumasakay sa bola eh, nagpapagulong-gulong siya.
Grabe, ibang klase.
10k.
Sabi ni Chubby Chicks, ay nako, ay unsubscribe ko na nga yun. Ay, nagbibiro lang kami.
Huwag naman.
Ay, nagbibiro lang kami.
Nagbibiro lang kami, ah.
Huwag nyo unsubscribe para naman kayo. Ayun, nagbibiro lang kami.
Iban nyo na, wag nyo na. Iban nyo na lang.
Hindi, huwag nyo unsubscribe.
Nagbibiro lang tayo.
Kasi,
Kasi 10k sabi niya.
kasi kung isasama naman kami niya, hindi rin naman kami sasama eh.
Sabay bata ka po.
Huwag nyo unsubscribe, bibiro lang namin.
Huwag niyo
Ito naman KJ eh.
Hindi, wag niyo subscribe. Ano nyo iban nyo.
Tinitira pa namin, bumalit ka naman ng ganyan.
Walang yan. Wow, 10k. O, kita mo pare, ang dami wow, 10k. Hindi po 10k, grabe.
Grabe, iba na talaga.
Report ko na siya. Nire-report na nung iba.
O,
Gago,
report mo na, i-report mo na.
Gago!
Fundraising daw para sa triyong bitter.
Mag-fundraising kayo. Trio, bitterness. Walang iya eh. Ayop.
Andun pa yung
Ang lupit
momentum natin eh.
May magsusumbong na naman dyan. May nag-live siya, oy, inaano ka nung tatlo. Mamaya, text na naman sa akin, nagpapaliwanag na naman dyan.
Pare, ano sabi ni Joan? Boss, ni-report na daw si Third Eye.
Wag yung report. Biro lang yun, biro lang. Happy kami sa kanya, ano ka ba?
Happy na kami. Kahit sana maging maligaya na siya sa buhay niya. Oh, bukas ulit sa Gcash.
Dito na ba kami nag-gigas kasi, papabati.
Alam mo, hindi na namin poposas yan. Puta, ibibigti na namin.
Cedric, sabi na-report niya na daw. Huwag niya report. Nagbibiroan lang tayo.
Mag-report lang, sa paling kumuha nyo.
Wala nga eh. Oh, ha? Si Third Eye may kinakausap na naman na multo. Ay putang na pare.
Shoutout daw kay Balbaliw, kamukha ni Bentisoy.
Ya puta, balbaliw, thank you.
Padala ng piso.
Piso para sa puso. Ay, nako grabe.
Tawa kong tawa. Pag si Third Eye talaga, tawa tayo ng tawa, no?
Uy.
Mamaya, may pag nag-live yun, may magsusumbo.
Nakalive yan eh.
Nakalive pa rin ngayon.
Tingnan mo ka nakalive na yung hype na yun. Ayun.
Ah, hindi na.
Hindi na, wala na.
Nakikinig yun sa atin.
Walang iya eh. Talagang nagulat ako, no?
Oo nga, tama. Oh. Sabi kayong dalawa naman mag-posas. Mag-posas tayo minsan.
Oo, sige.
Hindi naman ako natakbo eh.
Oo nga.
Na para iba naman. No? Pasay pa yung posas. Pasay pa ba yung susi?
Sa akin.
Isang
Ayun
susi
nga eh.
lang.
Parang isang susi lang yung dito sa akin.
Next time magposas tayo, tayong dalawa.
Oo.
Dapat kayo natin ginawa no?
Hindi man dun, ano, mahirap.
Sa twin?
Mahirap sa
Ay, mahirap magtakbo-takbo dun.
Hindi naman kami tatakbo.
Pag hindi, matatakot talaga dun eh.
Ito lang.
Pag may nagparamdam eh, oo.
Hindi, at least tayo, alam natin na...
Ilang percent? 10?
Hindi mo talaga, meron naman akong chat.
Ito yung susi. Ito yung posas oh. Kaya lang yung susi.
Yung susi, meron pa.
Hanapin ko. Yung isa, nung dito.
Ito lang pare masakit dito. Ayan, ito. Ayan,
Matalas.
Ito, talas.
Ah,
Ramdam
no.
mo eh. Ramdam.
Hindi, pag ano, pag tayong dalawa, hindi naman tayo magigitan eh. Basta
Ito yung
yung,
isa lang kasi.
yung content lang na nakaposas.
Iwan ko na kaya dito to.
O, iwanan mo na yun dyan, boy.
Ang problema kasi pare yung
Yung
isa.
susi, pare, yung susi.
Yung isa makate parang buhok. Ang magulo.
Alin?
Sino pa yung kaposas ko?
Si Bentisoy.
Si Bentisoy.
Boy, shoutout mo daw to.
Paano ko maintindihan yan? Alam mo magpapa-shoutout ka, Chinese, Chinese po, Japanese to. Oh, from Calamba, Laguna. Paano kayo bungot naman to? Hoy, ayusin mo! Grabe, no?
Japanese.
Pero pare, all expense paid.
Oo, tas 10.
Totoo kaya
tas
yun?
10K.
Pag-isip ako eh.
Hindi, totoo naman yun. May ganun.
Walang hiyo.
Sabi ni, nagsend daw si Jazz. Jazz, wala pa, inantay ko pa. Yung Gcash.
Just, nag-send ako
So,
Gcash.
thank you in advance.
Okay, shout out sa
Oo
iyo.
nga, mag-poses tayo, boy.
Ano, sige. Pero
Next
wag
na
ano,
natin.
wag lang maghatakan.
Ba't naman tayo maghahatakan?
Kasi yung isa hinatakan.
Ginagaya mo naman ako sa unggoy eh.
Oo nga pare, mahirap talaga. Ibang utak ng unggoy eh.
Hanapin ko yung isang.
Bakit ha? Di ba nata?
Hanapin ko. Isa lang yung dito, di ba dalawa?
Hindi, nasa akin yung isa.
Kasi isa. Ito, isa.
Kasi yung ano, yung
Posas.
posas.
Ito sa likod.
Nasa akin yung isang boy, alam ko nasa bag ko. Naghiwalay tayo eh, kasi baka ano.
Oo nga pala.
Wala ka ng plastic dyan, para magkasamang plastic na to.
Na-scam daw tayo ni third tayo.
Ang galing talaga no? Sige, ano.
Na-scam daw tayo ni third eye.
Paano na-scout?
Pag nakita ko yan, bibigyan ko ng black eye yun.
Ay, nagsusumbong talaga. Totoo yun, Boss Bal. Subscriber ang sumagot sa gastos.
Grabe, pare.
Kita mo? Si pare yung malupit.
Huwag ka na ba inggit? Meron ka ng GoPro! Ano? Mas malupit ka pa rin! Ano na, inggit ako.
Pare, expense paid. May 10k pa. Ikaw na.
Oo, no, expense paid, tapos may 10K pa. May GoPro ka naman eh.
Oo nga. At least
May tripod ka.
Hindi boy, happy ako kasi magkakasama pa rin tayo.
Oo, yun.
Yan ang mga ano pare. Di ba?
Mm.
Tama ba?
Tama. Oo.
Yan.
Susunod, pag sinama natin yan doon, iiwanan natin yan doon.
Oh, mag-commute lang siya, no?
Oo,
Total, may
kumusta na
10k siya eh.
Oo, may 10K ka naman eh.
Oo.
Ayun na mo.
Ayup tayo. Pare, na-scam tayo talaga.
Yun, no, 10K. May 10, puta, guess niya siya.
Oh, pare, kaya nga. Ang message niya sa atin, guess siya.
Guess siya.
Guess siya dun sa,
yun?
ano.
May TF yun pag ganun.
Oo.
Talent fee.
Puta lang yun.
Grabe.
Pare, na-scam tayo talaga.
Hiningan ako kaya, no? Eh, live ba siya?
Hindi na.
Hindi na, wala na nanonood, lumipat na sa atin eh. Sir Dax, anakan mo ako.
Tayo dyan. May TF din yun.
May TF daw yan. Ay, may TF daw yan. Ay, si Ma'am Donna Kanupin. Oh, puta ba lumalaki, 23.99. Para sa mga bitterness.
Para sa tatlong bitter.
Ay,
Bitter talaga. Nakakahinayang pare. Tayo na. Pero yung mga, pare magkano yun pare? Tatlong araw sila doon. Ang dami nila. All expenses paid. Pati pagkain magkano doon. Tapos may 10K pang TF. Gaano kasigat yung hayop na yun?
pare, iba na talaga.
Saan ka ba naman nakakita? Unggoy nag-e-explore.
Pare, hindi daw kayo makamove on sa scam.
Scam ba?
Bakit kami? Ikaw din ha? Ikaw din ha?
Hindi daw tayo makamove on sa scam. Taka. Hindi kami. Tayo. Tayo na gano'n.
Ay, nagago, hindi tayo sinama. Hayop na yun.
Tarantado mo.
Panay pa naman ang alok ko doon. Gusto mo magkape?
Oo.
Diba?
Tapos cobra yun sa gym mo.
Oo, tang-ina.
Nilibili pa ng cobra yun.
Oo.
Nangyam Ayop na yun. Pinakain natin ng ano, ng baliwag.
Oo.
Di ba yung sa mukbang?
Oo.
Ng ano, crispy pata, boy.
Oo.
Tapos hindi tayo sinama, all expense paid.
Oo.
With TF.
Pero yung pare, nandun siya sa La Union. Hoy!
Oh, teka, tumitingin ako baka mabangga eh. Biglang kumabig eh.
Tingnan mo dyan.
Hindi kumabig eh.
Iba, kakaiba yun.
Kakaiba yun eh. Iba eh. Kaya napalingon ako eh. Oh, sige tuloy.
Wala na.
Oh, kwento.
Tignan mo rin kasi.
Oh, tumingin ka kunyari hindi mo nakita.
Hindi ko maintindihan pare.
Yung driver.
Hindi ko mag-gets.
Oh, sige, kwento ka ba kunyari hindi mo
Wala,
alam.
wala na sa, wala yan.
Wala. Balik.
Pare,
Oh.
nagpunta siya doon.
Oh.
Libre siya.
Oo.
All expense paid.
Oo.
Tapos isipin mo pare, tayo pupunta rin doon. Gastos natin lahat.
Oo. Kasama pa siya sa libre.
Imbis na ayoko, kasama pa siya.
libre.
Libre pa natin siya.
Oo.
Ano ka nang
Pare, wag na natin sama. Tayong tatlo na lang ulit. Oh.
Pare, nalinlang talaga
Sabi
tayo.
ko sa'yo, na-scam tayo eh.
Oh, kasama mo pala siya doon pagbalik natin.
Oo.
Kasama pa siya doon.
Oo.
All expense paid din siya doon, pare.
Eh, wag na natin sama. Pare, mag-ambag na siya.
Yung 10K yan.
Oh, yung 10K, bigay niya sa atin yung 5K.
Dadali ko sa Manila so yun.
Oo, pare. Doon na lang natin pag-vlogin. Manila Zoo. O kaya sa Malabon Zoo.
Nadali
Pare, sa Malabon Zoo. O kaya doon kay kay Chabit. Yung zoo ni Chabit. Marami doon
Sa
leon.
sa ang layo.
Ba't liyon?
Tangina.
Pare, pakain na sa leon. Oo.
Pare, ang layo nun.
Putang ina,
Sa
pare.
Baluarte, sa Bigan.
Oo. Eh pare, at least doon siya. Oh, happy na siya. May mga doon, may mga giraffe. Oh, may tigre. Sama kita noon. Oh, ha?
O, to shout out kay Jazz para sa explore nyo po, pandagdag.
Oh, ano?
500 pesos.
Okay, thank you. Shout
Shout out kay
out. Jazz.
Jazz!
Anong apelido?
Shoutout Jazz!
Jazz lang.
Jazz. Oh, shout out
Utah.
sa'yo. Jazz, yun lang.
Hindi, Utah.
Utah.
From Utah.
Jazz Utah.
Jazz Utah.
Yun ang last name niya,
Baka,
Utah.
para ako niloloko mo. Jazz Utah. Ang ano to? Hindi nga.
Ano ba?
Jazz niya, Utah ang surname
Jazz
niya.
Utah?
Shout out to, Jazz Utah.
Parang saan
Parang sa
pa?
para NBA
Ayun
yun
yun.
ah.
Jazz Utah?
NBA yun eh.
Slow ang puta. Ang slow mo,
Hindi.
Utah Jazz.
Utah Jazz. Binaliktad mo lang. Tarantado ka talagang hayop ka eh. Nagising
Masalino pa sa'yo yung unggoy talaga.
Pare, nagising na ako ng malalim eh.
Tangina, gago ka talaga.
Pero pare, Musbal, pag iba kasama, hindi siya tumatakbo. Oh, pare, oh. Pag iba daw, sino yung tumatawag? Hong Kong? Sino?
Hong Kong.
Boss Bal, pag iba kasama, hindi siya tumatakbo.
Oh, boy, kita mo.
Ba't sa atin tumatakbo siya?
Oo, boy.
Nalinlang talaga tayo.
Oo, boy, sabi ko sa'yo eh.
Hindi, ito totoo ha. Yung sinasabi nila na pagka hindi tumatakbo si investigador kasi umaga.
Mm.
Lahat ng vlog niya na hindi tayo kasama umaga.
Umaga ba?
Mm.
Talaga?
Oh, ang gabi yung horror house.
Mm.
Hindi naman siya tumakbo dun kahit kasama tayo.
Oo.
Oo nga, paano siya makakatakbo? Sige.
Hiwa-hiwa siya doon.
Hiwa-hiwa siya doon. Paano ka makakalundag pare ng malalim?
Yan, tatalas.
Ayan.
Oo.
Mm.
Kaya nga, oh, di ba? Grabe, no?
Grabe.
Oh, siyang ina. Nag-isip talaga ako ng malalim dun ah.
Oy, mag-set na kayo. Dami na, may budget na tayo pang explore. Oh.
January 1st,
January.
2nd, or second weekends.
Oo.
Di ba Friday, Saturday,
Oh.
Sunday?
Ano yun?
January 1st.
Oo.
Yung mga ganun, second
Oh,
week.
second week.
Para
chicken.
ma-set up mo boy, tatlong
Oo.
araw kasi tayo dun eh.
No, hindi,
Pero
Sabado.
Sabado, Linggo.
Oo.
Ah,
Pwede yun.
ah.
Kaya
La
mo.
Union.
Kahanap ako ng ano.
Gago,
naman,
kasi
eh.
kung second week, wala ka nang pang-upload dun.
Oo nga.
Dapat first week.
Dapat first week.
Oo.
Dapat
ano
yung...
ano bang first week ng weekend?
Hindi, hanap muna pa ako ng
Oh, sabi ni Jazz, nasa beach siya ngayon. Tangina
Oh
boy.
shit, bitch!
Marunong ba lumangoy ang matching?
Tangina nga, pare, ang lupit no.
Bakit ganun? Bakit parang ganun? Tangina, parang saya-saya niya.
Oo.
Libre na lahat. May 10K pa siya. Nasa beach pa siya ngayon. Tayo na dito tayo sa harap ng McDo. Oh, sabi ni Jazz.
Naka-hotel pa no?
Imbis na tayo nasa beach din.
Oo.
Nagsasaya na tayo doon, pare.
Hindi tayo niyakag.
Pare, ang blangis talaga. Scammer.
Puta,
Pro scammer. Pro scam.
Na-scam tayo, bro.
Oo, tangina.
Grabe.
Ang lupit.
Hirap.
Napaisip din.
Tinuruan mo kasi.
Ikaw gago, tinuruan mo mag-live eh.
Ito,
Tinuruan mo mag-live.
Pare, ang unggoy talaga pag naturuan mo mag-live, talaga dire-diretso
yun
non-stop.
nga eh, parang hindi tayo sinama, tinuruan mo na lahat.
Oo.
Tinuruan mo mag-live, tinuruan mo maggawa ng pangalan.
Hey! Ayabang! Oh, tangin na boy. Sabi ni Investigador Jay, oh. Hey! Ayan boy, ay taka, ayan oh, ayan.
Investigador J.
Hey! Tangin na, pare ang unggoy pala
Diyan
na.
na si third eye.
Baka naman ano yan boy, scam.
Oh, hindi boy, malupit.
Legit ba?
May unggoy pala nagsasalitang, hey!
Ay, hey.
Sabi, Boss Trino, ititreat daw kayo.
Nino,
Nino, ni Adventure, ano Adventure?
Nino, ititreat daw kayo?
Legit. Siya yun.
Siya talaga. Boss, sabi sa atin, hey!
Hey!
Oo, pare, ano
Utang
sabi?
ina mo kang matching ka.
Treat daw kayo? Sino magtitreat?
Wala boy, sabi lang sa'yo, hey!
Oo, pare, sosyal, mayabang.
Hey!
Op!
Biro mo, nag-i-English pa yung ano.
Oo, pare, saan nakita unggoy na nag-i-English? Hey!
Ang sakit nun,
Ano sabi?
sabi ni Mickey. Ang sakit daw nun.
Pare, grabe, tinuruan mo na mag-live. Tinuruan mo gumawa ng, nag-iisipin natin ng title ng kanyang YouTube. Pare, tapos tuturuan pa ni Dax ng ano.
Oo, may tumatawag!
Tuturuan pa ni Dax ng
Monetization.
monetization. Pare, tayo hindi sinama.
Oo, tangina, ang lupit mo. Kita mo, i-comment na naman, nasa beach daw,
Nasa
nag-i-enjoy.
beach, tapos
Ayan,
naka-hotel.
Tangina, boy.
Saan may La Union?
Yun, lupit nitong batang to. Sino may natawag na yun?
Eh, hindi ko kalala.
Okay, magpakilala ako sino ka natawag ka.
Di ba, boy, tinuruan mo na lahat, tapos hindi tayo sinama.
Oo, puta, sabi pare, nag-English ang scammer. Hey!
Hey, tama. Ang dami natin sinabi lang, hey.
Oo, tangina boy, sabi niya, hey, dyan na kayo.
English pang hayop.
Boy, hindi, ibig sabihin niyan, hey, dyan na kayo. Dito ako. Walang hiya. Oh my, holy.
Uy, nag-i-English. Where are you going daw, mga boss, sabi?
Where you going? It's none of your business, goddamn you. Pa-English ka pa, hayop. You're an animal. You bitch.
Pura!
Bitch, sabi bitch.
Bitch.
Nasa
Tama,
beach siya.
Nasa
beach.
Nasa beach siya, tama.
Goddamn you bitch.
Tama.
Nasa beach siya. You son of a bitch.
Tama, bitch.
Mag-English ka pa. Goddamn you animal.
Hayop ka? Hayop ka!
Ayan nagtagalog mo pare. Matindi. Hayop ka eh. Hayop ka eh. Sumigaw na eh. Boy, malupit na. Nagalit na.
Tutubuan ako ng buhok.
Puta, where you going? Parang pa English na yun. Hayop na yun. You're a goddamn animal! Sabi nga, tara na dito sa mga... Biglang nagtagalog ang gago din.
Tara na dito mga boss.
Bala ka sa buhay mo!
Pare, pinapasunod pa tayo doon.
Bobo! Bobo!
Pare, pinapasunod pa tayo doon.
Oo.
Maggagas tayo, magtutongkin tayo, imbis na libre tayo.
Wag na daw sumama sa scammer!
Hayop talaga yan, oh. Hayop ka.
Hayop talaga. God damn you animal!
Gaganti kami sa'yo, maghahanap kami ng kapalit mo.
Oo, pag kami nakakita, mahala ka. Dahil diyan kay ano.
Maghahanap kami ng pusa.
Oo.
Tuturuan namin mag-vlog.
Oo, tayo na. Pag yun na lupit na, puta patay kayo. Bahala ka sa buhay mo. Hayop ka.
Naisahan tayo, pare. Ha? Siguro ito sabi ng subscriber niya. Oy, punta kayo dito, libre ko kayo, all expenses paid, pare. Sama niyo sila Bosino Balbali, tapos si Adventure Duck sama mo. Siguro sabi niya, ay hindi sila available eh.
Yun.
Siguro ganoon sabi no. Sabi niya.
Ganun?
Oo, baka sabi ni investigador doon sa subscriber, hindi siya available, busy kasi yun eh. Oo. Tapos ito na lang yung isasama natin.
Oy.
Kaya
Sabi boy, ganun ang pagkakasabi nun pare.
pare.
Nakikita ko na pare, tuso talaga yung matching eh.
Pare, tapos sasabihin pa tayo, hey.
Tapos hey.
Tapos sasabihin, sumunod kayo. Where you going mga boss? Aboy.
Ay, nagko-comment daw si Third Eye, pansinin natin.
Saan ba?
Saan na ba?
Wala. Nagsabi nga eh. Wala. Wala na. Oh, kita mo natawa tuloy si Ma'am Donna Canupin.
Grabe.
Iba to.
Grabe boy.
Ipatulpo daw.
Ipatulpo si Third Eye.
Arbelin. Patulpo daw.
Ay, Diyos ka.
Boss, ang dami nagagalit kay Third Eye. Hindi, biro lang yun.
Oh.
Biro lang yun, pinapatawa lang namin kayo.
Ay, Diyos ka. Na-scam daw.
Nakita mo na, hindi mo kami sinama.
Sabi na pare, ano? Invitation guest lang ako dito. Ulul! Invitation guest lang daw.
Masyadong formal,
Oo, pare, invitation. Bobo, mali pa English mo. Tanga. Invitation.
Invitation guest lang ako dito.
Gago, I was invited only. Bobo.
Invitation guest. Guest talaga siya
Oo,
pa.
pare. Hindi big sabihin, bayad yung guest mo. Tanga.
Tangina, may guesting na kagad.
Oo,
ba?
nag-guesting na.
10K?
Oo.
10K yung guesting mo, tapos hindi mo
all
kami
expenses
sinama.
paid.
All expense paid. Bungat!
Miss Jen, official, shoutout sa'yo.
Oh, ha?
Yung 10K daw, galing pala kay Cayetano.
Sino Cayetano? Pia Cayetano? Putang ang lupit!
Si Senator.
Ay,
Sino to?
Si Cayetano. Oh.
Pia Cayetano o si ano? Yung
Peter.
Peter Cayetano. Okay. Pare, ang lupit talaga. Senador pang ano, kanyang sponsor.
Oh boy, lupit talaga.
Ang lupit talaga.
Mahilig sa unggoy yun eh.
Oh my God. Napabundang hininga ako. Oh.
Lupit talaga, dinaig ka pa, Boss Bal.
Oo, dinaig pa kami. Ay, ano lang, si Monica Awa, nagdadala ng $2.
Si Sir Ed Kalawag daw nag-comment. Hindi, ano yan, poser.
Poser lang po yan. Huwag kayong mag-alala. Grabe, no?
Nag-comment po si Ed Kalawag, collab daw po kayo. Wala, poser yan.
Poser po yan, poser.
Nung isang araw pa yan eh.
Ang tagal lang nagaganyan.
O sabi na ano, next na collab daw sa kay Third Eye, may TF na daw boy.
Huli ka, huti.
Ang gagawin natin.
May
Pare,
Para daw sumama sa atin, may TF na.
ay bahala na siya sa buhay niya. Puta. Pare, it's not our loss.
Oh!
It's theirs.
Ay, sasabay si
Ah?
Bal. Sinasabayan din ni Bal.
Oo. Pero bobo English mo!
Bitter si Bal boy.
Hindi, joke lang.
Oo.
Ay, nako.
Bitter na si Bal.
Bitter na ako! Bitterness, tenderness. Pare, it's not our loss. Bakit di nyo...
Lady Jean. Ba't
Lady-
daw di natin siya pinapansin?
Sino daw?
Si Lady Jean?
Lady Jean.
Eh, napinasin yun.
Okay.
Yun na, scam. Ina nyo. Na-scam kayo, nabati nyo na. Wala na kayo magagawa.
Oo, nabati na namin eh. Lupit talaga. Dinaig ka pa, boss. Bal, oo nga, dinaig pa ako. Oh my God. He's famous.
Famous pa.
No, he's famous.
Million views siya sa TikTok.
Oo.
Million views?
Oo, yun sa video ko.
Mm.
Oh, million yun boy. Dalawang video yan. 1 million, 1 million.
Sabi ni Donna, Ma'am Donna Canupin, Nax Bal.
Magaling mag-English na si Bal.
Yes!
Ay, naka. Launa na pala boy.
Oo.
Uuwi pa to.
Tara! O, baba na mga tropa! We have to go. We better run. We better get. We better make tracks. Okay? Ano? Sabi ano? Ha?
Sabi ni Longga ko, Adventure Ducks, lahi mo na lang akin.
Ah, pucha.
Lahiyan mo daw siya.
Pare, bibigyan kita ng lalagyan na magsimula ka na batibot.
Oh, may suggestion si JB. Nakukonsensya daw si Third Eye, isasama na daw tayo. Pero sagot natin.
Apo, hindi na. Siya na lang mag-isa. No way, Jose. Okay. Bye po. Oh. Pare, bibigyan kita.
Bye-bye na dahil. Bye-bye na.
Oh.
Bye-bye!
Bye-bye na at uuwi pa si Boss Dax. Malayo pa.
Kasi si Adventure Ducks,
Uwi pa yan ng Quezon City. Malayo pa. Nandito siya sa Laguna. Nakakahiya naman at mapapagod siya.
Tulugan na kayo ha.
Oo.
Okay, bye-bye!
Bye-bye! Paalam!
Okay ka na boy.
Bye-bye guys.
Pakit pa rin to.
Mabait. Iba. Sino ba yung tapos mo? Nandito siya sa Laguna. Nakakahiya naman at mapapagod siya.
Tulugan na kayo ha.
Oo.
Okay, bye-bye!
Bye-bye! Paalam!
Shout out sa'yo, Steven Datibal. Good morning. Siyempre, good morning na. Umaga na eh. Alang naman mag-good evening ako. Sabay na echo. Cesar oh, ito si Cesar masipag to eh. Ay, sa wakas nakaabot. Good morning Cesar. Shout out. Saan ka ngayon boss? Sa bahay na. Pauwi lang. Hello, shout out sa 15 viewers. Good evening, good evening. Umaga na Madam Natalia Nicole. Good evening Boss J and Happy New Year to all. Good morning. Good morning Natalie Nicole. Happy New Year din. Lyra nga po. Anong Lyra? David Hunter Vlog. Good morning sa'yo. Supportahan daw natin si David Hunter Vlog. Wala namang problema sa akin mag-support. Collab ka sa akin para masuportahan kita. Eman Burquillos, good morning. Shout out sa'yo. Nasa Saudi pala siya. Okay, okay lang yan, okay lang yan. Good evening sa Saudi. Ako, pulto ng lola ko. Ay, si ano nga pala, si Lyra nga pala to. Sorry. Kasi ayaw mong baguhin yung pangalan. Baguhin mo kasi yung pangalan niyan. Alay ba si Rino ngayon?
Naglalay daw. Ayun, nasa comment.
Naglalay po si Boss Rino ngayon. Hello, Jawik. Si Jawik, oh. Good morning sa'yo. Good morning sa'yo, Jawik. Sipag din niya si Jawik na yan. Nasa GC natin yan, eh, no? Ilan ba moderator ng GC? 21 na, no? Dami na. Sayang, masipag. Yung mga hindi masipag doon, pag wala, may nakita ko hindi masipag doon sa GC, tanggalin nyo. Ito'y palit niyo si Jawik. Good morning din sa'yo, Jawik. Uy, si Mark Sanglay, gising pa pala. Good morning sa'yo, Mark Sanglay. Yo, nakabalik na. Oo, nakabalik na sa awa ng Diyos. Good morning sa'yo, Mark Sanglay. Ito si Jens Art, oh. Kaiga na, oh. Iyon, oh. Kung naman, kaiga na. Papatulog po ako ng pamangkin ko. Kaya pala. Hindi siya natutulog kasi nagpapatulog siya ng pamangkin niya. Ay, nako. Dito tayo. Para kita ng camera si Jen Art.
Ulas daw.
Sino 12 years old?
David Hunter Vlog.
12 years old ka lang, nagbablog ka? Anong binablog mo, David Hunter? Hello Jenny, Endless Love. Si Jenny ng Endless Love, oh. Sir, may kasama ka dyan na bata. Meron, alaga ko yan. Ba't nakita mo ba? 12 years old ka lang, nagbablog ka? Ano kaya, gabay ko yan, si Angel. Nakita mo ba? Hello Jenny, nag-play po ako ng music para makatulog siya. Sa Regina, shout out sa Regina, good morning. Palike ng ating live, palike po ng live natin. Gabay kaya gabay. Buti nga hindi mo nakikita yung dalawa kong tatlo pala. Tatlo ko pang alaga. Si Alpha, si Lian, tsaka si Luna. So yun nga pala guys, may bago tayong napulot. Ay, napulot, grabe makapulot. May bago tayong naging kaibigan. Sa nakuha natin to sa Luna. Sa Luna, La Union. Nakuha natin to sa Luna La Union, kaya papangalanan ko siyang Luna kasi taga Luna La Union siya. Bago nating gabay na kinuha ni Lian, ang pangalan ay Luna. Ay, boss, may bata dyan. Angel yan. Pag nakakita ka ng punong multo, tatakbo ka siguro sa barracks. Nako, hindi na ako tumatakbo ngayon.
Ay, yung ano to, ang tinutukoy niya siguro yung kay ano,
Good morning.
yung vlog ngayon nila.
Hello Kuya Mark. Meron pa. Sige, ano yung nakita mo din Ano pa? Si Kuya Rick, shoutout Kuya Rick. Nakauwi ka na pala. Boss J, ay Lods J. Oo, nakauwi na Kuya Rick.
Video mo sila natin.
Kakakain lang yun Shoutout Timothy Singsong. Timothy, shoutout. Gusto nila yung mga candy. Lalo na yung snowball. Bakit mga? Isa lang naman yan si Angel. Isa lang naman yung gabay ko na yan. Na bata. Si Angel. Hindi na ako tumatakbo sa mga vlog, Cesar. Diyan nga sa La Union Pinalag namin dahil kami natakbo.
Good morning, Idol. Lodi. Ramil Agustin.
Ramil Agustin, shoutout. Good morning din. Tawag ka Jenso.
Burahin ko tong ano.
Jenso niya.
Burahin ko tong
Alin?
yung ano, comment niya.
Boss, inalisan. Ano?
Ba't hindi ko ma-hide yung comment niya?
Inalisan mo daw si Boss Rino, sabi ni Quattro. Ang kulit. Ilang beses ko ba ipapaliwanag sa inyo? Hindi ko nga inalisan yung team ko. Yung duwende daw. Baka alaga mo yung Jens.
Hindi ko alam.
Duwende. Timothy Simpson. Bahala ka dyan, boss. Timothy Simpson. Sa GC. Bilis nila. Hindi ko na nakita. Hindi Angel. Ayun, duwende. Hindi si Angel yung duwende. Hindi naman talaga duwende si Angel. Pambihira yan. Solo exploration po kayo. Nyo ang hirap pala dun. Pinatay yung GoPro ko, kuya. Saan ba? Saan ba pinatay yung GoPro mo? Babaero daw, ha? Sino nag-comment na babaero? Pagbabasahin ko pa yung kwan nito, yung comment nito, mababad trip lang tayo.
Ano to, sana to, si Timothy. Huwag mong dalahin sa live yung kwentuhan natin sa ano, GC.
Sino? Mark, sleep ka na. Boss Jeff, ang cute mo po. John Kenneth Laguerta. Ito si John Kenneth Laguerta, shoutout sa'yo. Siya yung nag-comment nga pala ng subscriber siguro ni Rino. Bakit anong nangyari? Anong nangyari, Jens?
Mamaya ako kanya.
David Hunter Vlog. Bilya Epipanya, kuya. Tinigil ko na. Tumakbo na ako dahil takot na ako. Di ko na tinuloy. Ba't ka naman natakot? J, matindi doon. Maraming pinatay doon. Oo nga, Kuya Rick, kaya lang kailangan natin ng budget dyan. Bahay mo yan, Boss Jeff. Oh, nasa bahay na ako, John Kenneth. Nakauwi na. Kahit pagod, live pa rin tayo. May nakaupo po kasi doon sa itaas. Ba't ka naman natatakot kung may nakaupo? Ako dati takot ako pero ngayon hindi na. Ay, may nakaupo po. Or sa Sempio Mansion sa San Miguel. Haunted din. Saan yun? Kaya try muna natin Kuya Rick yung Sempio Mansion. San Miguel, Bulacan lang ba yan? Boss, solid pan nyo akong apat. Ina Boss Rino. Oo nga, solid pan ka nga namin. Yung problema, hindi naman ako umalis doon. Hindi naman kasi ako umalis doon. Sabi ni Ate Regina, buti gising ka pa, di ka inantok. Hindi pa, kararating pa lang namin at Regina. Kararating lang namin eh. Ano daw? Sino may sabi na ito? Captain Gaming. Tumakbo ka lang, boss. Ikaw isama kaya kita para tumakbo ka rin pagka makita ko sa'yo walang ulo. Kahit nung narinig ako na song nagulat din ako kaya alam kong gulat sa Twin Mansion. Tama si Jenny. Shout out Ted Kenshi de la Cruz. Shout out sa Ted. Paalala lang po, boss, halos namatay ako sa noong sumigaw kayo ng hanggang inigin. May entrance fee pag-explore dun. Pero solid nga paramdam yan. Magkano entrance fee dyan, Kuya Rick? Ano sabi? Okay, boss. Alam ko na Hindi ko naman pwedeng alisan yung sarili kong team. Yung Kalarino. Pero gumawa lang ako na sarili ko rin team. Ano ba pangalan natin yung team natin? Parang normal. Good, nice. Luke Vincent Eguia, shout out. Oh. Okay, Boss Jeff Hunt, Brit Lan. Salamat ma.
Thank you po, Mami.
Ano daw? Boss Jeff, Ghost Hunt Break Challenge. Ayoko nga. Pamya may makita lumalawit delikado tayo dyan. Ngayon si Ang sabi nito, Captain. Hindi naman daw nakakatakot. Try natin. Sige, tagasan ka, yung pangalan ng mayabang na to, Captain Gaming. Tagasan ka. Gagastusan kita, isasama kita. Pero wag mo ko sisisihin pagka iniwanan kita sa loob ng sinasanibang ka na. Dahil hindi kita tutulungan. Pag sinanibang ka. Sige Kuya Rick. Pag-usapan natin niya Kuya Rick. Hindi naman nakakatakot na subukan mo. Yeah, pabuksan third eye mo para malaman mo. Tama si Timothy Singson. Try natin kaya buksan yung third eye niya na Timothy. Buksan kaya natin third eye nung mayabang na Captain Gaming ba? Captain Gaming ba yan? Para masapian ng tama nga si Jenny, sabi niya nagugulat pa rin ako sa mga nagpaparamdam at nakikita ko. Kaltokan mo, Boss J, pag sinapian. Hindi natin kakaltokan, Jawik. Pasisipa ko sa iyan. Sabi ni 4 bak hindi ka makatulog ng maayos. Ay, 4, hindi makakatulog ng maayos si Captain Gaming na yan. Malamang siguro diretso pulinarya babangutin eh. Mukhang asim. Hindi ko po alam. Hindi ko naman po nakakasama yun eh. Si Jenny nakanggagamot din daw siya. Sabi ni Lyra, lagot ka Captain. Sino pogi? Si Rino o ikaw? Hindi ko po alam. Mas pogi si Boss Rino sa akin. All Bids TV, shout out. Tess Rosales, lagay nyo. Banga Boss Jeff pag sinapian. Wag sa banga, maliit eh. Sa itim na ataol. Kapag sinapian Boss J, hubuan mo. O pwede rin. Hubuan natin Kuya Rick. Tapos hintayin nating mabalik ang ulirat habang may nakabidyong camera. Oo nga, pwede naman yan, Ted Kenshi. Mayabang lang siguro talaga tong Captain Gaming na yan. Magkukulab kami sa nila Boss Rino sa Villa Epipanya. Baka first week of January. Ka-chat ko si Boss Rino eh. First week of January daw. Abangan nyo guys yung collab namin nila Boss Rino ulit sa Villa Epipanya first week of January. Sabi ni Quattro, baka makalimutan yung pangalan niya. Solid pala to si Quattro sa aming apat. Solid pan pala to. Sabi niya, solid pan niya akong apat. Kaya pala naka-live, kaya pala active dito sa ko live ko. Hindi lang pangalan na makakalimutan niya, Quattro, sigurado. Yaan nyo, panira ng moment yan. Hindi, okay lang yan. At least may pinagkukwento, meron kaming pinag-uusapan ng mga viewer, mga solid na subscriber ko. Tama, nai-enjoy nga sila mag-comment eh. Mukbang kayo sa Zambales Barracks, doon matagal na abandon house. Saan yun? Boss J, parang mahina ata sounds mo ngayon. Iniinahan ko kasi may natutulog. Yun, collab nila Boss Rino, waiting. May collab kami, after January. First week of January kasi nga, daw, Villa Epipanya. Doon din kami mag-i-stay sa pinag-stayan namin ng team investigador sa resort. Dapat always kayong apat, lagi magkakasama, mas masaya yung solid. Hindi naman po pwede po kasi lagi kami magkakasamang apat. Paano kung meron silang pupuntahan na sila lang? Oh, alam nga malagi kong kasama kahit gusto nila sila lang. Tsaka siyempre sasamahan ko rin din sarili kong team. Shoutout sa'yo Arvin James Sanchez Roldan, Santa Maria Bulacan. Saan kasi Santa Maria Bulacan to si Arvin? Si Lyra. Porda, yabang ang captain. Mayabang magsalita. Tapos pagka nandun na sa actual nangangatog na ihi pa. Oo nga, Kuya Rick, tama ka dun. Jenny, bukas third eye mo. Solid fans. May apat na Boss Jeff. Kahit motorin ni kayo. Pwede naman. Yun, sarap talaga manood. Apat ito. JAB. Ano yung JAB? J. Ano yung A? Sino yung A? Si B, si ano eh. Sino yung JAB? Yung B siguro si Bal. SSJ. Ako yun si J eh. 4. Boss, pero congrats nalabanan mo na takot mo Oo naman. Kaya ako nagsosolo guys. 4. Kaya ako nagsosolo. Try ko kasi para mapalakas ko yung sarili ko. Ako Pulilan. Taga Pulilan pala to sa All Beach TV. Yung malalapit dito sa Bulacan lang. Pwede tayo mag-meet and greet. Mark C. Shoutout sa'yo Mark C. Yung mga taga Bulacan dyan katulad ng Santa Maria. Tapos yung Pulilan. Pwede tayo mag-meet up. Adventure Ducks. All Beach. Taga Pulilan ka lang pala. Plaridel. Scary ko. Plaridel lang yun Swerte naman sama nyo. Taga saan ka Ted Kenshi? Magkape mo bro. Magkape muna tayo. Kape tayo. Tara, kape tayo. tayo dito. Traffic. Jenny and Islam, malinaw na malinaw.
Hindi po, mi. Malakas ng alon.
Antike, layo mo, antike. Layo mo, antike ka pala.
Sakit sa balat.
Kahit ako lang, cameraman nyo. Layo mo nga eh. Boss J, sabi ni Mark Sanglay, Boss J, kape din tayo. Sige, salamat Mark. Ito oh. Oy Mark, Mark Sanglay. Mark na nga lang, ang bihira. Marami kasing Mark dito eh. Mark Sanglay, salamat nga pala doon sa palipad mo ha. Nakatulong, ang laki ng tulong. Kahit paano eh, ang laking tulong talaga. Napasalamat nga si Lian sa iyo eh. Oy guys, ano nga pala Mark? May bago akong naging kaibigan doon. Ang masama noon, sinama pa ni Lian. Inampun niya. Eh dahil taga La Union Luna siya, taga Luna siya, La Union. Pangalanan ko tong Luna. Oo. Pangalan ng ating bagong Luna. Sige, walang problema, Lyra. Kailan ma-debo mo? Taga saan ka ulit? Cebu? Cebu ka? Tama ba? Ito ba yung taga Cebu? Meron na nga, Boss Jeff. Nakita mo na? Mark? Inampun ni Lian. Ano, diwata do sa may sa may kakahuyan dun sa do sa may Luna, do sa may Mark, naalala mo yung sinabi ko sa'yo na yun nga yung muntikan na kami pagtripan doon. Nagulat ako, may Luna ang pangalan niya. Pinangalanan ko siyang Luna eh, taga Luna naman siya eh. Kaya Luna pangalan niya. Inampun ni Lian. Gulat nga ako eh. Nagulat ako, lumagay sa likod ko bigla. Kwento ka, Boss Jeff, para malibang lahat. Eh yun na nga, ito na nga, kukwento ko nga sa inyo. Yun na nga, nagulat kasi ako noon. Talagang lahat ng lahat ng noon time na yon, lahat ng aking gabay noon, yung si Lian, si Alpha, si Angel, papanik na. Kasi nga, nag-aalala sila, baka daw kami pagtripan ng lasing. Hello daw, Luna. Nakikita mo si Luna nandito? Kita mo Mark Sanglay? Ang aking pinaka-cute na nagselos naman Lian ko. Yung cute din pala. Si Luna. Kaway-kaway kayo dyan. Ayun na nga. Dahil nag-aalala kami, panay ang bulong sa akin ni Lian tsaka ni Alpha, baka nga daw may masamang balak. Kasi nga, na-bad trip kasi yon. Ganito ang kwento. Na-bad trip kasi yon. Parang siguro na-offend. Na-offend siya. Baka nanonood si Madam. O, tulog na ba si Madam? Mula Daong Gabalawan? 1,000? 1,000 tayong Oo. Tapos yun na nga, eh tinawag ni Lian itong si Luna, tinawag niya kasi sleep na, Boss Jeff. Mamaya pa ako matutulog, nagkakape ko. Nagulat ako, tinawag ni Lian itong si Luna, nandun kasi ito sa may malaking kahoy nang galing. Nanggaling siya doon sa may malaking kahoy, tinawag ni Lian. Gulat ako eh. Lumalapit eh, napakalamig. Kahit yung kahit to si Philip, nagulat, humahawak daw sa kanya, napakalamig. Si Luna. Lobisyan po ako. Anong Lobison? Lobison. Ah, tinuro mo sa akin, Boss Jet. Sabi ni Lyra, Lobisyan po ako. Anong gulat ako, ang kakayahan nito si Luna pala. Alam niyo ba ang kakayahan ni Luna? Kaya niya, alam niyo kung naalala niyo, kung naranasan niyo na yung naglalakad kayo sa gubat. Kung naranasan niyo naglalakad kayo sa gubat tapos bigla kayong yung parang pabalik-balik kayo sa isang lugar lang na pinupuntahan niyo. Diba naglalakad kayo tapos pupunta kayo doon sa magugulat kayo, parang nadaanan ko na to ah. Yun ang kakayahan ni Luna, taga-ligaw, taga-bulag. Kailangan baliktarin mo pa yung damit mo para lang makabalik sa pinanggalingan mo. Parang pabalik-balik kayo sa isang lugar lang. Legit ba explore mo? Nyo, sunod na vlog nyo. Sama nyo si Ed Kaluwag. Idol, legit ba? Sino naman to? Idol, legit ba? Explore nyo. Sunod na vlog, sama nyo. Bakit pag sinaba ba namin si Ed Kaluwag, magiging lalong legit ba kami? Legit naman talaga yung vlog namin nila Boss Rino. Kahit hindi namin isama si Ed Kaluwag, legit boss yung ano namin, yung vlog namin nila Boss Rino, wala kaming daya. Dahil ayaw namin ng daya, ayaw namin ng peke. Baka yung mukha mo lang siguro yung peke. Bakit pag sinaba ba namin si Ed Kaluwag, magiging lalong legit ba kami? Hindi na namin kailangan isama si Ed Kaluwag kasi hindi kami marunong mandaya. Hindi kami marunong mameke ng video. Pag si Boss Rino pa nakabasa niya, sigurado babarahin ka pa nun, may kasama pang mura yun. Ang palagi mo sa amin, peke. Hindi nga kami gumagamit ng mga multo-multo eh. Wala kaming artistang multo. Kilala niyo na siguro kung sino pinapatamaan ko. Pag si Boss Rino pa nakabasa niya, sigurado babarahin ka pa nun, may kasama pang mura yun. Sumitsit nga na walang tao. O tama si Ted Kenshi. May sumitsit nga pero may sumitsit nga na walang tao eh. Oh. Kung si Kuya Rino pa nakabasa, anong pangalan nun? Anong pangalan nun? Kian Rodriguez. Kung sa live ka ni Boss Rino magko-comment ng ganyan, barado ka, may kasama pang mura. Sigurado. Salamat ka sa akin ka nag-comment dahil mabait pa ako, mabait talaga ako. Hindi ako yung alam Kian Rodriguez. Kung sa live ka ni Boss Rino magko-comment ng ganyan, barado ka, may kasama pang mura. Sigurado. Salamat ka sa akin ka nag-comment dahil mabait pa ako, mabait talaga ako. Hindi ako yung alam.
There are countless, unusual celestial bodies scattered around the vast expanses of the universe. A combination of various factors has turned some of them into mysterious anomalies, exceptional even by space standards. Some of these objects are amazing exoplanets, strikingly similar to Earth, while others have never seen sunlight or experienced heat. There are worlds torn by continuous sandstorms, while others are covered by a vast ocean whose bottom is made of blocks of glowing ice. At the same time, in the depths of multicolored nebulae, there are giant stars capable of swallowing whole planetary systems, and millions of light years away from them, jellyfish galaxies cut through the expanses of space with their shining stellar tentacles. And today, we invite you to join us on a fantastic journey to the most incredible ones. Cosmo. Jellyfish galaxies vast expanses of space with their shining stellar tentacles. Today, we invite you to join us. Before we set out on a space journey beyond the boundaries of our system, we have to decide on the manner of selecting a planet that resembles the Earth most from thousands of candidates. What should be the parameters of this fascinating world, and what should we take into consideration first? It goes without saying that planets favorable for the genesis and sustenance of life have always posed considerable interest to scientists. However, it is no easy matter to single out suitable celestial bodies among a great number of those discovered by now. To have clear-cut selection criteria, scientists worked out the so-called Earth Similarity Index, or ESI for short. It is based on several principal parameters: a planet's radius, density, and average surface temperature. This combination makes it possible to calculate the object's mass, approximately estimate its chemical composition, gravitational level, whether or not there is an atmosphere, and if there is, analyze some of its characteristics. It also helps establish if there is liquid water on the planet's surface and other information. The standard of this index is the Earth, with its parameters assumed as ideal and its ESI equaling 1. Based on the Earth Similarity Index, all the objects known to us conventionally fall into 3 categories. The first one is objects whose ESI is under 0.5. These are for the most part gas and ice giants, as well as extremely hot or, on the contrary, cold objects. This is the category most of the solar system planets and satellites fall into. It takes just one characteristic to greatly exceed the maximum permissible values for a celestial object to be unfavorable for the genesis and sustenance of life. Let's take Venus, for instance. The radius and mass of this celestial body are very close to those of the Earth. However, due to its close proximity to the Sun and a dense atmosphere, its surface temperature is extremely high. That is why, in spite of a close similarity to the Earth on the face of it, Venus's ESI is not high, at just 0.44. Of course, there being any life on its surface is totally out of the question. Celestial objects whose ESI is within 0.5 to 0.7 fall into the second category. These objects resemble our home planet noticeably more. They're mostly rocky worlds with relatively moderate temperatures, but it can also be ocean planets and even some large satellites. Incidentally, a high Earth Similarity Index per se does not warrant favorable conditions for life. For example, quite often low-mass planets are incapable of retaining a dense enough atmosphere, while their magnetic field is too weak to protect the surface from lethally dangerous radiation. Other celestial bodies yet may happen to be located too close to their parent star and so get tidally locked. Of course, all these factors greatly reduce the chances of life's genesis and sustenance. As for the third category, it contains celestial bodies with a high ESI, that is over 0.7. All of these planets are beyond the solar system. According to estimates, the size of these worlds and the conditions on their surfaces are potentially close to those of the Earth. Among these planets, there is one which resembles ours most, and it lies just 12.5 light years away from the Earth. That is over 0.7. All of these planets... This amazing world orbits Teegarden's star, a small red dwarf discovered in 2003. This star is 1,370 times dimmer than the Sun. This means that it cannot be observed with the naked eye, even though it lies quite close to the Earth. The mass of this tiny star is roughly 9% that of the Sun, and its radius is about 5% bigger than that of Jupiter. Gravitational forces are barely strong enough to maintain the thermonuclear reaction in the star's interior. That is why the surface temperature is just 2,900 Kelvin, or roughly 2,630 degrees Celsius. As is the case for all red dwarfs, Teegarden's star's habitable zone is comparatively narrow and located very close to it. Back in 2019, 2 exoplanets were detected in its system after continuous observations of the star's proper motion. Interestingly, one of them lies beyond the star's habitable zone and the other within. The outer planet, dubbed Teegarden C, follows an almost ideal circular orbit around the system's center. With the orbit's radius 0.045 astronomical units, it is completed every 11.5 days. It is presumably a rocky celestial body with a mass 11% bigger than that of the Earth. Its radius is estimated to be approximately 3.5% bigger than that of our planet. Unfortunately, conditions on Teegarden C's surface are far from hospitable. Due to the low luminosity of its parent star, the object enjoys 63% less energy than what the Earth receives from the Sun. As a result, the planet's surface temperature is gauged at 47 degrees Celsius below zero on average, which is too low for life sustenance, at least in the forms we know it. Still, the chance of there being vast oceans of salty water concealed under a thick layer of ice on Teegarden C, as is the case with Jupiter's satellites for instance, shouldn't be ruled out. As for the inner planet, it is dubbed Teegarden B. It is actually this planet that is the most Earth-like object of all those discovered to date. Its CSI is 0.95, which is just 0.05 less than the standard ideal value of our Earth. This celestial body lies 0.025 astronomical units away from its star, and it takes it roughly 5 days to complete a full orbit around it. By following a practically circular orbit, the exoplanet is constantly in its star's habitable zone, and it receives 15% more radiation from it than the Earth from the Sun. According to some estimates, Teegarden B's mass is just 5% more than that of our planet. As for its radius, it differs from that of the Earth by a minuscule ratio, which means that the gravitation value is also quite close to what we're used to on our home planet. This makes it logical to assume that the inner makeup of the exoplanet is highly likely to be similar to that of the Earth. There is a massive metallic core coated in a thick layer of molten silicate mantle reckoned to be at the center of the planet. The celestial object's outer part is covered with a relatively thin crust of solidified rocks. Mathematical modeling shows that the average temperature of Teegarden B is 28 degrees Celsius, which is 14 degrees more than that of the Earth. This means that conditions on its surface allow the planet to have and retain an ocean of liquid water, and the planet's temperature profile is potentially favorable for most microorganisms. Even though Teegarden B is quite massive and is capable of retaining a comparatively dense atmosphere, the radial velocities method, which is used for exoplanets detection, is quite inadequate for obtaining any information about the atmosphere's composition. But it should be borne in mind that a planet's temperature profile directly depends on its atmosphere's composition. For example, a dense atmosphere with a high percentage of methane and carbon dioxide will cause a strong greenhouse effect. Dense clouds of water vapor, meanwhile, will on the contrary reflect sun rays, which reduces temperatures. We should also remember that no matter how optimistic the parameters of this fascinating celestial body might appear, it is not entirely flawless. Being in close proximity to its parent star, it seems that Teegarden B is always facing it with one and the same side, which causes sharp temperature differences between the day side and the shadow side. As I've already mentioned, Teegarden's star is a red dwarf, and this class demonstrates a tendency to suddenly flare up. The amplitude of fluctuations in its luminosity may reach 30%, which greatly affects the planets located close by. Still, the chances of Teegarden B's capability of sustaining life are high. Biological creatures often demonstrate incredible viability, and their ability to adapt can't but amaze. For example, the ocean could serve as protection against lethal radiation and sharp temperature fluctuations. Its upper layer is potentially capable of absorbing cosmic radiation, while its currents could dissipate temperature contrasts. For all we know, as time goes by, primitive organisms might evolve in the warm depths saturated with energy and microelements. Just a tiny chance is sometimes enough for life to develop into something bigger. As a rule, it's potentially habitable planets with favorable conditions and a moderate climate that especially catch one's attention among the great diversity of other worlds out there, or else, on the contrary, extremely dangerous objects stand out among others. Still, there is yet a third category. It's anomalous celestial objects manifesting unusual behavior which is barely scientifically accountable. Objects like that challenge our knowledge and deserves special attention. This is exactly the kind of world we'll be looking at now. Still, there is yet a third category. It's anomalous celestial objects manifesting unusual behavior. The year 2009. The environs of the Kepler 413 system. An unknown object passes between our planet and a distant star, briefly reducing its luminosity. Astronomers take this event to be a standard exoplanet transit and announce the discovery of a new celestial body. High-precision calculations even make it possible to determine its parameters. The planet turns out to be a cool giant, with a mass of about 25 times that of the Earth and a radius of about 40% that of Jupiter. However, 180 days later, another expected transit never occurred. The planet, so clearly visible in the old data, seemed to have vanished without a trace. A dark spot in the photosphere of the star, or a giant dust cloud moving in its vicinity, would have accounted for the mysterious phenomenon. But these hypotheses were dispelled when 800 days later the mysterious object reappeared just as suddenly as it had vanished. The hypothetical planet eclipsed the disk of its parent star 5 times before disappearing again. Still, the key to the riddle had been found. It turned out that Kepler 413b has a highly unusual orbit. The celestial body is located near a binary star and is 0.36 astronomical units from the system's common mass center. Its trajectory is constantly affected by gravitational perturbations, and the change in gravitation of 2 nearby stars shifts the orbital plane considerably, causing cyclic oscillations. When the deviation reaches its maximum, the object leaves the line of vision and then returns to it. Calculations show that Kepler 413b's orbit oscillates with a periodicity of about 11 years, deviating 2.5 degrees in each direction from its average value. The planet's own axis of rotation also changes its position significantly, with a maximum angle of inclination of up to 30 degrees. Combined with a notable eccentricity of the orbit and its periodic shift, the climatic conditions on the surface change in a bizarre way. The region that receives the most light from the parent star is constantly shifting from the equator to the poles and back, which leads to dramatic variations in temperature. It is likely that this process generates huge planetary-scale hurricanes, which can be larger than the Great Red Spot of Jupiter. Air currents can carry ice clouds at several kilometers per second, gradually becoming unstable and dispersing. Meanwhile, the collision and deformation of vortices is capable of causing tremendous atmospheric emissions that have the power to overcome the planet's gravity and reach outer space. According to calculations, they will hang a while up there before gravitational forces pull them back down. All these incredible phenomena make the planet a rather harsh place. However, it may seem like a tranquil, serene island in comparison to the following world. According to calculations, they will hang a while up there, 190 light-years from Earth. The environs of the HD 10606 system. This yellow dwarf, surprisingly similar in parameters to the Sun, is orbited by a planet with a highly variable climate. It whizzes towards its parent star as rapidly as a giant comet, burning itself in the hot rays of its corona, only to retreat to the periphery of the system. The object is a gas giant, with a mass 4 times that of Jupiter, and a radius slightly different from that of Jupiter. At the furthest point in its orbit, the planet is 0.88 astronomical units away from the parent star, and receives about as much heat from it as the Earth does from the Sun. It has been suggested that this is when clouds consisting of water vapor droplets, ice crystals, or even microparticles of quartz may condense in its atmosphere, and temperatures on the surface of the hypothetical satellites of the gas giant could be comparable to those on Earth. But as the planet gets closer to the star, conditions on it change very quickly. Within 55 days, the distance between them shrinks by a factor of nearly 30, and the energy flux from the star increases by a factor of 800. Observations show that at the lowest point in its orbit, the exoplanet's temperature roughly doubles within a matter of just 6 hours, from 500 to 1200 degrees Celsius. Such drastic changes result in violent hurricanes, which can reach speeds of up to 5 kilometers per second. By absorbing an incredible amount of heat, the atmosphere of the gas giant expands so fast that it produces shock waves capable of sweeping across the entire planet multiple times. Water vapor is broken down into oxygen and hydrogen by the temperature, and quartz crystals evaporate without a trace, only to recondense into gigantic sand clouds later. In all likelihood, HD 80606b is the only planet in its system. The gravity of another nearby star has not only warped its orbit, but has also wreaked havoc on the protoplanetary disk. So the chances of encountering other large objects nearby are rather slim. However, destabilization of a planetary system due to the interaction of celestial bodies is not uncommon. 1,530 light-years from Earth, the environs of the Kepler-36 system. The central object in this system is a yellow subgiant. Its mass is comparable to that of the Sun, and its radius is 62% larger than that of our star. There are two planets rapidly orbiting the star, a rocky super-Earth and a hot mini-Neptune. Every 97 days, they mutually approach at a critical distance of only 1.9 million kilometers, about 20 times less than the minimum distance between the Earth and Venus. At such moments, their mutual attraction causes global cataclysms, but after a few days, the celestial bodies diverge again until the next resonance. According to calculations, the gravitational interaction between the planets at the point of closest approach is about 13 times higher than that between the Earth and the Moon. In particular, this effect should be seen on the surface of the rocky planet. Under the influence of titanic forces, its crust may crack and shift, causing earthquakes of incredible power. The resulting chasms may be hundreds of kilometers long and cause multiple eruptions of gigantic volcanoes. It is likely that some regions of the planet do not cool down in the short period of relative tranquility, creating seas of eternally bubbling, red-hot magma. The reasons for the formation of such an unusual system are still debatable. We now know that the super-Earth, dubbed Kepler-36b, is 0.12 astronomical units away from its parent star, and it takes 14 days to complete a full orbit around it. The super-Earth's mass is 3.8 times that of the Earth, and its radius is 1.5 times that of our planet. The object has been calculated to have a temperature of 980 Kelvin, or just over 700 degrees Celsius, and an average density of about 30% higher than that of the Earth. The data suggests that the celestial body could be a Chthonian planet, the core of a gas giant that has lost its atmosphere. Such objects contain many heavy metals like iron and lead, as well as sulfur and silicon compounds. It is likely that the light elements that once made up the thick, dense shell of the celestial body may have been blown into space by stellar wind. Nor should we forget the second planet's gravitational pull, which could potentially have contributed to this process. The object is called Kepler-36c and is likely to fall into the class of hot mini-Neptunes. The celestial body moves in a nearly circular orbit with a radius of 0.13 astronomical units and completes it every 16 days. Its mass is 7 times that of our planet, and its radius is 3.7 times that of the Earth. Because of its proximity to the star, the temperature of the object is also very high, 928 Kelvin, or 655 degrees Celsius. This celestial body should be surrounded by a thick, multi-layered atmosphere consisting mainly of nitrogen, hydrogen and helium. Deeper down, the pressure inside the gas shell increases and it gradually turns into an ocean of supercritical fluid surrounding the solid core. Meanwhile, under certain conditions, truly fantastic phenomena are also possible. For example, the gravity of a more massive planet can potentially capture satellites from its smaller companion, while tidal forces may destroy them to form vast asteroid streams. In addition, the mutual gravitational pull of the two planets distorts their orbits, altering eccentricity and other parameters. Because of this, the entire system behaves chaotically and unpredictably, and its evolution cannot be predicted over any extended period. Modeling shows a 91% probability that the two planets will collide with each other over the next 70 million years, producing hundreds of thousands of pieces of debris which will disperse throughout the planetary system, thereby creating a still greater chaos within it. Such tremendous cataclysms may have occurred more than once in the following system. 434 light-years from Earth. A surprising object, informally called Super Saturn, is located 4 astronomical units away from a young Sun-like star. It is a brown dwarf, or a large gas giant, 20 times as heavy as Jupiter. Observations show it to be a young planet, about 15 to 16 million years old, which is still forming. Most of its atmosphere consists of hydrogen and helium, with a massive metallic core in its depths. This object is spun by a system of rings, like Saturn's but much larger. The transit method revealed at least 37 distinct rings, with the largest one's outer radius measuring about 0.6 astronomical units. This is comparable to the size of Venus's orbit, and about 640 times the radius of Saturn's rings. According to calculations, the total mass of the circumplanetary disk is bigger than the mass of the Earth, and its behavior manifests signs of randomness. Mathematical modeling shows that such structures are not stable and gradually disintegrate. Some of the objects making them up lose velocity and fall to the central planet, while others, on the contrary, accelerate and leave the disk forever. However, this process is greatly extended in time and may take several 100 million years. Also, a large rupture with a radius of about 0.4 astronomical units was detected in the system of rings, which is considered indirect evidence of the existence of an exosatellite in this region, about 80% the mass of the Earth. According to current understanding of the physics of space objects, it is a kind of object capable of clearing its orbit of small debris, forming a wide rupture in the ring structure. In addition, observations suggest the presence of at least 2 more celestial bodies, with a mass of each of about 30% that of the Earth, and located at a distance of about 0.25 astronomical units from the center of the brown dwarf. Just like it is the case with the large planets known to us, it can be assumed that a total of several hundred exosatellites, including rather massive ones, may be located within the gravitational influence of the central object. A simulation of such a system, including radiation from a parent star, heat flow from a giant planet, and tidal influences, shows that the temperature of the celestial bodies making it up could approach comfortable values. One can only imagine how enchanting the night sky would be from the surface of such an exosatellite. At this distance, the brown dwarf occupies 70 times as much space in the sky as the full moon, and its soft glow can dispel the darkness and turn the night into a misty twilight. Instead of the star-spangled canopy, the planet's sky is crisscrossed by vast swathes of light from horizon to horizon. At the same time, the tidal forces of a nearby massive body could provoke multiple eruptions on the satellite's surface, and its hypothetical ocean could slam the land with giant waves. The width of a tidal zone under such conditions could reach hundreds of kilometers, making it a unique climatic zone, something like a cross between land and the ocean floor. Still, it should be mentioned that such structures tend to be unstable and change their appearance quite quickly beyond recognition. It is difficult to say how much longer we'll be able to admire the giant rings and what they will look like in millions of years. Something like a cross between land and the ocean floor. Still, it should be mentioned that such structures tend to be unstable and change their appearance quite quickly beyond... Assumptions about the existence of space objects the size of a planet, which are independent from any star, have been around for a long time. Such celestial objects, freely drifting around interstellar space, are referred to as orphan, free-floating or rogue planets. Astronomical bodies of this kind emit very little thermal and light energy into space around them. It is suggested that there are no bodies in their close proximity they could clearly interact with or be bound to. That is why it is hardly surprising that these objects are so difficult to detect. The first potential representatives of this class of planets were spotted as recently as in the early 21st century. The warmest rogue planets can be detected with infrared telescopes, and others thanks to something called the gravitational microlensing effect. As one would expect, this class of celestial objects is one of the most mysterious and understudied. Today, only 3 astronomical bodies can be classified as rogue planets with a sufficient degree of certainty, with the overall number of rogue planet candidates over 24. Incidentally, according to the analysis of data collected in the course of the Ogle project, the Milky Way may supposedly be home to up to 100 billion objects of this class. This may only mean that right now we're at the very beginning of an upcoming series of discoveries in this field. Our notions of what rogue planets are like have long been based purely on assumptions and hypotheses. With the technological advancement of highly sensitive observation equipment, there arose opportunities to put them to the test in practice. The rogue planet lying closest to the Earth among those already confirmed is known as WISE 0855-0714. 7.27 light-years away from the Sun, it was detected in 2014 with the WISE Orbital Infrared Telescope. The astronomical body cannot be seen through optical telescopes, as it emits no visible light to speak of. The reason for this is its extremely low temperature, from 225 to 260 Kelvin, or 48 to 13 degrees Celsius below zero. In terms of its parameters, it resembles a cooled-off gas giant, and its age cannot be under 1 billion years. The rogue planet is mostly made up of hydrogen. However, in 2016, the Gemini Observatory produced evidence of the presence of large amounts of water in its atmosphere. It is suggested that water is condensed into clouds made up of tiniest particles of ice. Today, it hasn't been established for certain how this object came to be. There are currently 2 versions suggested by researchers. According to the first one, a celestial object like that starts its life cycle in the protoplanetary disk of a regular planetary system. Mathematical modeling of this process shows that if the original cloud of gas and dust is heavy enough, it is highly likely that at least one planet will be ejected beyond the system. The celestial object may also be forced out of its star's environs if another massive star passes it by, or else if its planetary system collides with another system. The chances of events like that are admittedly comparatively small. The other version has it that the space object was born just like any other star on compression of interstellar gas. At the same time, the mass of the object proved to be too small to unleash any thermonuclear reactions in its interior. It goes without saying that in this manner it may turn out only as a gas giant or a brown dwarf, but not a rocky planet similar to the Earth. Some researchers don't agree that these objects should be seen as rogue planets and classify them as sub-brown dwarfs instead. Others suggest using the term planemo for all interstellar wanderers that don't show any thermonuclear activity. Bearing in mind today's notions of the makeup of brown dwarfs and gas giants, we may estimate the mass of WISE 0855-0714 at anything from 3 to 10 Jupiter masses. This rather falls short of starting a thermonuclear reaction, but quite enough to keep the heat effectively trapped inside the planet. Taking into account our knowledge about natural laws, we can predict what the conditions on the astronomical body's surface are like. For example, according to research by David John Stevenson from the University of California in the US, gas giants similar to Jupiter don't cool off instantly after receding from their star. Their thick hydrogen atmosphere is quite reliable thermal isolation, while the dense and hot nucleus made up of metallic hydrogen can keep the planet heated for a considerable time. Estimates show that the temperature of the lowest strata of a hypothetical celestial object's atmosphere may be high enough for liquid water to be around. It is likely to be present in the atmosphere as giant clouds made up of tiniest droplets. These deductions agree with the results of mathematical modeling of WISE 0855-0714 carried out by a team of scientists from the University of Edinburgh. It showed that the most likely temperature value of the planet's surface is 250 Kelvin or 23 degrees Celsius below zero. The celestial body's atmosphere also has a comparatively warm layer around 100 kilometers thick, whose density fluctuates from 0.4 to 1.2 milligrams per cubic centimeter. It is comparable with the conditions on the Earth, and so it is thought that this environment should be favorable for potential organic life. Incidentally, a planet doesn't have to be a massive gas giant to avoid freezing in the cosmos. In 2020, a rogue planet candidate was detected using gravitational microlensing techniques. And here is the long designation it got. It is still awaiting confirmation of the rogue planet's status, and its parameters have been defined only generally so far. According to preliminary data, however, the object is comparable to the Earth in terms of its mass and is anything from 30 to 180,000 light-years away. According to our current scientific notions, an object with a mass like that is not supposed to be a gas giant, and is more likely to be a rocky planet. This, in its turn, offers good grounds to believe that the object formed in the protoplanetary disk of a planetary system as the latter was forming. It may have been ejected from the system as a result of a cataclysm in space, or alternatively, under the influence of a larger neighbor. After that, it was left to its own devices and so became a free-floating planet. What will happen to it next is predefined by a combination of several factors. Provided the object's atmosphere is sufficiently dense, it will be reliably thermally isolated. Potentially, a layer of ice on its surface could produce the same isolating effect. In addition, with the object's interior scorching hot and with radioactive elements undergoing decay, most of the hypothetical ocean will remain in a liquid state. If the planet happened to have a moon, it may have retained it on ejection. If this is the case, tidal forces are likely to continue to deform and warm up the lithosphere. Theoretically, with any luck, primitive anaerobic life forms may have stayed around, although of course it would be next to impossible to discover their traces now. Most of the data about the rogue planets we know today were arrived at following mathematical modeling and complex calculations. It was possible to do these calculations thanks to the tiniest bits of information gleaned with the help of orbital and Earth-based telescopes. Even as I speak, a project is being worked on known as Cleopatra. Its main objective will be to search for free-floating planets and other objects in space with subsequent definition of their parameters. The project relies on something called microlensing. It is a phenomenon when a celestial body passes between a remote star and the observer on the Earth and briefly interferes with the light emitted by the remote star in the background. When observed from different angles, the moment of transition will be registered a fraction of a second sooner in one observatory than in another. Referred to as lensing parallax, this effect allows scientists to gauge the distance to a detected object, as well as its mass and dimensions. An interplanetary spacecraft is planned to be created within the project. It is supposed to blast off the surface of the Earth as soon as in 2025 alongside a mission to Mars, after which it will enter its own orbit around the Sun. The project will be aided by a specialized artificial intelligence component. whose mission will be to process and analyze collected information. The Cleopatra project will certainly delight us with a wealth of exciting and important information, so there is a lot to look forward to. What is to become of all those rogue worlds out there, drifting quite by themselves in the dark depths of the universe? In theory, an orphan planet may be captured by the gravitational field of a star and become part of its planetary system, but this chance is by all accounts minuscule. Most objects like that are destined to wander for billions of years through endless expanses of space, while slowly and inevitably cooling off. Eventually, they're to be swallowed up by black holes, or else destroyed as a result of a cataclysm in space, never to reveal their secrets to mankind. Most objects like that are destined to wander for billions of years through endless expanses of space, while slowly and inevitably cooling. The year 2003. They're to be swallowed up by black holes, or else destroyed. As the starry sky was being routinely observed, a small yellow dwarf was detected in the Phoenix constellation. It was later to be dubbed WASP 96. The year 2013. The Super WASP orbital telescope detected an extremely rarefied gas giant in the immediate vicinity of the star. A preliminary spectral analysis of its atmosphere revealed that it was remarkably transparent and practically devoid of any water vapor. The year 2022. Analysis of the object's atmosphere was conducted again, this time with the help of the new generation orbital telescope James Webb, which offered an unprecedented accuracy. Scientists were taken aback. If the new data were to be believed, the exoplanet was supposed to be shrouded in thick layers of clouds, which was the exact opposite of what the previous observations had revealed. Thus, the data from the James Webb was in conflict with the earlier estimates, and the degree of our understanding of the universe was questioned yet again. So, what is this amazing telescope like? And what has it seen in the depths of space so far? Let's take a closer look at it. The history of the largest modern orbital telescope began back in 1996. Its development and modernization took as long as 25 years, after which the spacecraft left our planet and set out on its journey through space. It took James Webb a month to reach its destination point, located 1.5 million kilometers from our planet. Because the telescope is equipped with high-precision infrared sensors, it can see the dimmest and most distant space objects hidden in the depths of the universe. However, this unmatched sensitivity also has a downside. The intense radiation from the Earth, the Moon and the Sun interferes with the faint signals of distant stars and exoplanets. Therefore, in order to counteract this effect, the super-sensitive instruments were covered with a multi-layer heat-reflecting screen. The observatory itself had to be moved away from large celestial bodies and be located near the so-called second Lagrange point in the shadow of our planet. Still, the obtained results were absolutely worth all the effort, because James Webb helped us make quite a number of amazing discoveries pretty much from the very first days of its operation. With some of them quite expected, others, on the other hand, prompted additional questions. One of the studies with a paradoxical outcome was the spectral analysis of WASP-96b, a glowing exoplanet of extremely low density. It is located 0.045 astronomical units from its parent star and completes a full orbit around it in just 3.5 days. According to calculations, the mass of the celestial body is half the mass of Jupiter, and its diameter is 20% more than that of Jupiter. Because of the extreme proximity to the star, the temperature of the object's outer layers is quite high, and reaches 1285 Kelvin, or just over 1000 degrees Celsius. Exoplanets of this type fall in the category of hot Jupiters and are distinguished by large losses of atmosphere due to stellar wind. Earlier measurements showed very clear lines of sodium in the atmosphere of WASP-96b, which was interpreted by the researchers as a sign of an unusually clean and cloudless atmosphere. The fact is that according to the available models of the structure of gas giants, this element can exist only in the planet's interior. As we can see traces of it, it means that the upper regions of the celestial body's atmosphere practically do not absorb light. It was assumed that thanks to this, the ultra-sensitive detectors of James Webb could look into the deepest layers of the exoplanet. However, the information obtained by the telescope turned out to be radically different. The outer layers of the gas giant contain great amounts of water vapor. It condenses in the upper atmosphere and can form a large haze or thick clouds, reflecting some of the light shed on it. Because of this, the temperature of the lower layers of the object may differ significantly from the calculated values. Perhaps the accuracy of the earlier study was insufficient, or else some of the data was misinterpreted. It is also possible that we do not yet know of a certain factor that would allow us to combine the results to form a single correct picture. WASP-96b remains a mystery, which means it still needs to be studied in more detail. Of course, James Webb's discoveries do not end there. For example, 69 light-years away, there is an unusual system consisting of 3 brown dwarfs at once. These cosmic bodies are too big to be planets, and at the same time too small to launch a stable thermonuclear reaction in their interior. Brown dwarfs are usually difficult to detect, as the radiation of their surface is extremely low. But James Webb sees the universe primarily in infrared, which makes it easy to distinguish objects that are virtually invisible in the optical range. The 2 largest components of the system are very similar in their characteristics and are located quite close to each other. The distance between them is about 2 astronomical units, and their total mass is slightly more than 100 times that of Jupiter. The temperature of both objects is relatively high, reaching 2600 Kelvin or slightly over 2300 degrees Celsius. The third component of the system is at a much greater distance, about 100 astronomical units from the center. Its mass is between 14 and 23 Jupiter masses, and its radius is 20% more than that of Jupiter. Also, this brown dwarf is about twice as cold as its more massive companions. Observations reveal that the temperature of its outer layers is 1240 Kelvin or slightly below 1000 degrees Celsius. Nevertheless, the celestial body is considerably warmer than the gas giants in our system, especially given the absence of a star that would give it heat. It was surprising to find that the outer layers of this brown dwarf contain not only the usual components such as water, methane or carbon dioxide, but also minute particles of various silicon compounds. The simplest of these is quartz, but more complex substances have also been detected. These are thought to be concentrated in the atmosphere of the celestial body in the form of vast clouds. The existence of such clusters had previously been predicted from theoretical considerations, because silicon, being a product of stellar thermonuclear reactions, is quite widespread in the universe. Still, until recently, observations have not been able to confirm this hypothesis. It is thought that about 140 million years ago, there was a single gas-dust cloud in the system's place, which later split into 3 independent clumps. This event may have been caused by the gravitational influence of a massive celestial body that passed close to the protostellar nebula. Remarkably, if the separation had not occurred, the total mass of the formed object would have been enough to start a self-sustaining thermonuclear reaction. In this case, instead of 3 brown dwarfs, we might have been observing a single tiny star. Incidentally, the James Webb equipment is capable of observing not only single objects tucked away in the depths of space, but tremendous space structures as well, that stretch for hundreds of light years. One of them is the Carina Nebula, which is one of the largest stellar nurseries in our galaxy. This bright and vast cluster is located about 8,500 light-years from the Earth and has a mass of up to 900,000 suns. It contains not only giant clouds of interstellar gas and dust, but also thousands of stars, from the smallest ones to the most gigantic. This is where two of the Milky Way's brightest objects are located: Eta Carinae and WR25. The luminosity of each is several million times greater than that of the Sun. Unique objects like that certainly attract astronomers' attention. Besides, James Webb's infrared cameras are able to pick out great numbers of stars in the dusty haze, which were previously unknown to us. The point is that it is in this area in space that hundreds of young stars are constantly getting born. According to modern concepts, new stars are formed by gravitational forces that compress and heat up clouds of cosmic dust. During its evolutionary process, a protostar goes through several stages until finally a thermonuclear reaction kicks in its interior. This theory has been confirmed by multiple observations, but many details of this long and complex process currently remain understudied. The formation of a new star sometimes takes millions of years, but astronomers don't need that long to observe it. Thanks to James Webb's infrared sensors, thousands of protostars and young stars at various stages of evolution have been detected in the Carina Nebula. It is important to note that all these objects formed within the same gas cloud, which means that they're very similar in terms of composition and age. By observing them, researchers can fully trace the process of star formation and better understand what forces are involved. Some phases of this process, predicted only in theory, take hours or days, and with James Webb, the chance of capturing them is greatly enhanced. For all we know, we may soon be able to admire a photo of a young star flaring up thousands of light years from the Sun. Meanwhile, an 18-section mirror 6.5 meters in diameter and an onboard array of high-accuracy instruments allow James Webb to capture light from objects much further away, at the very edge of the visible universe. They are more than 13 billion years old, giving us a glimpse of the earliest times immediately after the hypothetical Big Bang. However, even James Webb would not have been able to see their luminescence but for one unique coincidence. The phenomenon of gravitational lensing has long been known to scientists. This physical phenomenon helps us to better see into the depths of the universe. And this is how it works. A powerful gravity generated by a massive body focuses and amplifies the light from a source behind it. Such an effect can be produced only on condition that a great many factors happily combine, so it is not surprising that it is one of the rarest phenomena in the universe. It is all the more surprising that while observing the galaxy cluster SMACS 0723, located about 4 billion light-years from the Earth, James Webb captured light of a space object passing through gravitational lenses as many as 3 times. In total, the radiation was amplified about 20 times, without which astronomers would hardly have been able to distinguish it from background noise. The object is thought to be a distant and very old galaxy, whose age is estimated to be 13 billion years. About 10 other star clusters have also been detected, which are thought to have originated between 200 and 700 million years after the genesis of the universe. According to some observations, they have a complex structure which takes tens of millions of years to form. This discovery will allow scientists to develop the existing ideas about the early stages of the universe's evolution and may even prompt to question its age. Unfortunately, we still know very little about such remote times, and James Webb will surely help us learn more about them. This discovery will allow scientists to develop the existing ideas about the early exoplanets differ very much in terms of their environment. Their dimensions may be enormous, some even beating Jupiter, but there are also comparatively smaller ones, close to our Earth in size. Some of these bodies are hot, consumed with oceans of molten lava, whereas others are encased in a shell of permanent ice. There are planets out there made entirely of oceans, with not a bit of dry land on them, while on others sulfuric acid rains or diamond snow are irregular occurrence. Various techniques are used for discovering other worlds. As a rule, it is next to impossible to spot an exoplanet by simply looking through a telescope. That is why in 2009 Kepler was launched, the first space telescope designed for searching for planets beyond the boundaries of the solar system. The telescope's cameras had 42 charge-coupled devices, or CCDs, with a total resolution of around 96 megapixels. With a field of view covering about 25% of the sky and coupled with a 1.5-meter mirror of the telescope, it was able to detect astronomical bodies within 3,000 light-years from the Earth. In the 3.5 years of productive operations, Kepler managed to spot over 3,500 exoplanet candidates. The status of over 2,000 of these has already been confirmed by repeated observations. It was in this period that the smallest of known exoplanets today was detected. The diameter of Kepler 37b is just 35.7% that of the Earth. The telescope was also instrumental in registering several stars and brown dwarfs. The transit method was used by Kepler in the search for exoplanets. This method is based on observing the star's luminosity. If the supposed planet passes between the parent star and the observer, this will be noticed in the telltale decrease in the star's luminosity. The extent of these fluctuations in luminosity directly depends on the ratio of the stars' and planets' dimensions, while their regularity allows one to estimate the object's orbital period. The transit method requires accuracy in measurements. Changes in a star's spectrum account for less than 2% and are usually tenths or even hundredths of 1%. Ripples in the atmosphere, dust and precipitations negatively affect results produced by Earth-based telescopes. That is the reason why telescopes based on automatic space stations are used for searching for objects beyond the boundaries of the solar system. Unfortunately, in 2013, 3.5 years into the mission, the Kepler Space Telescope had several major equipment failures. In 2018, the spacecraft ended science operations completely. Kepler was the first spacecraft to be created specifically for looking for exoplanets. However, most of the objects it managed to spot happened to be too remote and dim to study them in any satisfying detail. That is why the next space research complex had slightly different parameters. Kepler was succeeded by the TESS telescope launched by NASA on the 18th of April 2018. Its main object was searching for rocky exoplanets orbiting the brightest stars within 200 light-years from the Sun. This telescope also used the transit method, and here is the spacecraft's brief profile. TESS is equipped with 4 refractors with a 24 by 24 degree field of view and a 10 centimeter aperture. The spacecraft's peculiar orbit allows it to cover both the northern and the southern parts of the sky, which is approximately 85% of the entire sky. Photos are taken by 4 cameras, and the resolution of each camera's CCD is 16.8 megapixels. TOI 700D is one of the most notable objects discovered by TESS. This exoplanet became the first object of the kind comparable to the Earth in size, and which found itself in the habitable zone of its star. It orbits TOI 700, a red dwarf lying slightly over 100 light-years away from the Sun. It is a small and rather cold star. Its temperature is half that of the Sun, and its mass and radius are just 40% those of the Sun. TOI 700 is peculiar for its high stability. not a single flare has been registered on it since the beginning of observations. A star's stability is a positive feature, because bursts of activity are able to divest its planets of their atmospheres and be generally pernicious for potential life on planets' surfaces. There are at least 3 planets orbiting TOI 700. The one closest to it, TOI 700b, is comparable to the Earth in size. Its mass is approximately 1.07 times that of our planet, and its radius differs from that of the Earth by not more than 2%. Unfortunately, TOI 700b is too close to its host star. It is within about 0.06 astronomical units, and a year on the planet lasts just 10 days. In addition to that, chances are it is tidally locked, that is, it faces the star with one and the same side. This means that the planet is likely to be scorching hot. The planet lying further from its star, TOI 700c, is thought to be a mini-Neptune. Its mass may be from 5 to 13 times that of our Earth, and its radius is 2 or 3 times that of the Earth. It takes TOI 700c 16 days to complete one orbit around its host star. Located closer to the star than the inner border of the habitable zone, it must be too hot for life to originate and evolve there. TOI 700d is the third and at this point the remotest planet in the system discovered by now. It takes 37.4 days to complete a full orbit, which by the way lies along the inner edge of the habitable zone. The mass of TOI 700d hasn't been gauged precisely and may be anything from 1 to 3 times that of the Earth. At the same time, the planet's radius is just 20 to 30% bigger than that of the Earth. TOI 700d is thought to be a rocky world, but its exact composition is not yet known. The amount of energy received by the planet from its star is 86% that of the amount we receive from the Sun. Assuming the planet's atmosphere is similar to ours, the steady-state temperature on the surface of TOI 700d is estimated at 268.8 Kelvin, or 4.3 degrees Celsius below zero. However, due to the greenhouse effect, or other features of the atmosphere we may not know yet, this figure may shift either up or down. There is no precise data on the eccentricity of TOI 700d, but it is thought to be small at around 0.11. As the planet's orbit finds itself at the inner edge of the Goldilocks zone, the planet's eccentricity, however small, may incidentally turn out to be perceptible when the planet comes too close to its star from time to time, thus actually leaving the habitable zone. Still, with a year on the planet lasting slightly over 1 Earth month, such unfavorable periods are expected to be rather short. If there are living creatures on TOI 700d, then they might be able to weather the harsh spells in a state of anabiosis. Alternatively, they could adapt or migrate to less inclement areas. Even though the data acquired by spectral analysis of TOI 700d can't be enough for making conclusions, there is a chance that there is liquid water on the planet's surface. Then there is bound to be the greenhouse effect too, which will help the surface temperature to reach favorable values. As I've already mentioned, TOI 700d, along with the other known planets in the system, is highly likely to be tidally locked to its star. If this is the case, there should be a stark difference in temperatures between the sunny side and the shadow side. This contrast could be leveled off by a dense atmosphere, but that would cause powerful hurricane winds. Although the main mission of TESS has been accomplished by now, it still has enough resources to carry on operations. The telescope will continue taking snapshots of the sky, including the Milky Way plane, which is the most challenging direction for observation. Over 2,100 exoplanet candidates have been discovered by TESS in the course of the main mission. Not less than 66 of them have already been confirmed. Apart from that, 6 supernovae flares have been registered, 3 exocomets identified, and a great number of photos taken of small bodies in the solar system. The latters were not objects of the main mission, but are of course of scientific interest. Not less than 66 of them have already been confirmed. Apart from that, 6 Shortly before Halloween in 2020, NASA compiled a list of the most terrifying worlds. Among others, they included 6 exoplanets. Each of these objects' environments is not just extremely harsh for any living organism, even finding oneself in their comparatively close proximity may prove to be fatal. The first object on the list is a black gas giant, designation TRES-2b. This celestial object orbits the star TRES-2, which is a yellow dwarf lying as far as 718 light-years away from us. Let's take a closer look at it. Due to some unique properties of the chemical composition of the surface of TRES-2b, the planet absorbs over 99% of all the light shed on it. The nature of these properties remains a mystery, and chances are there are some chemical reactions taking place on the surface that we have never registered on any similar object before. And it is these properties that make TRES-2b the darkest exoplanet on the astronomical map of today. This gas giant was discovered on the 21st of August 2006, with more details on its characteristics obtained several years later. The mass of TRES-2b is 1.2 Jupiter masses, and its radius measures 1.27 times that of Jupiter. The atmosphere is as scorching as 1000 degrees Celsius, which gives the exoplanet a faint red glow like that of embers. Still, in spite of its gloomy looks, TRES-2b doesn't really qualify to be called the most dangerous place in the universe. There are many more objects lurking in space that are more terrifying than that. Let's see some more inhospitable ones. Here is another exoplanet, designation 55 Cancri E. It lies in the system of a Sun-like star, designation 55 Cancri A. This celestial object was discovered on the 30th of August 2004 by the Doppler spectroscopy method. Let's look at it in more detail. The planet's mass equals approximately 8 Earth masses, and its radius measures 1.875 that of the Earth. 55 Cancri E is tidally locked, and so it is always daytime on one side and nighttime on the other. That is why the side facing the host star is always heated up to a temperature reaching 2400 degrees Celsius, with the temperature on the night side 1300 degrees Celsius. These values are so high because the distance between the planet and its parent star is just 0.0183 astronomical units. Besides, volcanism on 55 Cancri E, which is thought likely to be there, causes dust clouds emissions. These clouds trap heat and effectively prevent it from escaping into space. The planet's orbital period is slightly under 18 hours. As for the atmospherical makeup, there is helium and hydrogen registered in it. There are also large amounts of carbon. Incidentally, this element is likely to form thick layers of graphite and diamonds in the planet's interior. 55 Cancri E isn't the only object in the planetary system of its host star. There are 4 other celestial objects orbiting it. The environments on these are by far more hospitable, which is the feature by which the 55 Cancri A system differs from the following object. It is dubbed Poltergeist, or PSR 1257 plus 12c. This is an exoplanet lying in a pulsar system. The celestial object is located just 0.36 astronomical units from the system's center. This shows that Poltergeist wouldn't have survived a supernova that must have taken place before the pulsar had been formed. Consequently, the exoplanet is likely to have formed after this tremendous event, with the material for it coming from the nebula left after the explosion. According to another hypothesis, the pulsar may have formed after the merging of 2 white dwarfs. Unlike with a supernova, this process isn't always accompanied by a powerful blast. Still, as this is the first object of its kind we have discovered, science cannot give a definite answer as to its origins. The system with the celestial object lies 2,300 light-years from the Earth. Its mass is approximately 4 times that of our planet. As for its orbital period, it is around 66 days. Incidentally, the outstandingly powerful radiation emitted by the pulsar is enough to crumple any spaceship wanting to approach the mysterious exoplanet in its system. Even with all these properties taken into account, Poltergeist does not really qualify as the most dangerous exoplanet known to us. On approaching it, an astronomical body may simply get destroyed, but it would get positively vaporized in close proximity to the following object. The reason for this effect is the extremely high temperature on Kepler 70b, which is the hottest exoplanet known to us. The object orbits the subdwarf star Kepler 70. With a surface temperature higher than that on our Sun, it reaches 6,800 degrees Celsius. The object's mass equals 0.44 Earth masses, and its radius measures 0.76 that of the Earth. The celestial object's orbital period is 345 minutes. In other words, a day here is less than 6 hours long. Interestingly, the exoplanet regularly passes another object in the system, Kepler 70c, at a distance of 240,000 kilometers. To date, this is the closest that planets in space have been registered to pass each other. The extremely high temperature on Kepler 70b could be accounted for by the fact that this object may once have been part of its parent star. As for giving it the status of an exoplanet, it will take more evidence to confirm that it deserves to be given it, so this remains an open question. It should be mentioned that Kepler 70b is not the only celestial object we know of that interacts with its parent star so closely. Another object in similar conditions is the exoplanet known as WASP-12b. This celestial body lies 870 light-years away from our system. Its radius measures 1.93 times that of Jupiter, and its mass equals 1.46 Jupiter masses. WASP-12b is just 0.03 astronomical units away from its parent star. Due to this close proximity, the exoplanet has a temperature reaching as much as 2,200 degrees Celsius. The host star's extremely powerful gravitation slowly absorbs WASP-12b. Eventually, in approximately 10 million years' time, the exoplanet is expected to be destroyed completely. Bearing all this in mind, we will probably never delve any deeper into the nature of this exoplanet. It would appear that studying worlds of this kind cannot be high on scientists' list of priorities. However, some of these objects may happen to have some really unique features. Seemingly quite plain and ordinary, worlds like that may conceal many more dangers than would appear at first glance. When flying past the celestial body HD 189733b, for example, one might complacently think it a safe planet, as it resembles our Earth by its looks. But if one were to get as low as the level of its atmosphere, one would be exposed to some life-threatening dangers. For a start, the object's winds carry particles of silicate and develop velocities of 8,700 kilometers per hour. Besides, the rains on this planet cause precipitations of molten glass. The reasons for such hazardous weather conditions are extremely high temperatures and the atmosphere's peculiar chemical composition. Speaking about the exoplanet's orbital period, it is approximately 2.5 days. And it is highly likely that the object is tidally locked to its parent star. As usual, a quick overview of its main characteristics. HD 189733b is a bright blue gas giant orbiting an orange dwarf in the constellation Vulpecula. It lies just 63 light-years away from our system. The object's diameter is 1.1 times that of Jupiter, and as for its mass, it is 113% that of Jupiter. Interestingly, the distance between HD 189733b and its star is 30 times less than the distance between the Earth and the Sun and equals approximately 5 million kilometers. Due to its close proximity to the parent star, it has a constant surface temperature of as high as around 930 degrees Celsius on the day side, with the temperature on the night side never dropping below 425 degrees Celsius. Immediately on being discovered, the celestial body became a subject of investigations. In 2007, thanks to data obtained by the Hubble telescope, scientists found out that HD 189733b has a foggy atmosphere. Interestingly, when the planet transits between the observer on the Earth and its star, its atmosphere assumes a reddish hue. This effect could possibly be caused by the haze in the atmosphere. According to preliminary estimates, it consists of particles of iron, silicates, and aluminium oxide. Apart from that, the information beamed back by the Hubble telescope helped scientists establish that the planet's atmosphere contains water vapor, neutral oxygen, and an organic methane compound. Additional investigations revealed the presence of carbon monoxide on the day side of the planet. What prompted most questions, however, was the results of investigations revealing traces of methane of an unusual variety in the planet's atmosphere. This chemical element was shown to be in a peculiar fluorescent state when it emits electromagnetic radiation in the infrared range. This state of the substance is indicative of some unknown activity in the atmosphere of the exoplanet, which still remains to be found out. This is quite a clear-cut example of a situation when investigating an object like an exoplanet with an exceptionally harsh environment may yield unexpected results about some processes taking place there that will be a valuable contribution to science. And as the process of studying these worlds continues, they will remain no other than horror planets to us, as well as a solid reminder that we're more than just lucky to be the dwellers of our Earth. The first steps in theoretical confirmation of there being ocean worlds out there, that is, planets fully covered in water, were made back in the 1970s. That is when evidence was found that radioactive decay in a planet's interior and tidal forces may cause water ice to melt and subsequently form huge oceans. In all likelihood, similar processes take place on Jupiter's and Saturn's satellites. However, these celestial bodies remain icebound as they lie too far away from the Sun, whose rays would otherwise melt the thick layers of ice. But when we talk about an ocean planet, a slightly different type of space object is meant. The term implies that the ocean on a planet's surface isn't concealed under a layer of ice, and its depth measures more than 100 kilometers. Theoretical calculations of these planets' formation and evolution processes were carried out in 2004 by French astrophysicists headed by Christophe Satin. According to this theory, if the mass of a forming planet is more than 10 times that of the Earth, this starts to actively attract hydrogen and helium from the gas and dust cloud around it. In this manner, with time, it grows into a gas giant. By contrast, if this planet's mass is just 6 to 8 Earth masses, the new planet is going to be comprised of ice and rocks roughly in equal measure. Just to compare, the mass total of all water in the global ocean on our Earth accounts for just 0.025% of the Earth's total mass. In this case, provided a space object's orbit lies far from the host star, this object is going to be either an ice giant or a cold super-Earth. Radioactive decay taking place inside the core will help melt some portion of the ice, which in its turn will help form a subsurface ocean, but the planet's outer layers will still remain frozen. If the planet happens to find itself in its star's habitable zone, its outer layers will melt and spill all over the surface in a boundless ocean. Theoretical calculations show that a planet with a mass 6 to 8 times that of the Earth may have a layer of water over 100 kilometers thick. The pressure exerted by this amount of water may reach 20,000 atmospheres, depending on temperature, impurities, and other parameters. This is enough for some special exotic varieties of ice to form, like ones remaining solid even at high temperatures. In addition, unlike the familiar water ice, these modifications would be heavier than liquid water. For example, the density of ice 7, which is likely to form in these conditions, should be around 1,650 kilos per cubic meter. This ice settles on the planet's ocean's bottom and forms a massive cryosphere that envelops the more massive core. The opportunity to put these theoretical assumptions to test arose when a tiny and dim star was spotted 42 light-years away from the Earth. It was dubbed Gliese 1214. The diameter of this red dwarf turned out to be 5 times smaller than that of the Sun, with its mass just 15.7% that of the Sun. At the same time, Gliese 1214 is 300 times dimmer than our parent star, while its surface temperature is only 3000 Kelvin, or 2700 degrees Celsius. There is nothing particularly remarkable about the star itself. To be blunt, it is just another nondescript red dwarf that looks like any of the billions of other stars in our galaxy. However, in 2009, a solitary planet was detected in its environs, which was dubbed Gliese 1214b. With its diameter measuring 2.5 times that of the Earth, this exoplanet is just 6.5 times heavier than our home planet. Straightforward calculations show the freefall acceleration on the exoplanet's surface to be just 91% that of the Earth. The average density of Gliese 1214b is approximately 1,870 kilos per cubic meter. Judging by this comparatively small value, the exoplanet cannot realistically be made up of mostly metals and rocks, as is the case with our Earth, for example. But incidentally, this average density value seems to confirm the assumption that the astronomical body is 75% water or water ice and just 25% rocks. Thus it appears safe to suggest that this exoplanet is an ocean planet. The object lies very close to its host star. The average distance between them measures just around 2 million kilometers, or 0.014 astronomical units, which is 75 times smaller than that between the Earth and the Sun. Also, the orbit eccentricity is rather high at 0.27, slightly more than that of Pluto. This means that in its perihelion, Gliese 1214b is approximately twice as close to its star than when in its aphelion. As for its orbital period, it takes the planet about 36 hours to complete it. The red dwarf Gliese 1214 may be 300 times dimmer than the Sun, but this incredible proximity to the star makes the climate on Gliese 1214b scorching hot. Supposing the reflection coefficient of the surface of Gliese 1214b is the same as that of Venus, the planet's surface temperature is supposed to be around 393 Kelvin or 120 degrees Celsius. If, on the other hand, the surface is darker, the temperature may reach as much as 553 Kelvin or 280 degrees Celsius. Due to the fact that the orbit of Gliese 1214b crosses the star's disk, scientists are able to carry out spectroscopic investigations of its atmosphere. Still, the results are rather ambiguous. If this space object really is an ocean planet, its atmosphere is supposed to predominantly consist of water vapor with some accompanying gases. Interestingly, no lines of hydrogen, helium, or complex substances like water, CO2, and ammonia have so far been detected in the planet's spectrum. It is thought that the outer layer of the dense atmosphere conceals its true content from the observer. The conditions on the surface of Gliese 1214b remind one of what it is like inside a giant steam boiler. Interestingly, the atmospheric pressure in its lower strata should be at least 15 times as high as that of the Earth. As the ocean and the atmosphere are in a state of thermodynamic equilibrium, the border between them is rather blurred. No wonder, as the density of water vapor just above the ocean's surface is practically equal to that of constantly boiling water. As we look deeper, at the lowest strata of the ocean, the pressure will continue to increase until we reach the depth of 100 kilometers. With the pressure value at this depth, water will be unable to remain in its liquid state even at temperatures this high, and so we will see the bottom made up of dense and heavy ice. whose thickness is estimated to be upwards of 5,000 kilometers. Thus, most water on the planet is concentrated here. Below the cryosphere, there should be the core, made up of rocks and metals. Unfortunately, chances of life evolving on any ocean planet are rather thin, even if the surface temperature happens to be more favorable than on this one. This is so due to the fact that oceans on planets like that are too poor in terms of microelements that are vital for living creatures. Even taking into account meteorites that occasionally bombard the surfaces of these celestial bodies, the chemical diversity is simply not good enough for life to originate here. Still, studying ocean planets poses a great scientific interest. According to NASA's mathematical modeling estimates published in 2020, there may be billions of planets of this type in our galaxy, both cold, harboring an ocean under an ice shell, and warm, like Gliese 1214b. Water is one of the most widespread complex chemical compounds in the universe, and this means that the chances of discovering new ocean planets are quite optimistic. There is a giant cloud in space, hundreds of light years away from the Earth, with some of its areas concealing dozens of yet unborn stars. Others are ripped apart by tremendous flashes. The space here is permeated by lethal ionizing radiation and threads of red-hot hydrogen, and fiery vortices are capable of absorbing whole stellar systems. This is where stars are born, the stellar nursery which is closest to the Earth. What does it conceal from us? There are stellar nurseries richly scattered across the galaxy, with some of them comparatively modest in size. Others stretch for tens and even hundreds of light years. These are vast nebulae made up of interstellar gas and dust being inexorably compressed by gravity forces. Most of these tremendous clouds are barely visible against the abyss of space, but some of them can be seen from the Earth with the naked eye. One of these structures is the Orion Nebula, located 1,344 light-years away from the Earth. It is the middle object in the so-called Sword of Orion, a clearly visible line produced by three relatively bright light sources. Due to its large size and comparative closeness to the Earth, the nebula has been attractive for scientists ever since the early days of astronomy. It is hardly surprising, therefore, that this great structure is one of the best-studied space objects. It was the Hubble Orbital Space Telescope that beamed back first images of the Orion Nebula back in 1993, where the rich diversity of its colors can be appreciated. Most of the material was of a reddish or bluish-purple hue, while unusual bright green lines of some peripheral areas were revealed by spectral analysis. This phenomenon perplexed scientists for a long time, as the observed radiation did not demonstrate any chemical element known at the time. There was even a hypothesis that was put forward about there being a hypothetical element, nebulium, argued to be not present on our planet, but allegedly amply scattered across clouds in space. However, with the advancement of science, it turned out that the light was emitted by extremely rarefied and ionized oxygen. This discovery accounted not only for the bizarre illumination of many nebulae, including our Sun. There are currently not less than 3,000 stars discovered in the Orion Nebula to date, as well as giant clouds of interstellar gas and a great number of protostars. All this amazing diversity of space objects is concentrated in an area of around 23 light-years in diameter, all of them continuously and elaborately interacting with each other. The overall mass of the material concentrated here is around 10,000 solar masses. Looking at the Orion Nebula closer, we will notice several clearly defined areas. The most outstanding of them is trapezium, also known as Theta 1 Orionis. It's an open star cluster about 300,000 years of age, made up of 8 main components. Some of them are binary stars, others have no companions. The brightest and most noticeable of the trapezium stars are 4 stellar systems designated by letters of the Latin alphabet. Located close to each other, they lie within an area about 1.5 light years in diameter. Each of these objects' mass is within 15 to 40 solar masses, which means that these stars are quite young and hot. Theta 1 Orionis C is the most massive, as well as the brightest star in both the trapezium cluster and actually the entire nebula. It is a white and blue main sequence star with a mass roughly 40 solar masses, whose radius is 8 times that of the Sun. The object's surface temperature is approximately 45,000 Kelvin, and its luminosity about 250,000 times higher than that of the Sun. The radiation of Theta 1 Orionis C illumines virtually all the nebula around it, but there is hardly any interstellar gas in its immediate vicinity. This is the case due to the fact it is typical for objects of this class to experience exceptionally powerful stellar wind that scatters rarefied material far off. Having traveled a few light years away from trapezium, we will see another remarkable system, which is Theta 2 Orionis. It is made up of 3 gravitationally bound stars located close to the so-called Orion bar, an extensive feature of hot gas emitting bright light. It was impossible to study this area for a long time on account of dense clouds of dust, and thanks to the James Webb Telescope, more detailed images of this region have been beamed back to us. The first component of Theta 2 Orionis is just slightly less massive and not as luminous as the trapezium's biggest star. As for its surface temperature, it measures about 35,000 Kelvin. The second component of the system is 15 times as massive as the Sun and 12,000 times as bright. The third component is as heavy as 5 solar masses, and its temperature almost reaches 14,000 Kelvin. However, it wasn't just bright stars that caught the researchers' attention. James Webb's infrared cameras allowed it to detect previously unseen objects, hidden deep within the clouds of gas and dust. Thanks to the telescope, about 180 so-called proplids have been discovered at the heart of the Orion Nebula. These are dense, dark protoplanetary disks surrounding stars that are still in the process of formation. One of these is Orion 294-606, a young protostar about 1 million years old, surrounded by a gas and dust disk about 300 astronomical units in diameter. Thanks to its being edge-on to Earth, we can observe its structure and size. It is expected to hit the main sequence phase in a few million years, and it will be accompanied by a system of several exoplanets and possibly their satellites. The night sky of these future celestial bodies must be a truly fantastic sight. Just imagine a multicolored luminous veil with the glow of a multitude of close and bright stars, far more numerous than those seen from the Earth, coming through. And now and then tremendous swirls of glowing gas cover half the sky, turning the night into translucent twilight. If we fly a little further and examine the wider region, we see that the bulk of the nebula is filled with scattered gas. The central part of the cloud is filled with highly ionized hydrogen, which actively absorbs high-energy stellar radiation. The temperature of this gas can reach 10,000 Kelvin, but it falls sharply towards the edge of the region. Temperature and pressure contrasts, as well as the collision of stellar wind streams, set material in space in motion, creating tremendous currents and vortices. According to calculations, some of them can reach speeds of up to 50 kilometers per second, and their size can be greater than the solar system. Also, in some areas of the nebula, thin strands stretching for several light years have been detected, consisting of relatively cool molecular hydrogen, without mixtures of methane, ethane, and water. Further out, we will see that the central region of the Orion Nebula is enveloped in a vast cloud of cooler, denser gas. The cloud of bright stars and the luminescence of ionized hydrogen intricately intertwine here, creating a beautiful multicolored curtain of light. Hidden behind it are hundreds of space objects, invisible in the optical range. But the infrared cameras of today's telescopes allow us to see through the veil of interstellar matter. By combining data from different sources, astronomers have discovered about 700 protostars at different stages of evolution within this region. Their concentration is noticeably lower than in the central part of the nebula due to the lower degree of gravitational compression of the interstellar gas. The absolute majority of these objects are very young by space standards and are still in the process of formation. According to modern concepts of stellar evolution, new stars form during gradual gravitational compression of large clouds of interstellar gas. Typically, as a result of this process, giant nebulae split up into a number of closely grouped gravity centers, which soon turn into protostars. Such clusters are called stellar nurseries, or more scientifically, regions of star formation. At a certain point, the internal pressure of the compressed gas compensates for the gravitational forces, bringing the protostar to a state of temporary equilibrium. The remaining material swirls into a giant vortex disk, with some of it gradually absorbed by the future star, and the rest of it, by contrast, expelled far beyond the boundaries of the nascent system. The growing magnetic field of the young star also plays its part. As ionized particles accelerate through its field lines and then rapidly escape from the vicinity of the object, it has been calculated that such flows can reach speeds of up to several hundred kilometers per second. As they collide with the gas clouds surrounding them, they create large-scale vortices and hemispheres called Herbig-Haro objects. In the process, part of the kinetic energy dissipates into light and heat, giving these bizarre structures different colors. In addition, the ultra-fast motion affects the surrounding material, spreading shockwaves across it, which incidentally are also captured by telescopes. Since stellar nurseries contain many closely spaced protostars, each producing several gas emissions, it is not surprising that Herbig-Haro objects exhibit an amazing variety of shapes and colors. Clearly, being essentially the result of a major cosmic collision, they are highly unstable and variable. Herbig-Haro objects rapidly change color and shape, and typically disperse completely over several tens of thousands of years. During this time, they cover between 1 and 3 light years on an escape trajectory from their parent stars. About 400 such objects have been discovered so far, with their total number within the Milky Way estimated to be about 150,000. Perhaps one of the varieties of this awe-inspiring natural phenomenon is the bullets, hundreds of astronomical units in diameter, also detected in the Orion Nebula. Moving at incredible speeds, they easily pierce thinner hydrogen clouds, creating far-flung shockwaves in them. According to spectral analysis, the frontal parts of these objects contain atoms of iron that glow in the infrared. The bullets are estimated to be about 1,000 years old, and their origin is still a mystery. They supposedly originated from some catastrophic event. Moving on, we will soon find that the Orion Nebula is part of a much larger cosmic structure called the Orion Cloud. It stretches for hundreds of light years, accounting for virtually the entire constellation of Orion in the Earth's night sky. This is where the well-known Horsehead Nebula is located, remarkable for its bizarre shape. It is a dense dust cloud, about 3.5 light years in diameter, clearly visible against a background of a contrasting scarlet glow. Also close to the Orion Nebula, there is an impressive cosmic structure called the Barnard's Loop. This emission nebula, about 300 light years in size, came into being about 3 million years ago, after a series of consecutive explosions of mutually close supernovae. After the shock-compressed gas jets mixed together, they produced a gigantic curved nebula, and the glow of several young stars, gathered in an open cluster, made it reddish in hue. For all its beauty, The Orion Nebula is a fragile and unstable object by the universe's standards. Stellar winds and pressure of light from many young stars, as well as gas emissions and turbulent vortices, constantly disperse its material in the surrounding space. The nebula has already lost about 60% of its original material, and in about 100,000 years it will be stripped of its remnants. In place of the shining multicolored cloud, there will remain an open star cluster similar to the Pleiades. For a time, the young stars forming it will move together, but eventually each will find its separate way through the vast expanse of the boundless galaxy around. First stop is 202 light-years away from the Earth, destination K2-141, an orange dwarf. Its mass is roughly 0.7 that of the Sun, and its radius measures 68% that of our host star. With these parameters almost perfectly proportional, the star's temperature reaches 4,600 Kelvin, which is about 20% less than that of the Sun. And now to the planet in question. Just 0.007 astronomical units away from its star, there lies a really bizarre world, designation K2-141b. This rocky exoplanet is 5 times as massive as the Earth, with its radius 1.5 times as big as that of our Earth. All this gives us grounds to assume that the gravity on the planet's surface is at least twice as strong as that on our planet. The heavy metallic core, meanwhile, accounts for 20 to 50% of the planet's overall mass. It takes the celestial body about 6.5 hours to complete a full orbit around its parent star. Being extremely close, it is tidally locked to it. That is, it faces the star with one and the same side at all times. Observations show that the temperature on the planet's day side reaches 3,270 Kelvin or 3,000 degrees Celsius. This is enough not only to melt most rocks and metals, but also to effectively evaporate them. The day side of the planet is assumed to be covered with a lava ocean that never ceases to boil. The atmosphere is thought to be rather exotic, made up of steams of heavy metals and silicates. By contrast, the planet's night side is incredibly freezing. According to estimates, the temperature of most of its area is tens of times lower than that on the day side, and on balance, its values are supposed to be sub-zero. Mathematical modeling shows that this sharp temperature contrast gives rise to exceptionally strong winds whose speed reaches 1.75 kilometers per second. This is roughly 5 times the speed of sound, which means that the surface of K2-141b is continuously shaken by exceptionally powerful, deafening rumbling. It is assumed that on reaching the night side, atmospheric streams condense and precipitate on its surface in the form of fiery rain. This forms lava rivers, and eventually this molten metal makes its way back into a magma ocean to evaporate again later on and to continue this incredible fiery circulation. However, this infernal cycle affects only a relatively small part of the planet's night side. The thing is that masses of evaporated elements from the day side simply don't make it to the main part of the night side and precipitate somewhere on the border. That is why the central part of the night side is likely to be a freezing desert bound with layers of solid rocks. Remarkably, K2-141b is far from being the hottest planet that we know of. For example, there is an object referred to as Kelt 9b lying 670 light-years away from the Earth. Its surface is as hot as 4,600 Kelvin, which is approximately 4,330 degrees Celsius. Just to compare, the outer layers of almost all red dwarfs, for example, are much cooler, which means that in terms of temperature, this exoplanet is quite a match to stars. Its parent star, designation Kelt 9, is of a whitish-blue color and has a mass 2.6 times that of the Sun. As for its diameter, it is 2.3 times that of our star. The surface temperature of Kelt 9 is rather high, at approximately 10,170 Kelvin, or a staggering 9,900 degrees Celsius. This largely accounts for the extreme conditions on Kelt 9b, which lies quite close by. Just 0.035 astronomical units away from its parent star, the planet completes a full orbit around its system's center roughly every 1.5 days. Kelt 9b is a hot gas giant. Compared to Jupiter, its mass is 2.8 times as big, and its radius measures roughly twice as much as that of the largest planet in our system. Based on today's notions about the composition of this type of planets, the inner part of Kelt 9b's atmosphere is supposed to be even hotter. Estimates allow for this value to reach as much as 11,000 Kelvin on account of heavy metal ionization. With this figure so exceptionally big, it appears that the planet's atmosphere should contain vaporized iron and titanium, alongside the elements we're used to in an atmosphere's composition, such as hydrogen or helium. Its close proximity to the parent star and the extremely high temperature cause the planet to gradually lose its atmosphere. By and by, powerful stellar wind blows it off into space, which is why the object is shrouded in a cloud of rarefied gas. This material will eventually be attracted and absorbed by the star. Interestingly, according to some estimates, the exoplanet loses up to 68 Earth masses every billion years. Theoretically, in a long while, Kelt 9b may well get stripped of all of its atmosphere and transform itself into a Chthonian planet. However, its parent star is likely to hit the final stage of its life cycle long before that, swallowing up and destroying all the celestial objects within its reach. The space objects we have just looked at are a living proof, as it were, of the fact that stars can destroy the planets close to them and not just warm them up. But incidentally, there are celestial objects out there in the universe that have experienced their parent star's wrath in full measure. One of such objects lies 4,570 light-years away from the Earth in the environs of a small star, designation V391 Pegasi. Now, the star is a white dwarf whose mass is twice as little as that of the Sun and whose radius is approximately 23% that of our parent star. The temperature of this celestial object is unbelievably high, at almost 30,000 Kelvin. All thermonuclear reactions in its interior would have run their course a long while ago. Up ahead are hundreds of billions of years of slow cooling, with the white dwarf eventually transforming into a black one. The planet we will look at, referred to as V391 Pegasi b, is in this ordinary star's environs. Its lot is exceptionally amazing. According to mathematical modeling, the planet not only survived its progenitor star shedding its outer layers, but actually found itself almost within the star for some time. It is assumed that when the system's star V391 Pegasi transformed into a red giant, its outer layers, extremely rarefied by then, were almost brushing the planet's orbit. Their density became dozens of times lower than the atmospheric air we're used to, which means that the celestial objects devoured by the dying star remained whole for a while and didn't get destroyed at once. It goes without saying that they would have been losing their speed and dropped into the star's hotter and denser layers. Still, V391 Pegasi shed its outer layers sooner than V391 Pegasi b melted and ceased to exist as a whole object. At the moment, the exoplanet appears to be a gas giant, 3 times as massive as Jupiter. Its orbit passes 1.7 astronomical units away from its parent star, and it takes the planet approximately 1,170 Earth days to complete a full orbit around its system center. It is still not entirely clear how this astronomical body managed to preserve such a big mass after its collision with the scorching hot layers of the star. Their influence was supposed to have destroyed the object's atmosphere completely. However, there is no doubt that the host star's collapse brought about some dramatic changes, both in terms of the exoplanet's orbit and its parameters. That is why it is hardly possible for us to ever find out what V391 Pegasi b was like before immersing in a sea of raging plasma. Space expanses conceal uncountable astronomical objects with the most bizarre properties. Some of them are almost totally invisible through regular telescopes, but can be detected by looking at radio wavelengths when exploring space. An example of such like celestial objects is pulsars, neutron stars spinning on their axes at a mind-boggling speed. These objects' spectra are peculiar for exceptionally fast and regular pulsations. That is why it is quite easy to detect another celestial body transiting between a radiation source like that and an observer on the Earth. This is precisely the way our next object of interest was discovered. But first we'll be looking at a pulsar which lies around 4,000 light-years away from the Earth. This neutron star boasts quite a long name. Here it is on the screen. And now let's check out its remarkable features. The pulsar's diameter is just a measly 20 kilometers, and its mass is approximately 1.4 that of the Sun. The object spins at an incredible rate, with roughly 10,000 rotations a minute, while continuously emitting powerful electromagnetic radiation impulses. Now the surface of the exoplanet, our next object of interest, is continuously exposed to these waves of lethal radiation, which makes it a hostile and forbidding place. It takes this planet just 2 hours to complete a full orbit around its system's center, and the distance to the pulsar is smaller than the Sun's radius, just 600,000 kilometers or 0.004 astronomical units. Incidentally, the celestial body's surface is bound by eternal cold and space, as its parent star just barely emits thermal energy. The object's mass is around 330 that of the Earth, while its radius is 4 times that of our planet. This makes gravity on its surface as much as 20 times stronger than on the Earth. Estimates show the planet's average density to be about 23 grams per cubic centimeter, which is more than most chemical compounds we know. The planet is thought to be made up for the most part of crystallized carbon under a lot of pressure. Besides, the object's upper layers contain some oxygen, which is probably chemically bound with carbon. It is highly doubtful that a celestial body located so close to a star could possibly have survived a supernova event. It is more realistic to assume that the exoplanet formed after the progenitor star had come to the end of its life cycle and had transformed itself into a pulsar. The exoplanet could be a piece of debris left over from a white dwarf whose material would have dispersed for the most part. This makes classifying the exoplanet an especially difficult task. Still, whatever it is, this world remains one of the most dangerous and hostile ones lurking in the depths of the cosmos. 650 light-years away from the Earth, there lies IRC plus 10-16, a majestic star also known as CW Leonis. Its radius at its pulsation peak may reach 560 times that of the Sun, which is about 2.6 times the distance from the Earth to our parent star. With CW Leonis hypothetically placed in the middle of our system, all the planets as far as Mars would find themselves under its surface, which would even brush the inner boundary of the asteroid belt. Incidentally, the star's mass is not that great, roughly 1.5 to 4 solar masses. Its surface temperature is just 2,300 Kelvin, or about 2,000 degrees Celsius. But due to its impressive dimensions, the star emits on average 8,500 times more energy than our Sun. Like any other red giant, CW Leonis is in its final life stage. Its age hasn't been defined precisely, but it is estimated to be several billion years. It is assumed that in its salad days, CW Leonis was a white-blue star with a mass 3 to 5 times that of the Sun. However, by 1 billion years ago, a great part of the celestial body's hydrogen had burned out and transformed into helium. Slowly settling in the star's center, the helium ousted all the remaining hydrogen and formed a scorching hot core which did not participate in any thermonuclear reactions. This process typical for all stars whose mass is close to that of the Sun, is the starting point for a star's transformation into a red giant. The star's inner pressure causes it to expand to great proportions, which renders the outer layers more rarefied and unstable. The space object's diameter grows to be dozens of times greater, with its color gradually assuming a blood-red hue. A thermonuclear reaction still takes place in the star's depths, which causes the pressure and temperature of the stellar plasma to increase. At a certain point, this unleashes a chain reaction of nuclear fusion, where helium nuclei are transformed into carbon. This is the so-called helium flash. It is a complex, multi-level physical process that dramatically transforms the star's inner structure. With its core incredibly heating up, its outer layers, on the contrary, cool off and darken. There are currently great amounts of carbon in CW Leonis, but its mass is insufficient to hit the next level of nucleosynthesis. As a result, the thermonuclear combustion in the object's interior becomes unstable. The stellar matter gradually cools off and shrinks under the influence of gravitation. This heats up the star's interior again, and the reaction is unleashed with a new force. After receiving a new portion of thermal energy, the stellar matter expands again, and the combustion dies down. It is assumed that this cyclic process underlies the occasional changes of the star's luminosity. CW Leonis has a 649-day pulsation cycle, and with the luminosity at its peak is 11,300 times brighter than the Sun. With the luminosity at its lowest, meanwhile, the object emits 6,250 times more energy than the Sun. At the moment of contraction, the upper layers of stellar matter partly detach themselves from the star. This forms a carbon-oxygen gas nebula that the star is enveloped in. According to some estimates, CW Leonis loses 4 times 10 to the power of 22 tons of material every year on account of this process, and amount approximately 7 times the mass of the Earth. Observations show that the circumstellar nebula is not less than 69,000 years old, and its mass is about 1.5 times that of the Sun. As for its size, it reaches 84,000 astronomical units. The nebula has an elaborate structure with bulges and pockets of gas, as well as half-arcs and irregular rings. It is posited that these formations appeared due to magnetic activity and stellar wind generated by the unstable star close by. The chemical composition of the cloud CW Leonis is shrouded in is of great interest to explorers. Spectral analysis data reveals it to contain around 70 different chemical compounds, for example carbon dioxide, water and ammonia, to name but a few. There are also quite a lot of elements from the upper part of Mendeleev's periodic table, right down to iron. CW Leonis may have had planets in the past, but they appear to have been swallowed up early on at the stage of expansion. In any event, years of observations did not reveal distinct traces of their existence in the past. What was registered was subtle changes in the star's orbit back in 1994, and more recently, in 2017, mysterious shifts of matter were detected in the cloud of gas and dust enveloping the star. Some small red dwarf orbiting the giant could well account for these phenomena, although attempts to detect its radiation have so far been unsuccessful. This could be due to the nebula close by, which disperses and reflects the energy flow from sources of light located nearby. This phenomenon camouflages any objects in the immediate environs and prevents them from being accurately recognized. The mass of CW Leonis' hypothetical stellar companion is assumed to be definitely smaller than that of the Sun, and it should take it approximately 100 years to complete a full orbit around the giant. Another outstanding feature is a comparatively high water content in the star's environs and envelope. At first, it was posited that the star would melt and swallow up icy comets as it expanded. However, observations carried out in 2009 showed the temperature of some spectral lines to reach 1000 Kelvin. which is possible only on condition that water vapor forms actually in the upper layers of the giant. This fact did not fit in the model of red giant's structure accepted at the time, according to which all oxygen in stellar matter necessary for water synthesis must be used up completely to produce carbon monoxide. A new hypothesis was put forward to account for the witnessed phenomena, which stated that molecules of silicon oxides and carbon are destroyed by a powerful ultraviolet radiation. After that, the released oxygen reacts with hydrogen and there forms scorching hot water vapor. The weakness of this hypothesis is in the failure to account for the source of ultraviolet radiation. Reactions like that may occur only in rather high temperatures, that is, within stellar matter. However, it is practically impervious to cosmic rays. This paradox may be explained by yet another assumption. Since the star is unstable, large ruptures and low-density areas occasionally occur on its surface, where ultraviolet radiation is not blocked out that effectively. The water vapor's overall mass in the star's atmosphere and outer layers is estimated at several quintillion tons. Enormous though this figure may seem, in fact, water accounts for just around a billionth of the star's overall mass. According to today's notions of stellar evolution, being a red giant, CW Leonis is in its autumn years now. It will deplete its stellar fuel in the next 10 to 30,000 years, after which it will discard its outer layers following a powerful explosion. It will transform into an incredibly hot and dense space object, a white dwarf. Its mass will be roughly 80% that of the Sun, and its temperature will reach several million degrees in the first seconds after the transformation. However, with no energy source, it is destined to slowly and irrevocably fade in the course of billions of years to follow. Eventually, the celestial body will be almost invisible against a background of cosmic emptiness when it becomes a mysterious black dwarf. But this will not happen anytime soon. The shockwave and the mind-boggling temperature in the epicenter will generate new elements that are not to be found in a star's interior. For example, uranium, gold and lead. They will later become part of new celestial objects. Millions of years later yet, radioactive decay will heat the planet's interiors, melt the ice, and saturate the oceans with microelements, thus creating conditions for the genesis of life. The universe is constantly evolving, and global cataclysms and destruction are an inalienable part of this process. But at the end of every storm, there are fresh rays of light. Temperatures of any star's interiors are incredibly high. It is hardly surprising, as thermonuclear synthesis, that is the main energy source of all stars, can take place only in these extreme conditions. When two atoms of hydrogen merge, they produce an atom of helium and release an electron and several neutrinos. In addition, a great amount of energy is released during the process. Still, the hydrogen-helium synthesis isn't the only process that heats up stars. At higher temperatures, other elements may take part in chemical reactions as well. For example, lithium, carbon or oxygen. In this case, cores of heavier elements are produced, such as sulfur, magnesium or phosphorus. Their charge is higher and they repel each other more robustly. Much more energy is needed to overcome this resistance. When a main sequence star depletes most of its hydrogen supply, it starts to expand and cool off. With time, it ends up as a red giant. It will continue to burn due to thermonuclear reactions of helium transforming into carbon and oxygen. The lighter the star, however, the less time it will continue to burn. Eventually becoming unstable, it sheds its outer layers and goes supernova. This leaves it a white dwarf with no resources to fuel any thermonuclear reactions anymore. With all its energy sources depleted, it is forced to gradually cool off. Interestingly, when the mass of a star is higher than a certain value, heavy thermonuclear synthesis may become the star's main energy source even after all hydrogen has been used up. Such celestial objects are referred to as Wolf-Rayet stars. This class of space objects was discovered back in 1867 by the French astronomers Charles Wolf and Georges Rayet. The scientists' attention was caught by anomalously bright emission lines of heavy elements in these stars' spectra. As for the inner makeup of these unusual celestial objects, it was accounted for much later. Stars of this class are generally heavy. They have quite a meager supply of hydrogen and are in the final stages of their evolution. Wolf-Rayet stars are extremely rare. To date, just a few hundred of them have been discovered in our galaxy. As for their overall count in the Milky Way, it is estimated that there can't be over 2,000 celestial objects of this class. Wolf-Rayet stars are subdivided into three main sequences depending on the prevalent element in the spectrum: nitrogen, carbon and oxygen sequences. Each of them, in its turn, is subdivided into several types. As for the hottest star in the studied universe, it falls into the category of the oxygen spectral sequence ones. The celestial body, which is now known as WR102, was discovered back in 1971. At first, it was mistaken for the optical counterpart of the X-ray source GX3+1. However, further observations revealed that there were two completely different objects. According to data acquired thanks to spectral analysis, the discovered star had unusually bright oxygen lines in its radiation spectrum. Thus, in 1982, WR102 and four more bright stars became the first to form a new class. Spectral analysis showed that the star's surface temperature reaches over 210,000 Kelvin. This makes WR102 approximately 36 times as hot as our Sun. The luminosity of this scorching hot object is unbelievable. It is estimated at over 380,000 times that of the Sun. WR102 lies about 10,000 light-years away. The star is located in the part of the sky with the constellation Sagittarius. Incidentally, in spite of its exceptionally high luminosity, it can't be seen with the naked eye, as it is too far away from us. WR102 currently belongs to the extremely rare star class WO2. Containing great amounts of oxygen and almost no hydrogen, it mainly relies on the merging of heavy cores of such elements as neon, carbon and oxygen as its sources of energy. To date, only 9 objects of this class have been discovered, with 4 of them located in the Milky Way and the other 5 in other galaxies. There are 2 factors that make oxygen spectral sequence stars rare. Firstly, there are very few of Wolf-Rayet stars around because only stars with a mass not less than 40 solar masses are potential candidates to become ones. Secondly, this class represents the final stage of evolution of stars of this type. The stage may last anything from 1,000 to 10,000 years, which is mere seconds in astronomical terms. Being of comparatively modest dimensions, WR102 is notably quite a dense star. With its radius measuring just 58% that of the Sun, its mass, on the other hand, is estimated at 15 to 18 solar masses. On its birth, it is thought to have been as heavy as 40 to 60 solar masses. Still, the high temperature and robust chemical reactions in the star's interior cause an exceptionally powerful stellar wind, whose particles' velocity is over 5,000 kilometers per second. It takes WR102 just a few months to lose 1 Earth mass worth of material on account of its stellar wind. At this rate of particle emission, the star is going to lose 1 Sun mass worth of material in the course of 10,000 years. There are no planets orbiting WR102, but it is shrouded in a gas envelope. not dense and exposed to powerful ultraviolet radiation and strong stellar wind, the envelope gets contracted and ionized, which sustains its elaborate structure of protuberances and arches all around the star. According to a proposed theory, the gas cloud around WR102 may probably be remnants of the former hydrogen outer layer of the star. Another theory maintains that the cloud came to be as a result of the particle flow emitted by the star. WR102 is not the only outstandingly blistering place in the universe. For example, WR142, WR30A and WR93b, as well as the central star in the Bug Nebula NGC 6302, are as hot as around 200,000 Kelvin. Some white dwarfs may have almost the same surface temperature. However, all these are no match to neutron stars. When neutron stars are born, their temperatures may reach a staggering 100 billion Kelvin. Active neutrino emissions cool them off comparatively rapidly. But either way, the surface temperature of any neutron star is never less than a few 100,000 Kelvin. As for their cores, they must, admittedly, be hotter still. Having said that, it is highly improbable that the ultimate temperature record is ever going to be beaten. According to today's cosmological concepts, the temperature of the universe at the moment of the hypothetical Big Bang was approximately 1.4 times 10 to the power of 32 Kelvin. A fundamental physical constant, this value is referred to as the Planck temperature. Contemporary physics is not capable of defining a substance of a higher temperature, as physical laws are distorted beyond any recognition in such incredibly harsh conditions, quite beyond our imagination. Getting back to WR102, judging by the data we have on stellar evolution today, this star is in its autumn years now. As opposed to main sequence stars, Wolf-Rayet stars do not expand in their final stages of life. Their substantial mass holds all the star's material together in a dense and hot ball. However, after losing a lot of its mass through stellar wind, the object will eventually get destabilized. If current estimates are accurate, WR102 appears to be ready to go supernova at any point in the next 1,500 years. Bearing in mind that the distance between the star and the Earth is 10,000 light-years, it is highly likely that the event has already taken place. A supernova would have been accompanied by an extra-powerful gamma-ray flare. Fortunately, our planet is too far away to suffer any pernicious effects of this dangerous emission. WR102 is comprised of rather heavy chemical elements and even iron. Its later evolution will force it to contract to a critical point. The great explosion bringing the star's life cycle to a close will unleash processes of robust proton and neutron capture. This way, still heavier elements form, including transuranium ones. Eventually, WR102 will be replaced by a neutron star, a celestial body unbelievably hot and dense. The former star's outer layers, disrupted by the explosion, will form a nebula. Slowly cooling off, it will give off heat to the space around it. Many billions of years later, this material will be able to form a new planetary system. Until a short time ago, it was UY Scuti that used to be considered the largest star known to mankind for a long while. Located 9,500 light-years away from the Sun, the star is so staggeringly enormous that it would cover areas beyond Jupiter's orbit, were it placed in the center of the solar system. Its radius may reach 1,900 those of the Sun, and its volume may be over 5 billion times that of the Sun. However, recently a new giant has claimed the title of the largest star in the known universe. It is known as Stephenson 2-18, or RSGC 2-18. The star lies approximately 20,000 light-years away from the Sun and is part of the open cluster Stephenson 2, although according to some scientists, this space object should not be associated with the Stephenson cluster, as it wouldn't be accurate. Either way, Stephenson 2-18 is located in the Scutum constellation and continues to bear its original name. The star itself was catalogued in the All-Sky database back in the 1990s, but giant clouds of cosmic dust largely interfered with observation of the star clusters in the Scutum constellation, obscuring them from any observer anxious to find out more. Only in 2020 were scientists able to acquire data about its size, and the information proved to be astonishing. According to some estimates, the radius of Stephenson 2-18 may reach up to 1.5 billion kilometers, which is 10 times the distance from our Earth to the Sun, or 2,150 times the radius of the Sun. This means that the supergiant's volume should be about 10 billion times that of the Sun. Placed in the center of the solar system, Stephenson 2-18 would easily swallow up Saturn, along with all of its rings and moons, to say nothing of the terrestrial planets. Interestingly, it would take light almost 8.5 hours to travel the length of this gigantic star's equator. This is the same time it takes sunlight to reach Pluto at the remotest point of its orbit. The supergiant's luminosity is estimated to reach 440,000 times that of the Sun, although its surface temperature is comparatively low at about 3,200 Kelvin. This is about 2 times as little as that of the Sun, and corresponds to the red band of the light spectrum. This is the reason why Stephenson 2-18 falls into the category of red supergiants. Also, this relatively low temperature implies that most of the star's radiation is in the visible and thermal spectra, with amounts of deathly ultraviolet and X-ray types of radiation rather negligible in comparison. It may seem strange that in spite of its impressive dimensions and sufficient luminosity, Stephenson 2-18 cannot be seen from the Earth with the naked eye. But this has to do with its low surface temperature, as well as clouds of stardust and gas shrouding the giant star, thus concealing it from observers on our Earth. They absorb and disperse the star's light, and this poses difficulties for studying the object. The mass of Stephenson 2-18 still remains to be gauged. However, supposing its inner makeup is similar to that of UY Scuti and other supergiants, it should be anything within 20 solar masses. If it is the case, the average density of supergiants like that must be extremely low and almost equal to the density of the Earth's atmosphere at a height of about 90 kilometers above the sea level. That is practically on the border with space. It is really amazing that thermonuclear energy, that is the kind of energy that gives a glow to a star, is still sustained in such conditions. Supergiant sizes are so mind-boggling that these objects are hardly steady. Most of them are variable in terms of their luminosity, and as a rule this variability is unpredictable. No wonder, as the overwhelming majority of supergiants are in the final stages of their life cycles, which means that they may go supernova literally at any moment. According to the contemporary scientific concepts of stellar evolution, it is stars with original masses from 10 to 40 that of the Sun that qualify to become red supergiants at a later stage of their existence. Thermonuclear reactions in their interior rapidly burn out all hydrogen, thus turning it into helium. After that, fusion reactions of helium, carbon, oxygen and lithium become the chief energy source of the star. Life expectancy of stars of this kind is comparatively short, just a few million years. As it evolves, the prospective supergiant rapidly expands in size and loses its mass on account of strong solar wind. Clouds of stardust and gas surrounding the original star are quickly absorbed by the new star, which keeps swelling way beyond its original size at an astonishing rate. However, its own solar wind creates a new nebula around the star. On account of the short lifespan of this kind of star, no planets can realistically originate in this nebula. Eventually, the supergiant explodes. Following the supernova or even hypernova event, the outer layers of the star are hurled away and then gradually cool off, forming a nebula. As for the former core, it becomes either a neutron star or a black hole depending on its mass. By the way, feel free to see our previous videos about dwarf stars and supernovae. A hypernova event is accompanied by a high-energy X-ray burst, powerful enough to eliminate any life within the radius of several light-years. Luckily for us and the Earth, all supergiants identified by scientists so far lie considerably further than that, so we seem to be safe from those. Due to active radiation of charged particles, the rotation of stars of this type gradually slows down, and eventually their outer layers practically grind to a halt. The core of the star, meanwhile, continues to rotate quite unabated, and there may be a substantial difference between the speed of the core and that of the outer layer. Taking into consideration the high luminosity, low temperature and impressive dimensions, on balance, it is safe to assume that the habitable zone of Stephenson 2-18 should be really huge. Its middle should lie approximately 663 astronomical units away from the star's center. In other words, 20 times the distance from the center of the Sun to Pluto's orbit. And as for the area of the habitable zone, it is expected to be 1 billion times that of the Sun. Scientists do admit of the possibility of the existence of planetary systems around supergiants. But what with these stars' short lifespan and unstable conditions, the chances are almost negligible. At any rate, no confirmed exoplanets have so far been discovered in the environs of one. Stephenson 2-18 lies so far away that its light travels to our Earth for 20,000 years. For all we know, at this very moment, its core might be shrinking to form an extremely dense neutron star, with red-hot shards of outer layers flying away in all directions to become part of ice-cold space. But mankind will be able to find this out only in a very distant future. Long before telescopes had been invented, people could observe a light strip crossing the heavens. The fascinating and mysterious phenomenon prompted a multitude of legends, but it took thousands of years of scientific progress to finally account for it. It turned out that the Milky Way wasn't a path of gods. What it is the dissipated light of billions of stars too remote to distinguish each one separately. The idea of the stars around us making up part of a single structure of enormous dimensions was first suggested by Immanuel Kant back in 1755. He also assumed that some nebulae discovered by scientists could in fact be remote star clusters, that is, other galaxies. This ingenious guess was well ahead of its time, with the philosopher's contemporaries initially dismissing it. Only in the early 20th century did the progress of observation equipment enable scientists to confirm the existence of other galaxies, and in 1936, Edwin Hubble devised a classification system. Many of its principles are still referred to by scientists today. According to the system, the Milky Way falls into the category of barred spiral galaxies, although it took a long while before it had assumed its today's looks. Our galaxy is quite an old one, since the stars in its central globular clusters were born as far back as around 13 billion years ago. At the same time, there are some areas in the Milky Way where stars are actively born, which means that there is always a fresh supply of young stars. The collected data points to the fact that the Milky Way is a comparatively large galaxy in astronomical terms. The diameter of its disk measures as much as 200,000 light-years, with a halo reaching out into space much deeper yet. Our galaxy is home to at least 200 billion various stars, as well as 25 to 100 billion brown dwarfs. In addition, it contains over 1 trillion planets, countless small celestial objects, as well as clouds of cosmic dust and interstellar gas, which may reach gigantic dimensions. At the same time, regular matter accounts for a small ratio in the galaxy. Around 90% of the Milky Way's overall mass is the so-called dark matter. The amount of light emitted by this mysterious and widespread substance is negligible. However, dark matter plays an active role in gravitational interaction. Even though most of the galactic mass remains invisible, we can still calculate it. To that end, scientists refer to stars' trajectories of movement around the center of the Milky Way. According to the estimates, the overall mass of our galaxy reaches 0.8 to 1.5 trillion solar masses. The structure of the Milky Way is quite elaborate. We'll start our journey today from its center. This area of the galaxy is shrouded in massive clouds of gas and dust, but by happy chance we can observe it through the so-called Bardes window, an area of space with lower amounts of dust. Just like most spiral galaxies, the Milky Way has a supermassive black hole in its center, which is surrounded with an accretion disk with a radius roughly 3 light-years. Dubbed Sagittarius A star, it is the closest object of this class to us. Its mass is 4.3 million solar masses, and its radius isn't over 16 million kilometers, which is 3 times smaller than Mercury's orbit. The first data about the nature of the object in the center of our galaxy was acquired in the course of long observations and thorough calculations. Only as recently as on May 12, 2022, was it possible to get a first image with the help of the EHD network of radio telescopes, and so the earlier hypotheses were confirmed. The area in the center of our galaxy is highly populated. More than 6,000 stars have already been detected within 3 light-years from the black hole, with the orbits of some of them defined rather accurately. For example, there is a white-blue star, designation S62, which is 17.8 astronomical units away from the black hole on its closest approach to it, while moving at 6.7% of the speed of light. Classical mechanics laws are inadequate for description of the trajectory of movement of a star as swift as that because of relativistic effects. Just to illustrate, the axis of its orbit shifts by 75 angular minutes with every completed orbit. Besides, when crossing this area in space, we can see several large star clusters with a total mass of around 1 million solar masses. And slightly further, roughly 200 light-years away, another massive black hole is likely to be lurking, whose mass should be around 100,000 times that of the Sun. Traveling further on, we will reach the central molecular cloud, an irregularly shaped area measuring 1600 to 1900 light-years, whose mass is over 60 million solar masses. There are a great many stellar nurseries and gas nebulae, as well as protostars and remnants of supernovae. Most of the cloud's matter is dense hydrogen, whose temperature fluctuates between 50 and 600 Kelvin, which corresponds to 223 degrees Celsius below zero to 327 degrees Celsius above zero. Spectral analysis shows a gigantic nebula to contain carbon monoxide, methyl alcohol, and hydrocyanic acid in addition to hydrogen. Having receded from the Milky Way's center a bit, we will see that it is encompassed by a bulge, a bright and massive formation of an elliptical shape. With its length reaching 10,000 light-years, its transverse diameter is roughly 7 light-years. The total mass of the bulge is as much as 10 billion times that of the Sun. The exact number of the stars cannot be calculated because their radiation blends and renders any estimates unrealistic. Being elongated, the bulge forms a so-called bar stretching for approximately 13,000 light-years and serving as the base for spiral galactic arms. It is here, at one of its ends, that we can see the star cluster Stephenson 2, containing the largest known star today. Its designation is Stephenson 2-18, and its radius is 2,150 times that of the Sun. Unfortunately, chances of finding exoplanets orbiting this outstanding object are quite minuscule. Even if planets did exist at some point in the past, the hypergiant would have swallowed them up while it was expanding. The galaxy's center is home to billions of stars and apparently a great number of exoplanets. Chances of encountering a potentially habitable world among this great multitude are much lower than in less populated areas of the galaxy. This is due to the fact that when a big number of stars are located close together, they destabilize exoplanets' orbits, while their powerful radiation is lethal to all living things. That is why a special area in the galaxy is defined as the habitable zone. It looks like a ring, with a radius measuring 22 to 29,000 light-years, and contains star systems with the most favorable conditions for the genesis of biological life. Worlds encompassed by the ring languish in exposure to excessive radiation, while beyond the ring there's a lack of heavy elements. However, mathematical modeling shows that stars within galaxies are able to migrate thousands of light-years away, thus either leaving the habitable zone or entering it. Consequently, with an exoplanet lying within the zone, it does not automatically suggest favorable conditions on it. Moving on away from the center of the Milky Way, we will have a chance to check out its most impressive part, the galactic disk. It is made up of two components with different properties. The first one, known as the thin disk, measures 1,000 to 1,300 light-years in thickness, and its visible radius measures as much as 50,000 light-years. On the edge, it gradually dissipates, with the outermost stars lying up to 100,000 light-years away from the galaxy's center. This part of the Milky Way contains around 80% of the galaxy's visible mass, and in fact, it was the last component to have formed. As for the thick disk, its diameter is comparable to that of the thin disk, but it's 4 times as thick and is much more rarefied. It is made up of old stars and is practically devoid of interstellar gas. Observations of some stars in the Milky Way, as well as mathematical modeling, show our galaxy to have swallowed up another one in the period from 11 to 8 billion years ago. This hypothetical cosmic structure was dubbed Gaia Enceladus. It is thought that it contributed several billion stars to the Milky Way, as well as great amounts of interstellar gas and dark matter. It is thanks to this tremendous event that most of our galaxy's thick disk formed, and an additional supply of gas led to a stellar baby boom. There is no doubt that spiral arms are the most noticeable structural elements of our galaxy's disk. Usually 2 major ones are singled out, the Scutum Centaurus arm and the Perseus arm, and 2 minor ones, the Norma arm and the Carina Sagittarius arm. Sometimes a 5th large arm is taken into account, named after the Cygnus constellation. Galactic arms are areas of especially high star count. Most of interstellar gas is also concentrated here, which is why the rate of star formation in the arms is 3 to 5 times higher than the galaxy on average. They spend the first millions of their lives in open clusters, but gravity forces are too weak to hold the stars close together for a long time. This destabilizes the clusters, and young stars gradually drift away from each other. Traveling along the Carina Sagittarius arm, we will reach a fork that links it to the Perseus arm. The length of this stellar structure reaches 11,000 light-years, and its width measures roughly 3,500 light-years. It is referred to as the Orion arm, and it is here, 27,000 light-years away from the galaxy's center, that the solar system is located. From our planet's perspective, the galaxy's center is seen as a dark abyss. This is the Great Rift, an area of space that shuts out the greater part of the Milky Way from our gaze. It is filled with massive clouds of interstellar gas and dust, and its total mass is as much as 1,000,000 times that of the Sun. Even though the Great Rift is practically not transparent in the optical range, its matter actively emits radio waves and thermal energy. Spectral analysis data reveals that clouds are mostly made up of hydrogen, with a small percentage of more complex compounds, ammonia, alcohols, and amino acids. The Great Rift is thought to be a potential stellar nursery, but it is going to take a while until the first stars light up in that area. While it is still not quite active, let's move on, beyond the galaxy disk. Even though its bright and clearly defined arms attract a lot of attention, there is more to the Milky Way than that. If we look closer, we will see the vastest and the most rarefied of its components, the halo. Its visible part, spherical in shape, stretches for up to 260,000 light-years away from the galaxy's center, but accounts for just a few percent of the total mass. The halo contains a great number of globular clusters made up of remarkably old stars over 12 billion years of age, and several tremendous stellar streams. The Sagittarius stream, for example, made up of several thousand stars, encompasses our galaxy in an elongated ellipsis, which is almost perpendicular to the main plane. Modeling shows that all these stars are highly likely to have been gravitationally captured by the Milky Way from a dwarf satellite galaxy. Designation Sagittarius DEG. It lies 500,000 light-years away from the Milky Way's center, and is going to be swallowed up by it completely within several billion years. Another dwarf galaxy has already met a similar fate. Lying in the Canis Major constellation, it was almost destroyed by the Milky Way, which pulled out millions of its stars by gravity forces. Stretching for 200,000 light-years and mixing with other stars, this string of stars with a total mass of roughly 100 million solar masses has already wrapped around our galaxy 3 times. Apart from bright but rare stars and clusters, the halo contains great amounts of gas, whose temperature reaches millions of Kelvin. Also, great amounts of dark matter are thought to be scattered in the vicinity of the Milky Way, forming the so-called dark halo. Stretching for up to 2 million light-years, it hardly emits any electromagnetic radiation, and can be detected only by gravitational interaction. The dark halo remains an unsolved mystery, yet it greatly contributes to the global stability of our galaxy. Distances from the Milky Way to other galaxies are by all accounts mind-boggling. As a rule, it is anything from millions to billions of light-years. Due to the universe's cosmological expansion, the distance between the Earth and any remote object in the universe is constantly growing, which makes the light emanating from this object look redder than it actually is. This phenomenon is known as a redshift. It is of great help in gauging distances and velocities on the astronomical scale. Alternatively, some galaxies' spectrum is blue-shifted, which means that they're not on an escape trajectory from us, but on the contrary are moving to meet us. One of these unusual space objects is the galaxy M86 in the Virgo cluster. Roughly 52 million light-years away from the Sun, it is moving towards the Milky Way at a speed of around 244 kilometers per second, which makes it one of the fastest moving blue-shifted galaxies. By moving at high speed through the scattered gas the Virgo cluster is filled with, M86 is constantly shedding its own interstellar matter. As a result of this process, it leaves a trail of long lines of warm ionized hydrogen behind, M86 is connected with the almost destroyed spiral galaxy NGC 4438 with several of these filaments. These two galaxies are thought to have collided at some point in the distant past, which was the smaller one's undoing. Interestingly, M86 is known to have destroyed its other neighbors in the past as well. Several stellar streams have been detected in its halo that are likely to be the remains of smaller galaxies absorbed earlier. An impressive number of globular clusters in its structure is another outstanding feature of M86. Observations show that their number is upwards of 3,800, which is around 25 times as many as in the Milky Way. There is a theory that claims these clusters to be the remains of dwarf galaxies that M86 would have absorbed in the past. If it really is the case, then it would have destroyed tens or even hundreds of other galaxies. Having said that, M86 looks anything but unique. The galaxy ESO 137-001, which we'll be looking at next, has a similar shape. But unlike M86, it appears more outlandishly original. Located 227 million light-years away from the Sun, it is as heavy as 5 to 14 billion solar masses. As for its stars, most of them are young and bright blue giants. ESO 137-001, in its turn, is part of Abell 3627, a large galaxy cluster. Moving to its center at an incredible speed of almost 2,000 kilometers per second, the galaxy collides with interstellar gas pressure inside the cluster. As a result, its own gas is blown out, leaving behind tails that stretch for up to 260,000 light-years. Incidentally, the mass of interstellar gas in those areas is 2 to 4 times that of the gas inside the galaxy. It is hardly surprising that starbursts are a common thing here. That is, stars don't stop forming in these enormous streams made up mostly of hydrogen. When seen from the side, ESO 137-001 appears like a giant jellyfish floating through endless expanses of space. Unfortunately, as the galaxy is continuously stripped of its interstellar gas, its life expectancy diminishes too. With not much material left, no new stars can form here, which greatly affects the structure of the spiral arms and central bulge of the galaxy. On the bright side, scientists have a chance of finding out more about dark matter and its interaction with other space objects by observing the behavior of the gas streams left in the galaxy's wake. Speaking about the formation of new stars, there is a galaxy with a name that speaks for itself: Baby Boom. Around 4,000 stars are born here every year, which is about 400 times more than in the Milky Way. Straightforward calculations show that on average, a new star lights up in this area of space every 2 hours. The Baby Boom galaxy lies around 12.2 billion light-years away from the Earth. This means that what we see when observing it is what was happening just 1.5 billion years after the hypothetical Big Bang. It was a time when the universe was still in the process of forming its structure. What is taking place in the galaxy now is drastically different from what we expect to observe there in theory, based on what we know about star formation. The reasons why stars are produced here at such an astounding rate are not known yet, but it is beyond any doubt that Baby Boom is able to provide us with a lot of information about the early stages of our universe's evolution. One of the few galaxies one can observe through an amateur telescope is the so-called Sombrero Galaxy, official designation M104. It lies 30 million light-years away from the Sun, and its diameter is roughly 4 times smaller than that of the Milky Way. The Sombrero Galaxy's outstanding feature is a massive ring of dust and cold hydrogen enveloping it. Observations show that it is here that most young stars are born. In addition to the peculiar ring, the Sombrero Galaxy is also remarkable for its elaborate inner makeup. Observations with a Spitzer Space Telescope show that most stars in this galaxy form a structure typical of elliptical galaxies. The stars here are mostly rather old yellow and red dwarfs. The other stars here, on the other hand, form spiral structures concealed within an elliptical cloud. It is thought that this phenomenon is a result of two galaxies' collision, with their stars subsequently and almost inevitably mingling together. It is incredible that the galactic structures survived a merge of that scale with minimal damage, are none the worse for this tremendous collision and can still be observed. Another peculiar feature in the Sombrero Galaxy is exceptionally powerful X-ray radiation emanating from the center. It is assumed that the accretion disk of a supermassive black hole may be its source. The mass of the hole is estimated to be over 1 billion solar masses, which makes this enormous object one of the most massive black holes known to science today. There are also several sources of tremendously high frequency or terahertz radiation detected within the galaxy, although today their nature is still a mystery. Our galactic parade today is concluded with yet another object boasting an elaborate inner structure, the eerie M64 galaxy, rather aptly dubbed the Black Eye Galaxy. The nickname comes from a dark band of cosmic dust that partly conceals the galaxy's center from the observer on the Earth. Due to this line of cosmic dust, as well as the exceptionally bright active nucleus, it is impossible to estimate the Black Eye's number of stars even roughly. What we do know is that it is comparatively small and not so remote. Its radius measures 25,000 light-years, and it lies approximately 17 million light-years away from the Milky Way. The Black Eye Galaxy is made up of two well-defined parts. Interestingly, the inner disk with a bulge rotates in a direction opposite to that of the outer ring. The most likely explanation for such a bizarre makeup is that the galaxy formed after two smaller ones collided and merged in the distant past. Admittedly, it would take a combination of a number of mutually independent factors for such a fascinating and well-defined structure to form. For example, the progenitor galaxies would have moved at specific velocities and come together at a certain angle. The odds of a success would have been minuscule. The solar system is just one of the countless multitude of planetary systems scattered across our galaxy. As we know, it consists of a single star in its main sequence stage and 8 planets with their satellites. In addition, our system contains over 1 million small celestial bodies like asteroids, comets, and meteoroids. The planet in the solar system lying furthest, at least that we know of, is Neptune. Its orbit's radius measures around 30 astronomical units, which is equivalent to approximately 4 light hours. Amazingly, only a tiny portion of the solar system is encompassed by Neptune's orbit. The remotest object in the system discovered to date is the so-called Far Far Out, lying 132 astronomical units, or 18 light hours away from the Sun. Still, even this object, barely visible against a dark background of unfathomable space, is not at all close to the hypothetical Oort cloud, whose inner boundaries lie approximately 2,000 astronomical units away from the center of our system. According to some estimates, its outer boundaries stretch for up to 60,000 astronomical units at the very least, which is around 1 light year. These limits are predefined by the Sun's gravitational influence, and what lies beyond is interstellar space. Moving further away, we will notice over 50 of all kinds of stars within 20 light-years from the Sun. These stars are really diverse, from dim and cold brown dwarfs to bright and widely known objects like Sirius, Procyon, and Altair. Some of them have their own planetary systems, with objects potentially capable of nursing and sustaining life. For example, the object known as Gliese 832c, which is 16.1 light-years away from the Sun, is similar to our Earth more than any other planet within the solar system that we know of. The average temperature on the exoplanet's surface reaches 253 Kelvin, or 20 degrees Celsius below zero, and it takes the astronomical body just 36 Earth days to complete a full orbit around its parent star. In astronomical standards, the distance between us and Gliese 832c is relatively small. However, a space probe setting out from our system at a speed of roughly 17 kilometers per second would take as much as 300,000 years to reach the exoplanet's environs. At our current level of technological advancement, it is impossible to design an interstellar spaceship capable of completing as long a journey as that. The solar system, together with its neighbor stars, is part of the Orion arm. The latter, in its turn, is part of the Milky Way. It contains around 400 billion stars, and potentially over 1 trillion exoplanets of all sorts can be discovered there, according to estimates today. The main diameter of the Milky Way measures around 100,000 light years, and the stellar halo may be twice as large. Even though the thickness of the main disk measures about 1,000 light years, there is a clearly defined bulge in the galaxy's center. This bulge is roughly 3,000 light years thick. The Milky Way is part of the so-called local group. This is a vast structure comprising over 50 galaxies concentrated within an area of space measuring around 10 million light years in diameter. The Andromeda Galaxy, the Triangulum Galaxy, and the Milky Way are the largest of the lot. Some estimates show that the mass total of the cluster may reach as much as 3 trillion solar masses, with our galaxy and Andromeda accounting for the major part. With a distance from the Earth to Andromeda around 2.5 million light years, it is considered to be our closest galaxy, not counting smaller or dwarf ones. Moving on to the next order, the local group forms part of the giant Virgo supercluster, made up of over 30,000 galaxies. The supercluster is located within an area of space with a diameter of around 150 million light years. Its mass total is as much as a quadrillion solar masses, or in other words, around 1,000 galaxies like the Milky Way. The supercluster is quite flattened, and around 60% of all the objects it is made up of appear like a flat sheet around 10 million light years thick. Staggering though it may appear on the face of it, this value is actually small in terms of the large-scale structure of the universe. As we zoom out still more, we have a chance of seeing a giant supercluster of galaxies approximately 520 million light years in size. Called Laniakea, it includes several galaxy superclusters, among others the Virgo supercluster and the Great Attractor. The overall mass of this formation measures approximately as much as 100 quadrillion solar masses. The Great Attractor lies roughly 250 million light years away from our planet and is the gravitational center for all objects lying close by astronomical standards. It cannot be observed from the Earth directly, as the Milky Way is playing thwarts it. That is why the nature of the Great Attractor still remains an unsolved mystery today. Laniakea is part of the large-scale structure of the universe, an elaborate system of galactic filaments, walls and voids, gargantuan areas of emptiness in space. Some of these objects are really incredibly enormous. For example, the Hercules Corona Borealis Great Wall stretches for around a staggering 10 billion light years. Ever since its discovery in 2013, this superstructure has been considered the most gigantic component of the large-scale structure of the universe. To all appearances, it must be home to millions of galaxies, and the number of stars it contains will probably always defy calculation. The mere existence of a structure like that is a mystery to science, as according to today's accepted theory of the universe's evolution, gargantuan clusters like that are simply not supposed to form. But incidentally, this wall, so enormous that the human brain cannot fully appreciate its dimensions, is still just a tiny portion of the observable universe. According to today's cosmological notions, space in the universe is continually expanding, with the speed of expansion depending on the distance between objects. The further an observed object lies away from the observer, the faster the distance between the two increases. The rate at which the two mutually recede is not limited by the speed of light, because it's actually space matter that's expanding, which means that at a certain point the two objects will be mutually unobservable. Relic radiation observation shows that the area of the observable universe is a sphere, with a diameter roughly 93 billion light years. According to the theory of relativity, we can see and interact with only those objects that are within this sphere. This conventional spherical area in space is called the meta-galaxy, and it may be either all of the universe, or again its tiny portion. For all we know, hypothetically, there may well lie some unknown structures beyond the visible boundaries of space. Such entities are referred to as extramegagalactic objects, and unfortunately it is impossible to study them today with scientific methods. Still, some astronomical bodies on the edge of the visible universe appear to be moving in ways different from what we would naturally expect, judging by the data we have. Instances of anomalous movements like those may be evidence of the presence of some massive structures beyond the metagalaxy boundaries. Their attraction pervades the space around and influences objects around too. There is a whole plethora of hypotheses as to the structure of the universe beyond the metagalaxy, but most of them are rather of metaphysical nature. For example, some people believe that time and space as we more or less know them are non-existent beyond boundaries of the universe. The physical laws we're used to do not apply there either, and notions of matter, material, or energy are virtually senseless. This hypothesis is further elaborated on by the following idea. The metagalaxy accounts for just a part of a yet more complex and larger scale superstructure in space whose makeup and dimensions are too incredible for us to imagine. It is quite possible that this structure could be in a multidimensional space, or else be based on physical principles we have no idea of. This makes the metagalaxy just an insignificant addition to, or a partial reflection of, this mind-boggling superstructure. According to some interpretations of the anthropic principle, there are other worlds out there beyond the boundaries of the observable universe. In those worlds, the values of the fundamental constants like the speed of light or the electron charge are completely different. This hypothesis is in many ways supported by the idea of a multiverse, which schematically appears as foam with lots of bubbles separated from each other by thin walls, but these walls are impenetrable. This makes every universe a separate space, with its own physical laws, and for all we know, these laws may be totally different from the ones we're used to. The most radical hypotheses go as far as to deny our world any objective reality whatsoever. According to these, the universe is just a simulation like virtual reality in computers, but on an incredibly advanced level. As a rule, ideas like that imply that there are some super beings, or super civilizations out there beyond the reality we're used to, whose level of advancement is infinitely higher than ours, and whose goals and capabilities are arcane and incomprehensible. However, it goes without saying that it is hardly possible to either confirm or repudiate these hypotheses. Of course, distances in space defy our imagination and are even frightening. They appear infinite from the point of view of any person today. What we do know is that the universe is expanding, and provided this process continues, there will come a point where space objects will disappear one after another beyond the event horizon. First galaxies, then stars, and the world will immerse in eternal darkness. But by then, there will be no one around to witness that. The famous American writer Ursula Le Guin expresses her own thoughts through a character in her book in these lines. The word must be heard in silence. There must be darkness to see the stars. The phrase has to do with the birth and death of all that exists. Every object in the universe has its beginning and its end. Some subatomic particles last as little as tenths of a second. Some microorganisms live between 2 hours and several days. Man's life expectancy counts several decades. But even stars eventually burn out after millions and billions of years of existence. And what about the universe itself? Is it also going to come to an end at some point? What will it be like? And what will happen after its death? The earliest theory of the genesis of our world is what is known as theory of the stationary universe, or steady-state universe. Supporters of this theory claim that the universe has no beginning and no end. It has always been and always will be in its steady state of equilibrium. However, very soon scientific estimations prove this theory likely to be wrong, as there are some irreversible processes taking place in the universe. In the 1910s and 1920s, the Big Bang theory was formulated and widely popularized. Today, it is one of the most consistent scientific theories, and it is able to account for the universe's genesis and evolution. Dozens of scientists contributed to the development of the Big Bang theory, and Albert Einstein's works on the general theory of relativity laid the theory's foundation. The main conclusion this theory enabled scientists to arrive at is the supposition that the fate of the universe depends on dark energy, a theoretical type of energy causing space to expand. Be it as it may, at this point it is quite impossible to say anything definite about this physical phenomenon. There are a great number of theories about this, and each of them has its praiseworthy aspects and shortcomings. According to data we possess today, the age of the universe is calculated from the moment of the Big Bang, and is estimated at slightly less than 14 billion years. The universe is constantly expanding, and depending on the density of dark energy, it will either expand forever at a regularly increasing rate, or else the expansion will slow down and reverse. In this case, the universe is bound to compress into an infinitely small singularity, similar to what it originated from. Today, science is not ready to give a definite answer to the question which of these two possibilities will prevail. However, it is ready to suggest at least two equally possible scenarios of what may happen next, referred to as the Big Rip and the Big Crunch. The universe's expansion rate is proportional to distances between objects. The further some objects are located from each other, the higher the expansion rate. Imagine a balloon pumped with air. There are two dots on it. If we pump still more air into the balloon, the dots will get further away from each other. That's the way the expansion of the universe works. It is space itself that expands. The further the dots are initially located, the faster they get still further apart. At a certain point, this rate exceeds the speed of light. This point is known as the event horizon. All objects beyond it disappear from view, and they drift away beyond the reach of the most advanced telescopes, never to be observed again. Just imagine. First, the remotest galaxies and clusters will disappear from the sky. Then, one by one, the Milky Way stars will fade away, and to crown it all, it will be the turn for our sun to go dim. What a gloomy sight. If the Big Rip theory holds good, the universe's expansion rate will be constantly on the increase. This will lead to expansion forces gradually overcoming gravity forces. Following that, first galaxy clusters and then galaxies themselves and star clusters will be broken up. After that, it will be the turn for stellar systems to disintegrate, as host stars will not have sufficient pull to keep their planets and satellites from floating away. At the next stage, matter will be reduced to atoms, and these will be reduced to subatomic particles. Matter will effectively cease to exist. After this, physical laws as we know them will cease to be, and any further developments are quite impossible to predict. Observations today show that space expands, and the expansion rate is on the increase. However, we're not familiar with the nature of dark energy. It may well have properties unknown to us at this point, and these may reverse the expansion processes. As a result, the universe will start contracting. This may well happen if general gravitation created by all matter in the universe exceeds its expansion force. This scenario is what is known as the Big Crunch. In this case, processes in the universe will run in the same manner until its size decreases 5 times. Galaxy clusters will come together as one supercluster, which in essence will fill the entire universe, considerably shrunk by this point. Meanwhile, inside the galaxies, events like births and deaths of stars, planet formation and so on will keep taking place just like before. When the universe contracts 20 times more, its volume will account for just 1% of that of today's, and all galaxies will blend into one. The relic radiation temperature by that time will measure 274 degrees Kelvin, and it will still continue to grow. This means that there won't be any liquid water left in the universe, and water is vital for biological life as we know it. Further contraction of space will cause the universe to heat up even more. Planets will first be burnt and then melted. All matter will crumple into an enormous cloud of boiling plasma. After that, atoms and subatomic particles will disperse, and eventually the universe will collapse into a singularity similar to the one it used to be when it was born. There is a theory which is a kind of a spin-off of the Big Crunch theory. It is known as the Big Bounce theory. According to the Big Bounce theory, on reaching the state of singularity following the Big Crunch, the universe will be reborn as a result of yet another Big Bang, and the cycle will repeat itself again and again, supposedly forever, as far as it is possible to speak about eternity in conditions devoid of time and space. I will repeat myself yet again by saying that our knowledge about dark energy is too meager to speak about the duration of any of these scenarios. For all we know, the next Big Rip, or Big Crunch for that matter, will take place in a period when there are still stars and planets around. But what if it isn't the case? What will happen to the universe if its ultimate fate is still extremely remote in time? Still, the laws of physics imply that the universe, as we more or less know it, cannot exist forever. There are 4 clearly defined epochs in cosmology, and each of them is associated with this or that particular phenomenon. We live in the so-called stelliferous era. There is a lot of interstellar gas in the parts of the universe around us. It is used as raw material for stars to form from. New stars are born from this gas, and the process will continue until all interstellar gas has been depleted. This epoch is expected to be over in the period from 1 to 100 trillion years from now. By that time, the Sun and the overwhelming majority of other stars will have depleted their nuclear fuel, subsequently turning into white dwarfs, neutron stars, or black holes. I've actually already spoken about it in an earlier video. The next era is known as the degenerate era. There will not be any main sequence stars around anymore. Most matter in the universe will remain in the form of white and brown dwarfs, and some matter will persist as neutron stars and black holes. It will take a great amount of time for all these objects to cool off, around a duodecillion, or 10 to the power of 39 years. White dwarfs will gradually give off their heat in the form of radiation, and become black dwarfs. As for brown dwarfs, they will cool off too. Thermonuclear reactions taking place in their interior at a sluggish rate will eventually stop completely. Gradually, most matter will be slurped by black holes. At this stage of the universe's evolution, dark matter annihilation and protons disintegration will be the major processes. The proton is a subatomic particle that atoms known to science are built of. It is considered one of the most durable subatomic particles. Its life expectancy, as it were, accounts for approximately 100 duodecillion, or 10 to the power of 41 years. Now, by the time this era comes to an end, matter in the universe will look like a great ocean of freely floating elementary particles with an occasional neutron star or black hole tucked away among them. The next era is the black hole era. According to some theories, black holes will form clusters and eventually blend together, thus forming one single gargantuan black hole. Alternative theories suggest that black holes will slowly evaporate while emitting energy before vanishing completely. Black hole evaporation is a quantum effect, produced by what is known as Hawking radiation. The smaller a hole, the more intensive its evaporation, which eventually strips the hole of all its matter and energy. This process is supposed to persist for 10 to the power of 100 years. This number is also referred to as Gugol. Be it as it may, eventually, only dead expanses of space will be left in the universe. This space will contain debris left over from processes having taken place in the previous epochs. Photons, electrons, positrons, neutrinos, and quarks. Electrons and positrons will collide, thus causing annihilation. The universe may exist in this state practically forever, until the next big crunch or big rip at the very least. Either way, the humanity will be long gone at that time. Its existence is likely to be terminated in the Stelliferous era. Our planet, meanwhile, will remain habitable for another billion years or so, and after that it will be burned by the ever-intensifying glow of the sun. About 5 or 6 billion years later, our sun, by then a red giant, will shed its outer layers and become a white dwarf. But what will happen after the universe dies? Disappointing as it is, there is absolutely no way we can answer this question. The trouble is, whatever the scenario, there won't be either time or space as we know them. Even if the Big Bounce theory or the Big Crunch theory is right, or else a new Big Bang takes place, thus giving birth to a new universe with a fresh set of galaxies and stars, we will simply never find out. Just like we will never find out what it used to be like in the universe before ours, because the word must be heard in silence. There must be darkness to see the stars. Dear friends, this amazing journey through the universe has come to an end, but there are many more discoveries to come. Billions of stars and trillions of planets still hold their secrets, and it will take a lot of time and effort to unlock them. That means that there are a lot more new educational episodes about mysteries of the universe up ahead. And let's keep in touch. But there are many more discoveries to come. Billions of stars and trillions of planets still hold their secrets, and it will take a lot of time and effort to unlock them. That means that there are a lot more new educational episodes about mysteries of the universe up ahead. And let's keep in touch.
In an age of planetary exploration, NASA's Phoenix lander descended to the Martian surface.
30 meters. Touchdown signal detected.
It soon uncovered treasure, frozen water. The red planet had remnants of water buried beneath the surface. Earth was no longer the only terrestrial world with the key ingredient to life as we know it. Throughout history, we've observed our planetary neighbors in the sky.
Human beings have looked up to the stars as long as we've been able to.
Probes and landers have ventured to other terrestrial worlds, Mercury, Venus, and Mars.
There were whole new areas in astrodynamics that had to be invented to be able to do this kind of thing.
Each journey revealed secrets of our solar system.
We actually learned a lot about Earth by looking at other planets.
And brought us closer to the possibility of alien life.
There was more and more of this history of a watery pass on Mars and an environment that could have at one time even been suitable for life.
Every mission has paved another stone on our road to an off-world colony.
The moment we step foot on an alien world, we have forever changed it.
$4.6 billion years ago, our solar system was merely a giant cloud of gas, and sprinkles of dust formed by ancient stars. But under the power of gravity, that cloud started collapsing, spinning ever faster and flattening into a disk.
Solar systems are pretty much always flat disks because when things rotate in space, they tend to flatten out.
A dense sphere of gas collected in the center. At its core, under the intense heat and pressure, hydrogen began undergoing a form of transmutation, nuclear fusion, releasing an explosion of energy that continues to this day. The sun was born. In this new solar system, small grains of dust began sticking together. Over 100 million years, a few grew massive enough that their own gravity crushed them into spheres.
The planets actually were just leftovers from the sun's formation. And slowly over time, they accumulated more and more material from the disk around the sun.
Our Our star's radiation blew away lighter gases like hydrogen and helium from the inner system. Ice was unable to form, and 4 rocky planets arose: Mercury, Venus, Earth, and Mars.
We talk about the terrestrial planets. These are the inner worlds, the rocky bodies.
While all started out with a similar evolutionary process, each reached a unique fate.
If you learn more about these terrestrial planets, you will learn more about our own history. And fundamentally, space exploration is about learning about ourselves.
The brightest planet in Earth's sky, Venus is our immediate neighbor in the solar system, at the closest possible distance of 38 million kilometers. The planet has shaped our understanding of our place amongst the universe. In the 1600s, Galileo Galilei observed Venus's phases, helping to confirm the Copernican notion that the planets orbited the Sun instead of the Earth. Humanity's comprehension of the solar system expanded over the centuries, but Venus's opaque cloud tops stirred speculation that habitable swamps or even oceans awaited below. Answers seemed in reach, with development of the first robotic visitor to another planet.
There's a way to make an entrance.
My destiny.
It was now a conspiracy of witches.
Download Veely today.
But any craft venturing beyond Earth's protective bubble would endure the dangers of interplanetary space.
A probe in space can be subjected to conditions which are far beyond anything we'll see on Earth. We're quite lucky in that Earth's atmosphere protects us from extreme temperatures or radiation from the sun.
The closer you get to the sun, the more radiation that you have. When there's a solar flare, if the sun does a bit of a hiccup, you can get really strong, powerful streams of charged particles that can actually knock out a spacecraft's electronics.
Designing probes for the space environment requires careful consideration of radiation, heat, pressure, and also temperature changes, because it's very easy to, within the life of a mission, experience very high shifts in temperature.
In the early 1960s, NASA began developing spacecraft to explore the solar system. The Mariner program consisted of 10 probes, launched over a decade, destined for the terrestrial planets.
Destruct command! Destruct command!
After Mariner 1 failed just 5 minutes after launch, hopes turned to its successor as our first emissary to Venus.
Mariner 2, a sophisticated unmanned spacecraft with orders to gather data on the planet Venus.
The second Mariner blasted off from Cape Canaveral on August 27, 1962. However, piloting a craft toward the center of our solar system came with a special challenge.
It's actually very difficult to get to the inner planets. A probe would gain so much kinetic energy. You need to be able to slow them down, or they just whiz right past.
So a spacecraft leaving the Earth's surface, relative to the Sun, it has very, very high velocity, and it's got to lose that velocity to be able to reach Venus.
Four months after leaving Earth, Mariner 2 passed Venus by, becoming our first interplanetary traveler.
Mariner 2 was the first successful flyby of anywhere in our solar system, making that journey past Venus for the very first time, looking at that cloud-covered world and getting a sense of the gases in its atmosphere.
Mariner 2 revealed a thick, crushing blanket, almost entirely composed of smothering carbon dioxide.
Venus is a inhospitable place. We wouldn't want to live there.
Sulfuric acid rains down from near hurricane speed winds. except it can't reach the surface because it's so hot.
Despite being a similar size to Earth, we had not found a twin, but a worst-case scenario of a runaway greenhouse, a build-up of heat-trapping gases that spiraled out of control.
Clouds trap heat, increasing levels of carbon dioxide from volcanoes, say. That heat in turn causes greater evaporation, more clouds.
It's now insulated and boiling at this huge temperature.
The accumulation of its thick atmosphere didn't just affect Venus's temperature and pressure. Mariner 2 confirmed that Venus spins on its axis opposite to the conventional direction of the other planets. But that may not always have been so.
We think that in the first couple of billion years after its formation, Venus was rotating in a similar way to the other planets. And then over the last few billion years, Venus has been slowing down, almost stopped, and then actually rotating in the opposite direction.
Venus's thicker atmosphere may be to blame. The Sun's gravitational influence could have pulled on it with enough force to cause the retrograde rotation.
All we know is that there is something very strange in the history of Venus. It has a very strange atmosphere, and perhaps the two are connected.
Hot on the trail of Mariner 2, the Soviets initiated the Venera program. The goal was not merely to pass Venus by, but to touch its surface.
All the while during the Cold War, where the US was aiming for the moon, the USSR was also sending missions to Venus. It's the real red planet, you might argue.
Early probes were crushed by the intense pressure before they even reached the planet's surface.
As the first missions started to go and get closer data, it became clear that Venus had an extremely challenging environment.
The next probe's parachute failed, but it reached the surface intact. Venera 7 made the first transmission from another planet's surface. The probe survived for 23 minutes before succumbing to heat and pressure.
The Venera program run by the USSR was an incredibly successful mission, actually, in terms of scientific exploration of our solar system.
The probe measured surface temperatures of 475 degrees Celsius, and scientists inferred an atmospheric pressure 91 times that of Earth's at sea level. 5 years later, in 1975, Venera 9 returned the first image from the surface of another planet. A single black and white photograph exposing a rather mundane, rocky surface.
It seemed to be an almost impossible task to be able to land probes on a surface of a world like that. But the Russians achieved it and sent back the first images of that world.
And once that mission had been successful, it was possible to design the future missions to adapt to what we now knew those surface conditions were.
The Soviets continued the Venera program into the 1980s, sending back ever more images and data.
Those images, even today, are helping us to form our understanding of that planet, even though we're only just looking at a few small areas.
Rather than focus on one small area of Venus, NASA's next mission sought to map nearly all of its surface. On May 4th, 1989, Magellan became the first deep space probe launched from a shuttle.
The advantages of launching a probe such as Magellan from the shuttle rather than from a conventional rocket are that you have a bit more control over how it sets off.
There are humans operating the shuttle, and they are able to safely check out the instrument before releasing it into space.
That allows you to really efficiently send the probe off without any difficult thrusting maneuvers or anything coming from the spacecraft itself.
We started the elevation procedures for the deploy. We went ahead and threw the switch and sent Magellan on its way.
Four months after leaving Earth, Magellan began transmitting radar images of the Venusian terrain.
Magellan spacecraft could use radar to penetrate through that blanket of cloud, to look at a surface that was totally alien. It was a world covered in volcanoes and areas of lava flows.
Mapping of Venus quickly showed that it's also active. Venus is volcanically active, it's seismically active. Processes are happening on the surface. Land is changing, land is forming.
Though some regions demonstrate geologic change and renewal, Venus's crust is hundreds of millions of years older than Earth's. Our neighboring alien world cannot recycle its rock the same way our planet does, through the movement of tectonic plates. Magellan revealed the possibility that within 2 billion years of its early history, Venus may once have been like Earth, with a liquid water ocean and habitable surface temperatures.
We think that Venus originally had an atmosphere similar to Earth, but over time the water boiled off due to the sun's radiation, because Venus is closer to the sun than the Earth, so it receives more of the sun's light.
As the sun ages, its luminosity grows, shining an ever more powerful light on the Earth. Combined with humanity's addition of greenhouse gases into the atmosphere, our planet may one day reach a similar fate.
Potentially, our Earth could go the same way. So it really makes us think about how precious our environment is.
There is a mystery with the origins of Venus that we want to understand, if only to potentially save ourselves in the future. It really is the evil twin of our Earth, and that was only revealed because of these robotic missions.
The European Space Agency's Venus Express began orbiting the planet in 2006. One of the craft's more surprising discoveries was an uncharacteristically cold region high in the planet's atmosphere, where carbon dioxide could freeze into snow. Dipping to -175 degrees Celsius, atmospheric layers like these entice astrobiologists.
The atmosphere of Venus might be home to some kind of life. It's possible. It wouldn't be anything like we think about here.
As a world of so many extremes, a myriad of mysteries remain.
Venus will retain its mysteries for a little longer, I suspect, if only because it hides them so well.
Named for the Roman god of messengers, travelers, and thieves, Mercury is the smallest planet in our solar system. At an average distance of 77 million kilometers from Earth, Mercury is the innermost world.
Mercury is a tiny planet and very close to the Sun. And the Sun has a constant stream of very hot charged particles coming off it called the solar wind. And that actually stripped away Mercury's atmosphere a very long time ago. And it's actually creating a little helium atmosphere from the gases inside the rocks on the surface of the planet.
Mercury is a world of extreme temperatures. Over 400 degrees Celsius during the day and -200 at night. Understanding this tiny world is a crucial piece in the puzzle of the terrestrial planets.
The world itself is remarkably dense.
Like Earth, Mercury's interior has layers. However, Mercury's core contains far more of the planet's mass, 85% compared to Earth's 55%.
If you think about what's underneath the ground of the Earth, or Venus or Mars, if you strip away the atmosphere and the stuff on it, this is probably the core of what a planet looks like.
It gives us a handle, a way to try to wind the clock back to those earliest days of our solar system, and that's why we're so fascinated by it.
Launched on November 3rd, 1973, Mariner 10 was the last spacecraft of the program, but the first ever probe destined for Mercury.
You've got a means of getting a tremendous amount of information that is beyond our imagination at the present point in time.
The energy costs to sink so deep into the gravitational well of the sun as Mercury resides is more costly than to go the other way to the hydro world.
There were whole new areas in astrodynamics that had to be invented, to be able to do this kind of thing.
In order to reach Mercury, Mariner 10 was the first spacecraft to employ an interplanetary slingshot maneuver. Flying first by Venus, it used the planet's gravity to decrease the size of its arc around the Sun, bending its flight path toward its target.
You have to do your rocket burns at exactly the right time. You have to alter your orbit in exactly the right amount. You have to do course correction, otherwise you can just miss.
An error of only 1 mile at Venus, if not corrected, could result in a 1,000-mile error at Mercury.
Approaching Mercury, Mariner 10 began transmitting photographs of a world pocked with massive craters, revealing more clues to the formation of our solar system.
We think that these massive craters are evidence of early bombardment. So there was a period right after the solar system formed where there was a huge amount of massive asteroids and comets which bombarded the planets.
Mariner 10 was the first spacecraft to return to its target, rendezvousing with Mercury 2 more times.
To be able to fly past the planet not once, twice, 3 times, it actually helped us learn a lot more about this gravitational slingshot maneuver, which is essential to all of the missions that we use today across the solar system. So Mariner 10 was the cornerstone of every single mission that we fly today.
Across its 3 encounters, Mariner 10 returned over 2,700 pictures of Mercury, revealing nearly half the planet's surface. Since March 1975, the spacecraft has slept soundly, still in orbit around the Sun. The next mission to the innermost world would take decades of preparation.
2, 1, and liftoff of Messenger on NASA's mission to Mercury, a planetary enigma in our inner solar system.
After a 7.9 billion kilometer journey lasting 6 years, Messenger entered Mercury's orbit in 2011.
Messenger was the first chance to actually put a spacecraft into long-term orbit around the planet Mercury, to truly map its surface.
The probe had to circle the Sun 15 times before it reached the exact speed and position to be captured by Mercury's gravity.
We got a whole world view of this planet, particularly the polar regions of Mercury, areas where there are craters that have been in shadow for billions of years.
We're seeing all kinds of evidence for volcanism, the tectonic deformation of these plains, ghost craters, which are pre-existing impact craters that were later covered over by lava.
The striking images of the planet's surface helped confirm a theory that Mercury is actually shrinking.
What we're talking about here is a phenomenon in the late stage
of the evolution of planets. Planets were very hot in the early history of the solar system, and most of that heat still has a residue in the interior of the planets.
As Mercury's interior cools, shedding the heat generated during its initial formation, the surface is pulled inward, causing the planet to shrink.
The surface is scarred, and we see those cracks and fault lines as the ground beneath the crust shrinks. This is a bizarre world, and one that is very much worthy of our attention.
Messenger's mission came to a dramatic end in 2015.
We'd like to end a mission in the most useful scientific way.
When the Messenger spacecraft ran out of fuel, it was sent on a final experiment, and that experiment was to basically self-immolate on the surface of Mercury.
While we could study Mercury from orbit and we could make some educated guesses about the density of the surface, best way to do that is to smash a spacecraft into it.
Closing in on the Mercurian surface, Messenger was able to collect data on the magnetic anomalies in the crust and ice hiding in the shadowed craters near the planet's poles. Mercury will not be alone for long. Launched in 2018, the joint European-Japanese mission, Bepi-Colombo, has been spiraling toward the innermost planet.
The missions are designed to be as wide open in terms of their capabilities as possible because we simply don't know the right questions to be asking of worlds that are as unknown as Mercury and Venus. That's what makes the exploration fun.
Mars, a world half Earth-size, hangs as a red speck in our night sky. The outermost terrestrial planet, Mars's orbit lies 78 million kilometers beyond Earth's. As telescope technology improved in the 19th century, observers began to record fascinating shapes on the Martian surface. The sketches of Italian astronomer Giovanni Schiaparelli hinted at extraterrestrial architects.
In the late 1800s, Schiaparelli made observations of Mars and drew maps of its surface. And some of the features that he saw, he labelled canali, meaning channels in Italian.
This created great excitement that we might actually have neighbours, you know. We might go to Mars and there would be other beings that we could talk to.
In the 1960s, probes to the red planet sought to separate fact from science fiction. The fourth probe of the Mariner program became Mars's first visitor. Over a few hours, Mariner 4 captured 21 complete images and a partial 22nd. But each would take nearly 9 hours to transmit back to Earth.
Hey, there she goes. Yeah. That's data.
They had to wait so long for such a small amount of data.
The figures cascade to the Earth. 240,000 bits of binary code, representing 40,000 dots that will finally make up the first picture.
They're waiting so long that they, in fact, started to colour in the pictures with pastels because to actually process that data would take even longer and they just couldn't wait.
The images did not reveal a world of extraterrestrial canals.
When Mariner 4 gave us the flyby images of Mars, it revealed a desolate landscape.
They saw dry rocks and craters and dust, and this is not at all what they expected.
And I think that may have been disappointing to the community at the time. We took for granted that the variation we see on the Earth would be found elsewhere, not realizing how unique water, and in particular life, is.
However, Mariner 4's pictures were snapped in a momentary flyby. A prolonged trip to Mars might reveal more. The penultimate Mariner mission would confirm whether or not Mars was truly uninhabitable. The Mariner 9 probe launched in May 1971.
Mariner's rocket engine will be fired for 15 minutes, slowing it by 3,500 miles per hour so it can go into orbit.
Mariner 9 became the first spacecraft to orbit another planet. The probe's instruments began to unveil the planet we know today.
In nearly a year of operation, 2 television cameras transmit more than 7,000 photographs to ensure that the entire Martian surface will be mapped.
An extraordinary world. 2 halves, the northern hemisphere almost perfectly flat, southern hemisphere heavily cratered, pockmarked highland regions, mountains, and sort of in between them is this anomaly, what we call the Tharsis Rise. It is an area where there was clearly huge amounts of volcanism in Mars's early history.
An enormous rift valley, almost 3,000 miles long. An astounding feature which no one expected on Mars.
Mars has the highest mountain in the solar system, Olympus Mons, a giant volcano. It has dust storms, it has weather in its thin atmosphere, so it really is a very active world.
We have fossilized riverbeds. There are mineral deposits that could only have formed in seas and lakes. We have features that reveal global oceans. Mars has revealed itself to be a world with a past, at least, that was water-rich.
Mariner 9 provided the first clues that waters once flowed on Mars. Humanity's first close-up examination of Mars would be facilitated by 2 identical craft, the Viking landers.
They were designed to learn as much as we could about the surface of Mars, given the technology that was available.
A small shovel on the end of a telescoping arm will scoop up some Martian soil, then drop it into a chemical analyzer on the Viking landing craft.
Vikings 1 and 2 would touch down on opposite sides of the globe.
The first photo from the Viking mission was actually of the lander's foot. That's a really interesting first image to see because it gives you scientific information as well about what the surface is like.
Look at the beautiful rock. Fantastic.
In addition to collecting photographs and measurements of the surface, the Viking landers dedicated 3 experiments toward the search for life.
The Viking spacecraft were looking to see whether there was any evidence, for example, of methanogenic microbes on Mars, microbes that would emit methane.
Were there Martians? Was there some kind of life somewhere at the surface or below the surface of that world?
Scientists concluded that the makeup of Mars's soil, coupled with solar ultraviolet radiation, restricted the formation of living organisms. But Viking's findings didn't exclude the possibility that an ancient Mars once supported life.
We don't know really where we are in the evolutionary cycle, and of course that's part of what we're trying to find out.
With the Viking missions in the 70s, they were simple landers, setting down on 2 different spots. But if you really want to explore, you need that mobility. So we had a small little rover called Sojourner, which landed with the Pathfinder mission in 1997. It showed that we could operate a small automated vehicle on the surface of Mars, but again, it couldn't go very far afield. So they decided to build two rovers with the lander and the rover as one vehicle.
The Mars Exploration Rovers were twin solar-powered robots designed to hunt for evidence that ancient Mars once held water.
They were equipped with an entire laboratory to measure the mineral content and other properties of samples that they were able to collect.
It was just transformative with having that ability to be able to just have an automated human being going around the planet.
Spirit landed in a crater which certainly showed signs of being once filled with water, but sometime in the intervening history of Mars had been covered over by a layer of lava. So Spirit had to go on a much longer journey, travelling several kilometres to reach some mountains, and literally, the moment they got out of the lava field, they found what they coined the pot of gold. Evidence that there was water in this spot billions of years ago.
Spirit found rocks rich in iron and magnesium, which could only form when Mars was wet and warm. Spirit's twin successfully landed on the other side of the planet.
The Opportunity rover, she landed in a small crater, the ultimate hole-in-one. And right in front of that rover was direct evidence that there was sedimentary layered rock, materials that can only form in the presence of long-standing water.
The puzzle pieces have been falling into place. We have concluded that the rocks here were once soaked in liquid water.
Spirit, she had to struggle for everything to achieve the goal of finding out the water history of Mars. For Opportunity, it was all laid out in front of her.
Originally slated for a 90-day mission, Spirit lasted over 6 years. Opportunity kept going for another 9 after that, traveling a total of 45 kilometers, further than any off-world rover.
Opportunity made us Martians. There's been a team of people that go to work operating the rover, and the surface of Mars has now become our neighborhood.
Mars can be both cruel and kind. They thought dust building up on the solar panels would eventually block the sunlight, and that would be the end of their mission. But those whirlwinds on Mars blew the dust away, kept the solar panels clean, allowed the rovers to drive further, to continue doing more science.
However, in 2018, a planet-wide dust storm sealed Opportunity's fate.
This dust storm, it was really sad. It actually was so huge it covered the entire planet. And then it lasted so long that Opportunity didn't have any power left.
The rest of the instruments were working fine, but if you don't have power, you can't do much else.
The last message from rover Opportunity was a message from the engineering instruments on board. And effectively it was, my battery is getting low and it's getting dark. And 15 years of operations on the surface of the Red Planet finally came to an end.
This concludes operations for MER-1 spacecraft ID 253.
Sad day for all of us.
MER project off the net.
Even without our rovers, humanity still had a close eye on the Red Planet. NASA designed the Mars Reconnaissance Orbiter, or MRO, as a next-generation eye in the sky, capturing surface features as small as a meter. It carried a novel telecommunication system that other Martian missions could use for a navigational aid. Since its arrival in March 2006, the MRO has circled the planet more than 60,000 times and sent back more data than all Mars missions combined. Its powerful camera has mapped 99% of the surface in unprecedented detail, revealing a planet that is still active and changing.
The reason we know a lot about Earth is our satellites. We can measure what happens as a planet as a whole, how it changes over time. And that's what Mars Reconnaissance Orbiter has been doing for Mars. It's been measuring changes over the planet as a whole.
Having a vehicle orbiting around Mars like the Mars Reconnaissance Orbiter with its high-resolution cameras has revealed the planet as an entire world with a diverse geology. And in some ways, it's actually got better maps of the planet Mars than we currently have for the Earth.
The MRO identified places of interest to send future landers and rovers, continuing the hunt for Martian water.
While there was very clear evidence of there being water once on the surface of Mars, we'd never really had a chance to get down there and dig it up and taste it with the instruments of a spacecraft. The Phoenix mission was landed near the northern polar regions of the Red Planet and had a digger on board.
Touchdown signal detected.
And just 6 centimeters below the surface, it came across this bright white material.
The rovers have been investigating the history of past water on the planet Mars for almost 5 years now. Phoenix is the first mission to actually touch that Martian water.
We tasted for the very first time the waters of Mars.
Water is fundamental to human life. Knowing where the water on Mars is, how much there is, and how to access it is critically important for any potential future missions.
While water is an essential ingredient to life as we know it, our robotic Martian spies have detected a chemical often created by life: methane.
The probes that we've sent there have not yet found definitive evidence of life, but there have been some close calls. There have been some signals that potentially complex organic chemicals might be there.
We have tantalizing hints of methane on Mars, and why that's important is, at least on Earth, methane is produced by living organisms. We call it a biosignature. It's entirely possible this could be geological in origin, but we may have found those first clues of life itself beyond the Earth.
The hunt for life and other mysteries Mars still holds will continue with future missions.
Where did the water go? Did it support life? Could it support life? Mars is a great example of all these big questions we have about the universe on our doorstep. And because it's on our doorstep, we can explore it more. And as we explore it more, like everything good in science, more questions arise.
We continue to probe Mars's past, hoping to understand its transformation from a primordial watery world. Our star bears some of that responsibility. In order to comprehend the mechanics of the inner planets, we need to unlock the secrets that drive the solar system. We need to study the sun.
The sun creates all the heat and light in the solar system that enables all life on Earth to exist. It's also created very extreme environments in the other terrestrial planets.
Prevented life in Mercury by stripping away its atmosphere. It prevented life on Venus by causing the evaporation of all the water and turning it into a runaway greenhouse.
Our sun produces its own weather, matter and light streaming out, influencing every orbiting body to some degree. Every so often, intense flares rise above the surface, ejecting charged particles up to 3 million meters per second. Sometimes these ejections collide with the Earth.
When you see those beautiful aurora, the northern lights or the southern lights, that is caused by solar storms, stuff leaving the sun, hitting our Earth's magnetic field, rubbing it around. Yeah, that's great, pretty pictures, but it also creates radio interference. It creates problems here on Earth.
The surge